able to look at single neurons and understand what we call intelligence. You know, to look at summing up. And the summing up is the issue here. Where, you know, one example is that the human genome, right? So there was a lot of work on excitement about sequencing the human genome because the idea would be that we'd be able to find genes that underlie diseases. But it turns out that, and it was a very reductionist idea. We figure out what all the parts are, and then we would be able to figure out which parts cause which things. But it turns out that the parts don't cause the things that we're interested in. It's like the interactions of these parts. And so that kind of reductionist approach didn't yield the explanation that we wanted.
What to you is the most beautiful, complex system that you've encountered?
Most beautiful.
That you've been captivated by? Is it sort of, I mean, for me, it's the simplest to be cellular atomic.
Oh, yeah. So I was very captivated by cellular atomic. I worked on cellular atomic for several years.
Do you find it amazing or surprising that such simple systems, such simple rules in cellular atomic can create sort of seemingly unlimited complexity?
Yeah, that was very surprising too.
How do you make sense of it? How does that make you feel? Is it just ultimately humbling, or is there a hope to somehow leverage this into a deeper understanding and even able to engineer things like intelligence?
It's definitely humbling. How humbling in that, also kind of awe-inspiring. That it's that awe-inspiring like part of mathematics that these incredibly simple rules can produce this very beautiful, complex, hard to understand behavior, and it's mysterious, and surprising still, but it's exciting because it does give you kind of the hope that you might be able to engineer complexity just from.
I'm so from the beginning. Can you briefly say what is the Santa Fe Institute, its history, its culture, its ideas, its future? So I mentioned to you, I've never been, but it's always been this, in my mind, this mystical place where brilliant people study the edge of chaos.
Yeah, exactly. So the Santa Fe Institute was started in 1984, and it was created by a group of scientists, a lot of them from Los Alamos National Lab, which is about a 40-minute drive from the Santa Fe Institute. They were mostly physicists and chemists, but they were frustrated in their field because they felt that their field wasn't approaching kind of big interdisciplinary questions like the kinds we've been talking about. And they wanted to have a place where people from different disciplines could work on these big questions without sort of being siloed into physics, chemistry, biology. So they started this institute. This was people like George Cowan, who is a chemist at the Manhattan Project, and Nicholas Metropolis, who mathematician, physicist, Uri Gelman, physicist. So some really big names here. Ken Arrow, an economist, Nobel Prize winning economist, and they started having these workshops, and this whole enterprise kind of grew into this research institute that's itself has been kind of on the edge of chaos its whole life because it doesn't have a significant endowment, and it's just been kind of living on whatever funding it can raise through donations and grants, and however it can, business associates and so on. But it's a great place. It's a really fun place to go think about ideas that you wouldn't normally encounter.
So, Sean Carroll, some physicists.
Yeah, he's on the external faculty.
And you mentioned that there's some external faculty and there's people that
A
are
very small group of resident faculty, maybe about 10, who are there for about 5-year terms that can sometimes get renewed. And then they have some postdocs, and then they have this much larger, on the order of 100, external faculty or people come, like me, who come and visit for various periods of time.
So what do you think the future of the Santa Fe Institute? Like what, and if people are interested, like what's there in terms of public interaction or students or so on that could be a possible interaction with Santa Fe Institute or its ideas?
Yeah, so there's a few different things they do. They have a complex systems summer school for graduate students and postdocs. Sometimes faculty too, and that's a 4-week, very intensive residential program where you go and listen to lectures and you do projects, and people really like that. I mean, it's a lot of fun. They also have some specialty summer schools. There's one on computational social science, one on climate sustainability, I think it's called. There's a few. And then they have short courses with just a few days, different topics. They also have an online education platform that offers a lot of different courses and tutorials from SFI faculty, including an introduction to complexity course that I taught.
Awesome. And there's a bunch of talks too on online from this guest speakers and so on. They host a lot of.
Yeah, they have sort of very technical seminars and colloquia, and they have a community lecture series, like public lectures, and they put everything on their YouTube channel so you can see it all. Watch it.
Douglas Hofstadter, author of Piano Escherbach, was your PhD advisor. You mentioned it a couple of times, working collaborator. Do you have any favorite lessons or memories from your time working with him that continues to this day? I guess, but just even looking back throughout your time working with him.
So one of the things he taught me was that when you're looking at a complex problem, to idealize it as much as possible, to try and figure out what is the essence of this problem. And this is how, like, the copycat program came to be, by taking analogy making and saying, how could we make this as idealized as possible, but still retain really the important things we want to study? And that's really kept, been a core theme of my research, I think. And I continue to try and do that. And it's really very much kind of physics inspired. Hofstadter was a PhD in physics. That's his background.
It's like first principle style thinking, like you reduce to the most fundamental aspect of the problem,
Yeah.
so that you can focus on solving that fundamental aspect.
Yeah, and in AI, that was, people used to work in these micro worlds, right? Like the blocks world was a very early, important area in AI. And then that got criticized because they said, oh, you can't scale that to a world. And so people started working on much more real world like problems. But now there's been kind of a return even to the blocks world itself. We've seen a lot of people who are trying to work on more of these very idealized problems for things like natural language and common sense. So that's an interesting evolution of those ideas.
So perhaps the blocks world represents the fundamental challenges of the problem of intelligence more than people realize.
It might.
Is there, so when you look back at your body of work in your life, you work in so many different fields, is there something that you're just really proud of in terms of ideas that you got to just explore, create yourself?
So I am really proud of my work on the Copycat project. I think it's really different from what almost everyone has done in AI. I think there's a lot of ideas there to be explored. And I guess one of the happiest days of my life, aside from my children, birth actually starting to be able to make interesting analogies. I remember that very clearly. It was a very exciting time.
Well, you kind of gave life
Yes,
artificial system.
that's right.
What in terms of what people can interact? I saw there's like these called Metacat, and there's a Python 3 implementation. If people actually want to play around with it and actually get into it, study and maybe integrate into whether it's deep learning or any other kind of work they're doing, what would you suggest they do? Learn more about it and to take it forward in different kinds of directions.
Yeah, so that there's Douglas Hofstadter's book called Fluid Concepts and Creative Analogies. Talks in great detail about copycat. I have a book called Analogy Making as Perception, which is a version of my PhD thesis on it. There's also code that's available. You can get it run. I have some links on my webpage to where people can get the code for it. And I think that would really be the best way to get into it. Yeah.
Play with it. Well, Melanie, it was an honor talking to you. I really enjoyed it. Thank you so much for your time today.
Thanks. It's been really great.
Thanks for listening to the conversation with Melanie Mitchell. And thank you to our presenting sponsor, Cat App. Download it, use code Lex Podcast. You'll get $10. $10 will go first. A STEM education nonprofit that inspires hundreds of thousands of young minds to learn and to dream of engineering our future. Enjoy this podcast. Subscribe on YouTube. Give it 5 stars on Apple Podcasts. Support it on Patreon. And connect with me on Twitter. And now, let me leave you with some words of wisdom from Douglas Hofstadter and Melanie Mitchell. Without concepts, there can be no thought. Without analogies, there can be no concepts. And Melanie adds, how to form and fluidly use concepts is the most important open problem in AI. Thank you for listening. I hope to see you next time. Following the conversation with Donald Knuth, one of the greatest, most impactful computer scientists and mathematicians ever. He's the recipient of the 1974 Turing Award, considered the Nobel Prize in Computing. He's the author of the multi-volume work, The Magnum Opus, The Art of Computer Programming. He made several key contributions to the rigorous analysis of computational complexity of algorithms, including the popularization of asymptotic notation, that we all affectionately know as the Big O notation. He also created the typesetting system, which most computer scientists, physicists, mathematicians, and scientists and engineers in general use the right technical terms to make them look beautiful. You can imagine no better guest than 2019 would have been Don, one of the kindest, most brilliant people in our field. This podcast was recorded many months ago. It's one I avoided because, perhaps counterintuitive, the conversation meant so much to me. If you can believe it, I knew even less about recording back then, so the camera angle is a bit off. I hope that's okay with you. The office space was a bit cramped for filming, but it was a magical space where Don does most of his work. It meant a lot to me that he would welcome me into his home. It was quite a journey to get there. As many people know, he doesn't check email, so I had to get creative. The effort was worth it. I've been doing this podcast on the side for just over a year. Sometimes I had to sacrifice a bit of sleep, but always happy to do it and to be part of an amazing community of curious minds. Thank you for your kind words of support, for the interesting discussions, and I look forward to many more of those in 2020. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, give 5 stars on Apple Podcasts, follow on Spotify, support on Patreon, or simply connect with me on Twitter at Lex Friedman, spelled Fridman. I recently started doing ads at the end of the introduction. I'll do 1 or 2 minutes after introducing the episode, and never any ads in the middle to break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. I provide timestamps for the start of the conversation that you can skip to, but it helps if you listen to the ad and support this podcast by trying out the product or service being advertised. This show is presented by Cash App. number one finance app in the App Store. I personally use Cash App to send money to friends, but you can also use it to buy, sell, deposit Bitcoin in just seconds. Cash App also has a new investing feature. You can buy fractions of stock, say $1 worth, no matter what the stock price is. Brokerage services are provided by Cash App Investing, subsidiary of Square, member SIPC. I'm excited to be working with Cash App to support one of my favorite organizations called First, best known for their First robotics and Lego competition. They educate and inspire hundreds of thousands of students in over 110 countries and have a perfect rating at Charity Navigator, which means the money is used with maximum effectiveness. When you get Cash App from the App Store or Google Play and use code LEXPODCAST, you'll get $10. Cash App will also donate $10 to First, which again is an organization that I've personally seen inspire girls and boys to dream of engineering a better world. And now, here's my conversation with Donald Knuth. In 1957, at K-Tech, you were once allowed to spend several evenings with a IBM 650 computer, as you've talked about in the past, and you fell in love with computing then.
Yeah.
Can you take me back to that moment with the IBM 650? What was it that grabbed you about that computer?
So the IBM 650 was this machine that well, it didn't fill a room, but it was big and noisy. But when I first saw it, it was through a window and there was a lot of lights right. And I was a freshman. I had a job with the statistics group, and I was supposed to punch cards and for data and then sort them on the machine. They got this new computer came in, and it had interesting lights. Okay, so well, but I had a key to the building, so I could get in and look at it and got a manual for it. And my first experience was based on the fact that I could punch cards. Basically, it was a big thing for but the IBM 650 was big in size, but incredibly small in power in memory. It had 2,000 words of memory, and the word of memory was 10 decimal digits plus a sign. And it would do, to add two numbers together, you could probably expect that would take, let's say 3 milliseconds. So
that's pretty fast. It's the memory is the constraint. The memory is the problem.
that was why it took 3 milliseconds, because it took 5 milliseconds for the drum to go around. And you had to wait, 5 cycle times. If you have an instruction, what position on the drum, then it would be ready to read the data for the instruction. 3 notches. Drum is 50 cycles around, and you go 3 cycles, and you get the data, and then you do another 3 cycles, so you get to the next instruction. If the instruction is there, otherwise you spin until you get to the right place. And we had no random access memory whatsoever until my senior year. In senior year, we got 50 words of random access memory, which were priceless. We could move stuff up to the random access memory in 60-word chunks, and then we store it again. So if you want to go up there.
Could you have predicted the future 60 years later of computing from that?
In fact, the hardest question I've ever asked was, what could I have predicted? Now, the interviewer asked me, she said, what computing has surprised me? And I rattled off a couple dozen things, and then she said, okay, so what didn't surprise you? And I tried for 5 minutes to think of something that I would have predicted, and I couldn't. But let me say that this machine, I didn't know. Well, there wasn't much else in the world at that time. The 650 was the first machine that there were more than 1,000 out there. And before that, there were each machine there would be a half a dozen examples.
The first mass market, mass produced.
The first one, done in quantity, and IBM didn't sell them; they rented them, but they rented them to universities at great had a great deal. And so that's why a lot of students learned about computers at that time.
So you refer to people, including yourself, who gravitate toward a kind of computational thinking as geeks. At least I've heard you use that terminology.
It's true that I think there's something that happened to me as I was growing up that made my brain structured in a certain way that resonates with computers.
So there's this space of people, 2% of the population, you empirically estimate.
That's it's been fairly constant over the rest of my career. However, it might be different now because kids have different experiences when they're young.
So what does the world look like to a geek? What is this aspect of thinking that is unique to that makes a geek?
This is a hugely important question. In the 50s, IBM noticed that there were geeks and non-geeks, and so they tried to hire geeks, and they put out ads with papers saying, if you play chess, come to Madison Avenue for an interview or something like that. So they were trying for something. So what is it that I find easy and other people tend to find harder? And I think there's two main things. One is this really to jump levels of abstraction. So you see something in the large, and you see something in the small, and you pass between those unconsciously. So you know that in order to solve some big problem, what you need to do is add one to a certain register, and it gets you to another step. I don't go down to the electron level. I knew what those milliseconds were, what the drum was like on the 650. I knew how I was going to factor a number or find an equation or something because of what I was doing. And as I'm debugging, I'm going through, did I make a key punch error? Did I write the wrong instruction? Did I have the wrong thing in the register? And each level is different, and this idea of being able to see something at odds of levels and what you go between seems to me to be more pronounced, much more pronounced in the people that resonate with computers like that. So in my books, I also take just to the high level, but I mix low level stuff with high level, and this that I should write better books, and probably true, but other people say, well, but that's if you think like that, then that's the way to train yourself. Keep mixing the levels and learn more and more how to compete. So that's the one thing. The other thing is that it's more of a talent to be able to deal with non-uniformity, where there's case 1, case 2, case 3, instead of having 1 or 2 rules that govern everything. So it doesn't bother me if I need like an algorithm that has 10 steps to it. Each step does something else. That doesn't bother me. But a lot of pure mathematics is based on 1 or 2 rules, which are universal, and so this means that people like me sometimes work with systems that are more complicated than necessary because it doesn't bother us that we do figure out the simple rule.
And you mentioned that while Jacobi, Boole, Abel, all the mathematicians in the 19th century may have had symptoms of geek, the first 100% legit geek was Turing, Alan Turing.
I think he had a lot more of this quality than anybody, just from reading the kind of stuff he did.
So how does Turing, what influence has Turing had on you? in your way of thinking?
so I didn't know that aspect of him until after I graduated some years. As an undergraduate, we had a class that talked about computability theory and Turing machines, and it was all, it sounded like a very specific kind of purely theoretical approach to this stuff. So how old was I when I learned that he had design, which was and he wrote a wonderful manual for Manchester machines, and he invented these subroutines, and he was a real hacker that he got his hands dirty. So I thought for many years that he hadn't done purely formal work. As I started reading his own publications, I could, I could feel this kinship, and of course he had a lot of securities that he wrote numbers backwards because left to right, so right to left, because that's it was easy for computers to process it that way.
What do you mean left to right?
He would write pi as 9, 5, 1, 4.3.
Right, got it.
Or 1. On the blackboard, I mean, he got trained himself to do that because the computers he was working with worked that way inside.
Train himself to think like a computer. Well, there you go. That's deep thinking. You've practiced the most elegant formalism in science, and yet you're the creator of a concept like literate programming, which seems to move closer to natural language type of description of programming.
Yeah, absolutely.
So how do you see those two as conflicting, as the formalism of theory and the idea of literate programming?
So here we are in a non-uniform system. I don't think one size fits all, and I don't think all truth lies in one kind of expertise. So somehow, the way you say my life is a convex combination of English and mathematics.
And you're okay with that?
And not only that, I wish I want my kids to be that way. I want them, etc.
Yeah.
You start brain and right brain at the same time, you get a lot more done. That's part of the problem.
And I've heard that you didn't really read for pleasure until into your 30s. And literature.
You know more about it than that, but I'll try to be consistent.
Yeah, no, just believe me. Just go with whatever story I tell you. It'll be easier that way. The conversation.
Right, yeah. No, that's
So I've heard mention of Philip Roth's American Pastoral, which I love as a book. I don't know if it was mentioned as something I think that was made to you as well. In either case, what literary books had a lasting impact on you? What literature?
yeah. So I met Roth. Well, we both got doctors from Harvard on the same day. So we had lunch together and stuff like that. And once you do that, computer books would never sell. All right. So you were a teenager when you left Russia. So I have to say that Tolstoy is one of the big influences. I especially like Anna Karenina, not because particularly of the plot of the story, but because there's this character who the topical discussions. It's the whole way of life. It's looked out there among the characters, and so that I thought was especially beautiful. On the other hand, Dostoevsky, I didn't like at all because I felt that he was mostly because he kept saying what he was trying to do, and he was just smart. I didn't think that he polished his stuff at all, and I tend to admire somebody who types the eyes, crosses the T's.
So the music of the pros is what you admire more than.
I certainly do admire the music of the language, which I couldn't appreciate in the Russian original, but I can in Hebrew, that's called French. But Tolstoy I like the same reason I like Herman Wouk as a novelist. I think like his book Marvin Morningstar has a similar character and hero who developed his own personal philosophy and
It's consistent.
yeah, right.
Yeah.
And it's worth talking about. So,
So you don't like Nietzsche and
like what?
you don't like Friedrich Nietzsche or
Nature, yeah, no, yeah. I keep seeing quotations from Nietzsche, and you never tempt me to read any.
well, he's full of contradictions. You will certainly not appreciate him.
But sure, I'm trying to get across what I appreciate and live. And part of it is as you say, the music of the language, the way it flows. And take Raymond Chandler versus Dashiell Hammett. Dashiell Hammett's sentences are awful. Raymond Chandler's are beautiful. They just flow. So I don't read literature because it's supposed to be good for me. Because somebody said it's great, but I find things that I like. You mentioned you were dressed like James Bond. So I love Ian Fleming. I think he's got a really great gift. If he has a golf game or a game of bridge or something, and it comes into a story, it'll be the most exciting golf game or the absolute best possible hand of bridge that exists, and it exploits it and tells it beautifully.
So in connecting some things here, looking at literary programming and being able to convey, encode algorithms to a computer in a way that mimics how humans speak. What do you think about natural language in general and the messiness of our human world, about trying to express difficult things?
So the idea of literary programming is you get to try to understand something better by seeing it from these two perspectives, the formal and the informal. We're trying to understand a complicated thing if we can look at it in different ways. So this is in fact a key technical writing. A good technical writer trying not to be obvious about it, but says everything twice, formally and informally, maybe three times, but try to give the reader a way to put the concept into his own brain.
Is that better for the writer or the reader or both?
Well, the writer just tries to understand the reader. That's the goal of the writer, is to have a good mental image of the reader, and to say what the reader expects next, and to impress the reader with what has impressed the writer, why something is interesting. So when you have a computer program, you try to, instead of looking at it as something that we're just trying to give instruction to the computer, what we really want to be is giving insight to the person who's going to be maintaining this program, or to the programmer himself when he's debugging it, as to why this stuff is being done. And so all the techniques of exposition that a teacher uses or a book writers make a better program if your program is going to be just a one-shot deal.
So how difficult is that? Do you see hope for the combination of informal and formal for the programming task?
Yeah, you're the wrong person to ask, I guess, probably every geek, but I think for a geek, some people have difficulty writing, and it might be because there's something in their brain structure that makes it hard for them to write. or it might be something just that they haven't had enough practice. I'm not the right one to judge, but I don't think you can teach any person any particular skill. I do think that writing is half of my life, and so I put it together in the program. Even when I'm writing a program, I write it a little bit way because I get it right faster than.
Now, does it get compiled automatically, or so? I guess on the technical side, my question was, how difficult is it to design a system where much of the programming is done informally?
Informal.
Yeah, informal.
I think whatever works to make it understandable is good. But then you have to also understand how informal it is. You have to know the limitations. So by putting the formal and informal together, this is where it gets locked into your brain. You could say informally, well, right now. So
Let's go there. Can you give me an example of connecting the informal and the formal?
well, too complicated an example. There's a puzzle that's self-referential. It's called the Japanese arrow puzzle, and you're given a bunch of boxes, each one points north, each south, or west. And at the end, you're supposed to fill in each box with the number of distinct numbers that it points to. So if I put a 3 in a box, that means that and it's pointing to 5 other boxes. That means that there's going to be 3 different numbers in those 5 boxes. And those boxes are pointing. One of them might be pointing to me, one of them might be pointing the other way. But anyway, I try and find a set of numbers that obeys this complicated condition that each number counts how many distinct numbers it points to. Well, so the guy sent me his solution to this problem where he presents formal statements that say either this is true or this is true or this is true. And so I try to render that formal statement informally, and I try to say, I contain a 3, and the guys I'm pointing to contain the numbers 1, 2, and 6. So by putting it informal, I convert it into a dialogue statement. That helps me understand the logical statement that he's written down to string a number in terms of some abstract variables that he has.
That's really interesting. So maybe an extension of that, there has been a resurgence in computer science and machine learning and neural networks. So using data to construct algorithms. So it's another way to construct algorithms, right?
Yes.
You can think of it that way.
Yeah.
So as opposed to natural language to construct algorithms, use data to construct algorithms. So what's your view of this branch of computer science, where data is almost more important than the mechanism of the algorithm?
It seems to be suited to a certain kind of non-geek, and which is probably why it's taken off and has its own community. But that really resonates with that. But it's hard to trust something like that because nobody, even the people who work with it, they have no idea what has been learned.
That's a really interesting thought. That it makes algorithms more accessible to a different community, a different type of brain.
Yep.
And that's really interesting because just like literate programming, perhaps could make programming more accessible to a certain kind of brain.
There are people who think it's just a matter of education, and anybody can learn to be a great programmer. Anybody can learn to be a great skier. I wish that were true, but I know that there's a lot of things that I've tried to do, and I was well motivated. And I keep trying to I can't do three-dimensional objects in my head. I have to make a model and look at it and study it for about 20 years. And I start to get some idea of what other people are good at four dimensions.
Physicists.
Yeah.
So let's go to the art of computer programming. In 1962, you set the table of contents for this magnum opus, right?
Yep.
It was supposed to be a single book, 12 chapters. Now today, what is it, 57 later, you're in the middle of volume 4.
In the middle of volume 4B, it's
4B.
more precisely.
Can I ask you for an impossible task, which is try to summarize the book, maybe by giving up a little examples. So from the sorting and the search and the combinatorial algorithm, you were to give a summary, a quick elevator summary, but depending how many floors there are in the building.
Yeah. The first volume called Fundamental Algorithms talks about something that the stuff you can't do without. You have to know some basic concepts of what is a program, what is the algorithm, and it also talks about a low-level machines that have some kind of idea of what's going on, and it has basic concepts of input-output, substitutes, induction, right? So mathematical preliminary. So the thing that makes my book different from a lot of others is that I try to not only present the algorithm, but I try to analyze it, which means quantitatively. I say not only does it work, but it works this fast. Okay, and so I need and then there's a standard way to structure data inside and represent information in the computer. So that's all volume 1. Volume 2 is called semi-numerical algorithms, and here we're writing programs, but we're also dealing with numbers. The algorithms deal with any kinds of objects, but so when there's objects on numbers, well then we have certain special paradigms that apply to things that have 12 numbers, and so there's arithmetic of numbers, and there's matrices full of numbers, there's random numbers, and there's power series full of numbers. There's different algebraic concepts that have numbers in structured ways.
And arithmetic and the way a computer would think about arithmetic. So floating point
arithmetic, high precision arithmetic, not only addition, subtraction, multiplication, but also comparison. So then volume 3 talks about.
I like that one. Sorting and search.
Sorting and search.
I love sorting.
Right. So here, we're not getting necessarily numbers because we sort letters and other objects. In searching, we're doing all the time with Google nowadays. But I mean, we have to find stuff. So again, algorithms that underlie all kinds of applications. None of these volumes is about a particular application, but the applications are examples of why people want to know about sorting. So then volume 4 goes into combinatorial. This is where we have zillions of things to deal with, and here we keep finding cases where one good idea can make something go more than a million times faster, and we're dealing with problems that are probably never going to be solved efficiently. But that doesn't mean we give up on it, and we have this chance to have good ideas and go much, much faster. So that's combinatorial algorithms, and those are the ones that are, you say, sorting is most fun to do.
Well, like satisfiability
but
too.
Combinatorial algorithms are the ones that I always enjoyed the most, because that's when my skill at programming had the most payoff. And the difference between an object-based algorithm that you think up first thing and interesting subtle algorithm that's not so obvious, but and circles around the other one. That's where computer science really comes in. And a lot of these combinatorial methods were found first in applications to artificial intelligence or cryptography. And in my case, I just liked them and associated more positives.
Do you like the most in the domain of graphs and graph theory?
Graphs are great because they're perfect models of so many things in the real world. And throw numbers on a graph and you've got a network, and so right there you have many more things. So, but combinatorial in general is in a arrangement of objects that has some kind of a higher structure, not random structure. It's okay. It's possible to put something together satisfying all these conditions, like you should arrows in the middle and to put these numbers on a bunch of boxes that according to attributes that can be possible.
That's volume 4.
That's volume 4.
The
The
future
volume 4A was part 1. And what happened was in 1962, when I started writing down a table of contents, it wasn't going to be a book about computer programming in general. It was going to be a book on how to write compilers. And I was asked to write a book explaining how to write a compiler. And at that time, there were only a few dozen people in the world who had written a compiler, and I happened to be one of them. So, and I also had some experience writing for like the campus newspaper, things like that. So I thought, okay, great. I'm the only person I know who's written a compiler but hasn't invented any new techniques for writing compilers. All the other people I knew had super ideas, but you see that they would be able to put that to describe anybody else's ideas with their own. So I could be the journalist, and I could explain what all these cool ideas about compiler writing were. And then I started putting down, well, yeah, let me.
Hello. Hey, how are you? Can you hear me? Hello.
A chapter about data structure. We should maybe have something about the material you want to talk about searching because a compiler writer has to look up the variables in a single table and find out which when you write the name of the variable in one place, it's supposed to be the same as the one you put somewhere else. So you need all these basic techniques, and I put in those some arithmetic and stuff. So I threw in these chapters, and I threw in a chapter on combinatorics because that was what I really enjoyed programming the most. But there weren't many algorithms known about combinatorial methods in 1962. So that was a kind of a short chapter, but sort of throwing just for fun. And chapter 12 was going to be compilers, applying all the stuff in chapters 1 to 11 to make compilers. Well, okay, so that was my table of contents from 1962. And during the 70s, the whole field of combinatorics went through a huge explosion. People talk about a combinatorial explosion, and they usually mean by that the number of cases goes up. N plus 1, and all of a sudden the problem has more than 10 times harder. But there was an explosion of ideas about combinatorics in the 70s to the point that like 1975, I bet you more than half of all the journals of computer science were about combinatorial methods.
And what kind of problems were occupying people's minds? What kind of problems in combinatorics? Was it such a satisfiability, graph theory?
Yeah, graph theory was quite dominant in that. But all of the NP hard problems that you have, like Hamiltonian path, going beyond, going beyond graphs, you have operation research. Whenever there was a small class of problems that had efficient solutions, and they were socially made for either a special mathematical construction. But once we went to things that involved three things at a time instead of two, all of a sudden things got harder. So we had satisfiability problems. You know, if we have clauses, and the clause has two logical elements in it, then we can satisfy it in time. We test for satisfiability in time, but if you just have three variables in the clause, then nobody knows how to do it. So these articles were about trying to find better ways to solve cryptography problems and graphing problems. Where we have lots of data, but we don't know how to find the best subsets of the data, like sorting it. We get the answer to take on.
So how did it continue to change from the 70s to today?
Yeah, so now there may be half a dozen conferences whose topic is combinatorics, different kind, but fortunately I don't have to rewrite my book every month, like I had to in the 70s. But still, there's a huge amount of work being done on duplicating better ideas on these problems that don't seem to have really efficient solutions, but still do a lot more with it. So this book that I'm finishing now is, I've got a whole bunch of brand new methods that, as far as I know, there's no other book that covers this particular approach, and so I'm trying to do my best of exploring the tip of the iceberg, and I try out lots of things and keep rewriting as I find better methods.
So what's your writing process like? What's your thinking and writing process like every day?
So
what's your routine even?
I guess it's actually the best question, because I spend 7 days a week programming.
You're the most prepared to answer it.
Yeah, but okay. So the chair I'm sitting in is where I do.
Where the magic happens.
Well, reading and writing, but the chair's usually sitting over there where I have some reference. But I found this chair, which was designed by a Swedish guy anyway. Turns out this is the only chair I can really sit in for hours and hours and not know that I'm in the chair. But then I have the stand-up desk right next to us, and so after I write something with a pencil and eraser, I get up and I type it and revise and write.
The kernel of the idea is first put on paper.
Yeah.
That's where.
And I'll write maybe 5 programs a week, of course, unit programming. And these are, before I describe something in my book, I always program it to see how it's working and I try it. So, for example, I learned at the end of January, I learned a breakthrough by 4 Japanese people who had extended one of my methods in a new direction. And so I spent the next 5 days writing a program to implement what they did, and then they had only generalized part of what I had done, so then I had to see if I could generalize more parts of it, and then I had to take their approach and I had to try it out on a couple of dozen of the other problems I had already worked out with my old methods. And so that took another couple of weeks, and then I tried to see the light, and I started writing the final draft, and then I would type it up. It involved some new mathematical questions, and so I wrote to my friends who might be good at solving those problems, and they solved some of them. And so I put that in as exercises, and so a month later, I had absorbed one new idea that I learned, and I'm glad I heard about it in time. Otherwise, I would put my book out before I heard about the idea. On the other hand, this book was supposed to come in at 300 pages, and I'm up to 350 now. It added 10 pages to the book. But if I learn about another one, I probably should finish it.
Well, So in the process, in that 1 month process, are some days harder than others?
Some days harder than others. But yeah, my work is fun, but I also work hard, and every big job has parts that are a lot more fun than others. And so many days I'll say, why do I have to have such high standards? Why couldn't I just be sloppy and not try this out and just record the answer? But I know that, that people are telling me to do this, and so okay, Don, if you can do it, and then the joy comes out when I see that actually I'm getting good results, and, and even more when I see that somebody has actually read and understood what I wrote and told me how to make it even better. I did want to mention something about the method. So I got this tablet here where I do the first writing of class. So
And what language is that?
all right, so take a look at it. Here, Ryan said, explain how to draw such 3 pixel diagrams. Okay, so I got this paper about 40 years ago when I was with my sister in Canada, and we make tablets of paper with just nice large size and just right.
Very small space between lines.
Oh,
You mind if I
yeah.
maybe
So yeah. I've got these manuscripts going back to the 60s, and those are when you get my ideas on paper. Okay. But I'm a good typist. In fact, I went to typing school when I was at school, so I can type faster than I think. So then when I do the editing, stand up and type, then I revise this, and it comes out a lot different than what for style and rhythm and things like that come out at the typing speed.
and you type in text.
And I type in text.
And can you think in text? So
to a certain extent, I have only a small number of idioms that I use, like getting a theorem, I do something for discrete equation, I do something, and so on. But I have to see it, and
in the way that it's on paper.
Yeah, right.
For example, Turing wrote with the other direction. You don't write macros, and you don't think in macros.
Not particular. When I need a macro, I'll go ahead and do it. But the thing is that I also write to fit. I mean, I'll change something if I can save a line. Like haiku. I'll figure out a way to rewrite the sentence so that it'll look better on the page. And I shouldn't be wasting my time on that, but I can't resist because I know it's only 3% of the time, something like that.
And it could also be argued that that is what life is about.
Yes, in fact, that's true. Like I work in the garden one day a week, and that's kind of a description of my life, is getting rid of weeds, moving those programs.
So, a lot of writers talk about, basically suffering, the writing processes, having, it's extremely difficult. And I think of programming, especially, or technical writing that you're doing, can be like that. Do you find yourself, methodologically, how do you every day sit down to do the work? Is it a challenge? You kind of say it's, it's fun, but it'd be interesting to hear if there are non-fun parts that you really struggle with.
Yeah, so the fun comes when I'm able to put together ideas of two people who didn't know about each other, and so I might be the first person that saw both of their ideas, and so then then I get to make a synthesis, and that gives me a chance to be creative. But the direct work is where I've got to chase everything down to its root. This leads me into really interesting stuff. I mean, I learned about Sanskrit, and I try to give credit to all the authors, and so I write to people who know the people, the authors of there. I communicate this way. And I got to get the math right, and I've got to tackle all my programs, try to find holes in them. And I rewrite the programs after I get a better idea.
Is there ever dead ends?
That ends, oh yeah, I throw stuff out, yeah. But one of the things that I spent a lot of time preparing a major example based on the game of baseball. And I know a lot of people who baseball is the most important thing in the world, but I also know a lot of people who cricket is the most important in the world, or soccer or something, and I realized that if I had a big example, I'm just going to have a fold-out illustration of everything. I was saying, well, what am I really teaching about algorithms here? I had this baseball example, and if I was the person who know only cricket, what would they think about this? So I ripped the whole thing out, but I had something that would really appeal to people with baseball as a major theme in their life.
There's a lot of people, but
just, yeah,
so a small minority.
Small minority. I took out bowling too.
Even a smaller minority. So what's the art in the art of programming? Why is there, of the few words in the title, why is art one of them?
Yeah, well, that's what I wrote my Turing lecture about. And so when people talk about art, what the word means is something that's not in nature. So artificial intelligence, that art comes from that same root, saying that this is something that was created by human beings. And then it's got, further meaning often in fine art, which has this beauty to the mix. And so we have things that are artistically done, and this means not only done by humans, but also done in a way that's elegant and brings joy, and has I guess that Tolstoy versus Dostoevsky.
Right.
But anyway, it's a part that says that it's done well, as well as not only different from nature. In general, then art is what human beings are specifically good at. Is they artificial intelligence, well, they're trying to mimic human beings.
But there's an element of fine art and beauty. You are one.
That's what I try to also say, that you can write a program and make it work of art.
So now, in terms of surprising, what ideas in writing from sort of research to combinatorial algorithms, what ideas have you come across that were particularly surprising to you, that changed the way you see a space of problems?
I get a surprise every time I have a bug in my program. Okay, but that isn't really what you're
More transformational.
Right, so volume 4A, I was especially surprised when I learned about data structure called BDT, Boolean Decision Diagram, because I sort of had the feeling that as an old timer, and might be programming since the 50s, and BDTs were invented in 1986. And here comes a brand new idea that's revolutionized the way to represent a Boolean function. And Boolean functions are so basic to all kinds of things. Logic is underlies it. Everything we can describe all of what we know in terms of logic somehow, and operational logic. I thought that was a cut dry and everything's known, but here comes Randy Bryant and discovers that BDTs are incredibly powerful. Then so that means I have a whole new section that I never would have thought of until 1986, not until 1990s when people started to use it for $1 billion application. And it was the standard way to design computers for a long time until SAT solvers came along in the year 2000. So that's another great big surprise. So a lot of these things have totally changed the structure of my book. And the middle favorite volume 4B is about SAT solvers, and that's 300 plus pages, which is all about material, mostly about material that was discovered in this century. And I had to start from scratch, meet all the people who write like 15 different sets out that I wrote about preparing that. 7 of them are described in the book, others were from my own experience.
So really, like the data structures or ways to represent
A whole new class of algorithm.
whole new class.
And the interesting thing about the BDDs was that the theoreticians started looking at it and started to describe all the things you couldn't do with BDD. And so they were getting a bad name because okay, they were useful, but they didn't solve everything. I'm sure that the theoreticians are in the next 10 years are going to show why machine learning doesn't solve everything. But I am not only worried about the worst case, I get a huge delight when I can actually solve a problem that I couldn't solve before. Even if I can't solve the problem that it suggests as a further problem, I know that I'm way better than I was before. So I found out that BDTs do all kinds of miraculous things. And so I have spent quite a few years learning about that territory.
So in general, what brings you more pleasure? Like proving or showing a worst case analysis of an algorithm, or showing a good average case, or just showing a good case that something good pragmatically can be done with this algorithm.
Yeah, I like a good case that is maybe only a million times faster than I was able to do before. And not worry about the fact that it's still going to take too long if I double the size of the problem.
So that said, you popularized the asymptotic notation for describing running time. Obviously, in the analysis of algorithms, worst case is such an important part. Do you see any aspects of that kind of analysis is lacking? And notation too.
Well, the main purpose is to have notations that help us for the problem we want to solve, and so that they match our intuitions. And people who work in number theory have used asymptotic notation in a certain way, but it was unknown to a small group of people. And I realized that, in fact, it was very useful to be able to have a notation for something that we don't know exactly what it is, but we only know partially about it. For example, instead of big O notation, this is much simpler. I'd say 0, 1, 0, 1, or 2. And suppose that when I had been in high school, we were allowed to put in the middle of our formula x plus 0, 1, or 2 equals okay. And then we need to multiply two such expressions together and deal with them. Well, the same thing, big O notation said use something that's I'm not sure what it is, but I know it's not too big. I know it's not bigger than some constant times n squared or something like that. So I write big O of n squared. Now I learn how to add big O of n squared to big O of n cubed, and I know how to add big O of n squared to plus 1 and square that, and how to take logarithms and exponentials and add big O's in the middle. And that turned out to be hugely valuable.
So I have there been algorithms in your journey that perform very differently in practice than they do in theory?
Well, the worst case of a combinatorial algorithm is almost always horrible. But the XF solvers that are shown were one of the last exercises in that part of my book was to figure out a problem that has 100 variables that's difficult for a set solve. But you would think that a problem with 100 variables has requires you to do 2 to the 100th operations, because that's the number of possibilities when you have 200 variables. And 2 to the 100th. 2 to the 100th is way bigger than we can handle. 10 to the 17th is a lot.
You've mentioned over the past years that you believe P may be equal to NP, but that it's not really, if somebody does prove that P equals NP, it will not directly lead to an actual algorithm to solve difficult problems. Can you explain your intuition here? Has it been changed? And in general, on the difference between easy and difficult problems of P and NP and so on?
Yeah, so the popular idea is if an algorithm exists, then somebody will find it. And it's just a matter of writing it down. But many more algorithms exist than anybody can understand or
Discover, yeah.
just way beyond human comprehension. But the problem with algorithms is more than mind-boggling. So we have situations now where we know that algorithms exist, but we don't know. We're doing the hardest looking what the algorithms are. There are simple examples based on game playing where you have where you say, well, there must be an algorithm that exists to win in the game of hex, because for the first player to win in the game of hex, because hex is always either waiting for the first player or the second player.
Well, what's the game of hex?
There's a game of hex which is based on putting pebbles onto a hexagonal board, and the white player tries to get a white path from left to right, and the black player tries to get a black path from bottom to top.
And how does capture occur?
And there's no capture. You just put pebbles down one at a time. But there's no draws, because after all the white and black are played, there's either going to be a white path across to west or a black path from bottom to top. So there's always, it's a perfect information game. People take turns like tic-tac-toe. And or it can be different sizes. But there's no possibility of draw. And players move one at a time. And so it's got to be either the first player winner or second player winner. Mathematically, follow out all the trees, and there's always room for second player. And it's finite. The game is finite. So there's an algorithm that will decide. You can show it has to be one or the other, because the second player could mimic the first player with kind of a pairing strategy. And so you can show that it has to be one. It has to be. We don't know any other. In other words, there are cases where you can prove the existence of the solution, but nobody knows anyway how to find it. But more like the algorithm question. There's a very powerful theorem of graph theory by Robinson and Seymour that says that every class of graphs that's closed undertaking minors has a boundary tank algorithm to determine whether it's in this class or not. Now, class of graphs, for example, planar graphs, these are graphs that you can draw in a plane without crossing lines. And a planar graph, taking minors means that you can shrink an edge into a point, or you can delete an edge. Right? And so you talk about a planar graph, or shrink an edge from points to plane, delete an edge. Okay. Now, but there are millions of different ways to just family of graph that still remains the same under taking money. And Robertson and Cuba proved that any such family of graphs, there is a finite number of minimum graphs that are obstructions. So that if it's not in the family, then it has to contain, then there has to be a way to shrink it down until you get one of these bad genes. In the case of a planar graph, the minimum graph is a 5-pointed star with everything pointing to another, and the minimum graph consists of trying to connect 3 utilities to 3 houses without crossing lines. And so there are 2 bad graphs that are not planar. And every non-planar graph contains one of these 2 bad graphs by shrinking and
Sorry, can you say that again? So, if you prove that there's a finite number of these bad graphs,
so I can find it. So somebody says, here's a family of,
it's hard to believe.
and they prove that this sequence of 20 papers I make, and it's deep work, but it's
Because that's for any arbitrary class. So it's for
any arbitrary class that's closed under taking money.
It's closed under. Maybe I'm not understanding because it seems like a lot of them are closed under taking money.
Almost all the important class graphs are. There are tons of such graphs, but also hundreds of them that arise in applications. I have a book over here called Classes of Graphs, and it's amazing how many different classes of graphs that people have looked at.
Why do you bring up this theorem, or this proof?
So now there's lots of algorithms that are known for special classes of graphs. So if I have a colored graph, then I can color it efficiently. If I have some kind of graphs, it will make a great network. So like test. If somebody gives you a graph, oh, it's in this family of graphs. If so, then I can go to the library and find an algorithm that's going to solve my problem on that graph. Okay. So we want to have a graph that says, an algorithm that says, give me a graph, I'll tell you whether it's in this family. Okay. And so all I have to do is test whether or not does this given graph have a minor. That's one of the bad. A minor is everything you can get by shrinking and moving it. And given any minor, there's a long time algorithm saying I can tell whether this is a minor of these. And there's a finite number of bad cases. So I just try, does it have this bad case? How many time I got the answer? Does it have this bad case? How many time I got the answer? Look at total column without the problem. However, all we know is that the number of minor, we know what that. We might only know 1 or 2 of the minor. We don't know if it's got it. 20, we don't know if it's like 21, 25. All we know is that it's finite. So here we have how many time algorithms that we don't know.
That's a really great example of what you worry about or why you think P equals NP won't be useful. But still, why do you hold the intuition that P equals NP?
But because you have to rule out so many possible algorithms as being not working. You can take the graph and you can represent it as in terms of certain time numbers, and then you can multiply those together, and then you can take the bitwise and construct some certain constant in polynomial time, and then that's a perfectly valid algorithm. And there's so many algorithms of that kind. A lot of times we see random. You take data and we get coincidences that some fairly random looking number actually is useful because it happens to solve a problem just because there's so many hairs on your head. It seems like unlikely that two people are going to have the same number of hairs on their head. But if they're obvious, like you can count how many people there are and how many hairs. There must be people walking around in the country that have the same number of hairs on their head. Well, if that's a coincidence, you might say also, this particular combination of operations just happens to prove that graph has a Hamiltonian path. And I see lots of cases where unexpected things happen when you have enough possibility.
But because space possibility is so huge, your intuition just
They
says
have to read them all out. And so that's even from my intuition. It's by no means a proof. I mean, some people say, well, P can't equal NP because you've had all these smart people. The smartest designers have been wrecking their brains for years and years, and there's $1 million prizes out there, and none of them, nobody has thought of the algorithm, so it must be no such a. On the other hand, can I use exactly the same logic, and I say, well, P must be equal to NP because there's so many smart people out here been trying to prove they're unequal to NP, and they've all failed. But
this kind of reminds me of the discussion about the search for aliens. We've been trying to look for them, and we haven't found them yet. But they don't exist.
Yeah.
But you can show that there's so many planets out there that they very possibly could exist.
Yeah.
And, right.
And then there's also the possibility that they exist, but they all discovered machine learning or something, and then each other up.
Well, on that small, quick tangent, let me ask: do you think there's intelligent life out there in the universe?
No idea.
Do you hope so? Do you think about it?
I don't spend my time thinking about things that I could never know.
And yet, you do enjoy the fact that there's many things you don't know. You do enjoy the mystery of things.
I enjoy the fact that I have limits, but I don't take time to answer unsolvable questions.
Well, because you've taken on some tough questions that may seem unsolvable. You've taken on some tough questions and they seem unsolvable.
And it gives me a feel when I can get further than I ever thought I could. Yeah. But I don't.
But much like with religion,
I'm glad that there's no proof that God exists.
it's full of mystery.
It would be $2, yeah.
So, to quickly talk about the other art of artificial intelligence. What's your view? Artificial intelligence community has developed as part of computer science and in parallel with computer science. What's your view of the AI community from the 60s to now?
So all the way through, it was the people who were inspired by trying to mimic intelligence or to do things that were somehow the greatest achievements of intelligence. That inspiration to people who have pushed the envelope of computer science maybe more than other people. So it's all the way through. It's been a great source of good problems to pick the teeth into, and getting partial answers and then more successful answers over the years. So this has been the inspiration from us of the great discoveries of computer science.
Are you yourself captivated by the possibility of algorithms having echoes of intelligence in them?
Not as much as most of the people in the field, I guess. But that's not to say that they're wrong on that. You asked about my own personal preferences, but the thing that I worry about is when people start believing that we succeeded, and because seems to be this huge gap between really understanding something and being able to pretend to understand something and get the illusion of understanding something.
you think it's possible to create without understanding?
Yeah.
So
I do that all the time too. I mean, that's why I use random. But I, but there's still this great gap. I don't assert that it's impossible, but I don't see anything coming any closer to really uh, the, uh, the kind of stuff that I would consider intelligence.
So you mentioned something that on that line of thinking, which I very much agree with. So the art of computer programming is both focused on single processor algorithms for the most part. You mentioned
That's only because it's at the table of contents of my position.
there's no
I'm glad I didn't wait until 1965.
it's, one book. Maybe we'll touch on the Bible, but one book can't always cover the entirety of everything. So I'm glad the particular for the art of computer programming is what it is. But you didn't that you thought that understanding of what ant colonies are able to perform incredibly organized tasks might well be the key to understanding human cognition. So these fundamentally distributed systems. So what do you think is the difference between the way Don Knuth would sort of an ant colony would sort of list or perform an algorithm?
Sorting a list is the same as cognition, though, but I know what you're getting at. So the advantage of ant colony is at least we can see what they're doing. We know which ant has talked to which other ant, and it's much harder with the brains to know to what extent neurons are passing signal. So I understand ant colony might be, if they have the secret of cognition, like think of an ant colony as a cognitive single being rather than as a colony of lots of different ants. I mean, it's like cells of our brain and the microbiome are all having interacting entities, but somehow I consider myself to be one single person. Well, the ant colony, or you can say, might be cognitive somehow, and some, okay, I smash a certain ant and go ahead and that's done. What was that?
Right.
But if we're going to crack the secret of cognition, it might be that we can do so by psyching out how ants do it, because we have got a chance to measure. They're communicating by pheromones and by touching each other and sight, but not by much more subtle phenomenon by kind of currents going through.
But even a simpler version of that, what are your thoughts of maybe Conway's Game of Life?
Okay, so Conway's Game of Life it could simulate any computable process, and any deterministic process.
I like how you went there. I mean, that's not its most powerful thing, I would say. I mean, we can simulate it, but the magic is that the individual units are distributed.
Yes.
And extremely simple.
Yes, we understand exactly what the primitives are.
The primitives, just like with the ant colony.
But still, it doesn't say that I understand. I understand life. I mean, I understand. It gives me it gives me a better insight into what does it mean what does it mean to have free choice, for example.
Do you think God plays dice?
Yes. I don't see any reason why God should be forbidden from being the most efficient ways to I mean, we that dice are extremely important inefficient algorithms. There are things that couldn't be done well without random. So I don't see any reason why God should be prohibited from
when the algorithm requires it. You don't see why the physics should constrain it. So in 2001, he gave a series of lectures at MIT about religion and science.
1999.
But he published. Sorry.
What came out
So in 1999, he spent a little bit of time in Boston, enough to give those lectures.
Yeah.
And I read the 2001 version. Most of it. It's quite fascinating read. I recommend people. It's transcription of the lectures. So, what did you learn about how ideas get started and grow studying the history of the Bible? So you rigorously studied a very particular part of the Bible. What did you learn from this process about the way us human beings, society, develop and grow ideas, share ideas, and find with those ideas?
It's hard to summarize that. I wouldn't say that I learned to do really definite things. I can make conclusions, but I learned more about what I don't know. It's a complex subject, which is really beyond understanding. Uh, so we give up on saying I'm never going to get to the end of the road. I'm not going to understand what you're saying. But maybe I'd be good for me to get closer and closer and learn more and more about something. So, how can I do that efficiently? And the answer is, well, use randomness. And so try a random subset of that is within my grasp and study that in detail instead of just studying parts that somebody tells me to study, and instead of studying nothing because it's too hard. So I decided for my own amusement that once that I would take a subset of the verses in the Bible, and I would try to find out what the best thinkers have said about that small subset. And I had about, let's say, 60 verses out of 3,000. I think it's 1 out of 500, something like that. And so then I went to the library, which are well indexed. You spend, for example, at Boston Public Library, I would go once a week for a year. I went several times to Hanover Harvard Library to look at this in Boston Public, where scholars had looked at you can coordinate and you can go to look at the index and say, oh, is this verse mentioned in this book? If so, look at page 25. So, right? I could learn not only about the Bible, but about the secondary literature about the Bible, the things that scholars have written about it. And so that gave me a way to zoom in on parts of the things so that I could get more insight. And so I look at it as a way of giving me some firm pegs in which I could hang pieces of information, but not as things where I would say, and therefore this is true.
In this random approach of sampling the Bible, what did you learn about the most central, biggest accumulation of ideas?
It seemed to me that the main thrust was not one that most people think of as saying, don't have sex or something like this. But the main thrust was to try to figure out how to live in harmony with God's wishes. I'm assuming that God exists, and as I said, I'm glad that there's no way to prove this because I would run through the proof once and then I would forget it, and I would never speculate about spiritual things and mysteries. Otherwise, and I think my life would be very incomplete. So I'm assuming that God exists, but a lot of the people say God doesn't exist, but that's still important to them. So in a way, that might still be important to other guys that are not In some sense, God is important to them. It's one of the verses I studied. You can interpret saying like it's better to be an atheist than not to care at all.
Mhm. So I would say it's similar to the P equals NP discussion.
Yeah.
You mentioned mental exercise that I'd love it if you could partake in yourself. Mental exercise of being God. So how would you, if you were God on earth, how would you present yourself to the people on earth?
You mentioned your love of literature, and there's this book that really I can recommend to you. The title I think is Blasphemy. It talks about God revealing Himself through a computer in Los Alamos, and it it's the only book that I've ever read where the punchline was really the very last word of the book, and it explained the whole idea of the book. And so I don't want to give that away, but it's really very much about this question that you raised. But suppose God uh, said, okay, my previous means of communication with the world and not the best for the 21st century. So what should I do now? And it's conceivable that it would that God would choose the way that's described in this book.
Another way to look at this exercise is looking at the human mind, looking at the human spirit, the human life in a systematic way.
I think mostly you want to learn humility. You want to realize that once you solve one problem, that doesn't mean that all of a sudden other problems are going to drop out, and we have to realize that there are things beyond our ability. Um, I see people all around.
Yeah, well said. If you were to run program analysis on your own life, how did you do in terms of correctness, running time, resource use, asymptotically speaking, of course?
Okay, yeah. Well, I would say that question has not been asked me before, and we started out with Socrates and learning how to be an automaton that was obedient. And I had the great advantage that I didn't have anybody to blame for my failures. If I started getting not understanding something, I knew that I should stop playing ping pong, and that it was my fault that I wouldn't study hard enough or something, rather than that somebody was discriminating against me in some way. And I don't know how to avoid the existence of biases in the world, but I know that extra burden that I didn't have to suffer from. Um, and then I found from my parents I learned the idea of altruism, service to other people as more important than what I get. I know that I need to be happy enough in order to be able to speak of service, but I came to philosophy finally that phrase as point eight is enough. And there was a TV show once called Eight is Enough, which was somebody had 8 kids. Um, but I say point eight, which means if I have a way of rating happiness, I think it's good design to have an organism that's happy about 80% of the time. And if it was 100% of the time, it would be like everybody's on drugs and never and everything collapses, nothing works because everybody's just too happy.
you think you've achieved that 0.8 optimal balance?
There are times when I'm down and I know that I'm trying to I know that I've been programmed uh, uh, to be depressed a certain amount of time, and if that gets out of kilter, and I'm more depressed than sometimes I find myself trying to think, oh, who should I be mad at today? There must be a reason why I. But then I realize, it's just my chemistry telling me that I'm supposed to be mad at somebody, and so I trip up. Say, oh, okay, go to sleep and get better. Um, but but if I'm not 100% happy, that doesn't mean that I should find somebody that's screwing me and try to assassinate me. I'm saying, okay, I'm not 100% happy, but I'm happy enough to be part of a sustainable situation. So that's kind of the numerical analysis I do. I do
Converge towards the optimal. Human life is a 0.8.
Yeah.
I hope it's okay. Talk about, as you talked about previously, in 2006, you were diagnosed with prostate cancer. Has that encounter with mortality changed you in some ways? Well,
Yeah, it did. The first encounter with mortality was when my dad died, and after a month when I sort of came to uh, be comfortable with the fact that I was going to die someday. And during that month, I don't know, I, I felt okay. I couldn't sing, and I couldn't do original research either. I sort of remember after 3 or 4 weeks the first time I started having a maybe slightly creative. I could sort of feel that something was starting to move again. But that was, so I felt very empty for until I came to grips with that. I learned that this is sort of a grief process that people. Well, okay, so then now I'm at a point in my life, even more so than in 2006, where all of my goals have been fulfilled except for finishing out a computer program. I had one major unfulfilled goal. I wanted all my life to write a piece of music and I had an idea for a certain kind of music that I thought ought to be written. At least somebody ought to try to do it, and I felt that music it wasn't going to be easy, but I wanted to proof of concept. I wanted to know if it was going to work or not. So I and finally I finished that piece, and we had the world premiere last year on my 80th birthday, and we had another premiere, and there's talk of concerts in Europe and various things. But that's done. It's part of the world's music now, and it's either good or bad. But I did what I was hoping to do. So the only thing that I have on my agenda is to try to do as well as I can with the computer programming until I go see.
Do you think there's an element of 0.8 that might apply?
0.8? Well, I look at it more that I got actually to 1.0 when that concept was over. I mean, so in 2006 I was at 0.8. So when I was diagnosed with prostate cancer, then I said, okay, well, maybe this is, I've had all kinds of good luck all my life. I have nothing to complain about. So when I die now, and we'll see what happens. And so it's seriously, I went to, I had no expectation that I deserved better. I didn't make any plans for the future. I had my surgery, I came out of the surgery, and spent some time learning how to walk again and so on. It's just painful for a while. And I realized I hadn't really thought about what to do next. I hadn't any in my. I said, okay, hey, I'm still alive. Okay, now I can let you go. But I didn't come with the attitude that this was terribly unfair, I just said, okay, I'm accepting whatever turned out. I got more than my share of life. And I did, and really, when I got home, I realized that I had really not thought about the next step, what I would do after I was getting through it. I sort of thought of it as this might. I was comfortable with the fact that it was at the end. But I was hoping that I would still, be able to learn about satisfiability and also something write music. I just started seriously on the music project in 2012.
So I'm going to be in huge trouble if I don't talk to you about this. In the 70s, you created the tech typesetting system together with metaphor language description, modern family of typefaces. That has basically defined the methodology and the aesthetic of the countless research fields, right? Math, physics, beyond computer science, so on. Okay, well, first of all, thank you. I think I speak for a lot of people in saying that. But a question in terms of beauty. There's a beauty to typography that you've created, and yet beauty is hard to quantify.
Right.
How does one create beautiful letters and beautiful equations? Like what? I mean, perhaps there's no words to be describing. Be describing the process, but
so the great Harvard mathematician George Dickow wrote a book in the 30s called Aesthetic Measure, where he had pictures of faces, and I would be a number. And this was how beautiful it was. And he had a phone book for this, and he actually also wrote about music, and so he could. So I thought maybe I would, part of my musical composition, I would try to program his algorithms, and so that I would write something that has number by his score. Well, it wasn't quite rigorous enough for a computer to do, but anyway, people have tried to put numerical value on beauty, and he did probably the most serious attempt, and Jeff Gershwin's teacher also wrote 2 volumes where he talked about his method of component. But you're talking about another kind of beauty in letters and
elegance, but whatever that arbitrary.
Right. So that's the older, as you said, that akin to striving for excellence in whatever definition you want to give to beauty, then you try to get as close to that as you can.
I guess I'm trying to ask, and there may not be a good answer. What loose definitions were you operating under with the community of people that were working?
Oh, the loose definition, I wanted it to appeal to me.
For you personally,
Yeah.
It's a good start.
Yeah, no, and it failed that test. When I got volume 2 came out with the new printing, and I was expecting to be the happiest day of my life, and I felt it like a burning, like how angry I was that I opened the book and it was in the same page covers, but didn't look right on the page. The number 2 was particularly ugly. I couldn't stand any page that had a 2 in this page number. And I was expecting that I spent all this time making measurements, and I had looked at stuff in different ways, and I had I had great technology, but it did, but I wasn't done. I had to retune the whole thing after 1961.
Has it ever made you happy finally?
Oh yes. Uh,
Or is it a point?
and so many books have come out that would never have been written without this. It's just but now all these pages that are sitting up there, I don't have. If I didn't like them, I would change them. That's my. Nobody else has the ability. They have to stick with what I get.
Yeah. So in terms of the other side of it, there's the typography, so the look of the type, of the curves, and the lines. What about the spacing?
What about the
spacing?
spacing? Yeah.
The white space.
Yeah.
It seems like you could be a little bit more systematic about the layout or technical.
Oh yeah, you can always go further. I didn't stop at point A. I stopped at point 9.
It seems like you're not following your own rule for happiness. Or is,
No. There's okay. Of course, there's this. What was it, Japanese word, wabi-sabi or something that where the most beautiful works of art are those that have flaws because then the person who perceives them as their own appreciation and that gives a little more satisfaction or so on. I but normally with typography I wanted to make it as good as I could in the vast majority of cases and then when it doesn't, then I say, okay, that's 2% more work for the author. But I didn't want to. I didn't want to say that my job was to get 200% out of the work and take all the work away from the author. That's what I meant by that.
so if you were to venture a guess, how much of the nature of reality do you think we humans understand? So you mentioned you appreciate mystery.
Yeah.
How much of the world about us is shrouded in mystery? Are we, if you were to put a number on it,
Yeah.
what percent of it all do we understand? Are we totally?
How many leading zeros? 0.0. I think it's infinitesimal.
How do we think about that and what do we do about that? Do we continue one step at a time?
Yeah, we do our best. We realize that nobody's perfect, and we try to keep advancing. But sometimes saying we're not there, we're not all the way to the end. Some mathematicians that would be in the office next to me when I was in math, they would never think about anything smaller than countable infinity. And I never, we intersected that countable infinity because I rarely got up to countable infinity. I was talking about finite stuff. But even limiting to finite stuff, which the universe might be, there's no way to really know when the universe isn't just made out of capital N, whatever you just want to call them, quarks or whatever, where capital N is some finite number. All of the numbers that are comprehensible are still way smaller than almost all finite numbers. I got this one paper called Supernatural Numbers, where I guess you probably ran into something called Knuth arrow notation. Did you run into that? Where so you take a number, I think it's like, I called it Super K. I named it after myself, but it's like an arrow notation is something like 10 and then 3 or something. The arrow notation, if you have no x, that means multiplication x, y, x times x times x times x, y time. If you have one arrow, so x1 arrow y means x2 to x to the x to the x to y time. So I found out, by the way, that this notation was invented by a guy in 1830, and he was a kind of ability who spend his time thinking about stuff like this. And exactly the same concept that I used arrows and he used slightly different notation, but in numbers. Acronym function is based on the same kind of idea. But the acronym was 1920. So anyway, you got this number 10 quadruple arrow 3. So that says, well, we take we take 10 to 10 to 10 to 10 to 10. And how many times do we do that? Oh, 10 double arrow 2 times. So I mean, how tall is that stack? Yeah, but then we do that again. Because that was only 10 triple quadruple arrow 2. Quadruple arrow 3.
It's a very large number.
It gets way beyond comprehension. Okay. And so, but it's so small compared to what finite numbers really are. Because I'm only using 4 arrows, and 10 and a 3. I mean, let's have that many numbered arrows. I mean,
The boundary between infinite and finite is incomprehensible for us humans.
I think there's a good, useful way for us to think about extremely large, extremely large thing, and we can manipulate it, but we can never know that the universe is actually and do that. But so it just so I realize how little we know. But we found an awful lot of just things that are too hard for any one person to really even respond.
Yeah, we did pretty good. So when you go up to heaven, you die, and get to ask one question that would get answered, what question would you ask?
What kind of browser do you have up here? I actually, I don't think you need
Okay, and then thank you so much. It was a huge honor to talk to you.
Well, thanks for the gamut.
Yeah, it was fun. Thanks for listening to this conversation with Donald Knuth. Thank you to our presenting sponsor, Catch It Down. Download it, use code NEXTPODCAST. You'll get $10. $10 will go to STEM education nonprofit that inspires hundreds of thousands of young minds to learn, dream, and engineer their future. If you enjoy this podcast, subscribe on YouTube, give 5 stars on Apple Podcasts, support on Patreon, and connect with me on Twitter. And now, let me leave you with some words of them from Donald Knuth. We should continually be striving to transform every art into a science, and in the process, we advance the art. Thank you for listening. Hope to see you next time. The following is a conversation with Stephen Godkin, professor of history at Princeton University and one of the great historians of our time, specializing in Russian and Soviet history. He has written many books on Stalin and the Soviet Union, including the first 2 of a 3-volume work on Stalin. He is currently working on volume 3. You may have noticed that I've been speaking with not just computer scientists, but physicists, engineers, historians, neuroscientists, and soon much more. To me, artificial intelligence is much bigger than deep learning, bigger than computing. It is our civilization's journey into understanding the human mind and creating ecosystem in the machine. To me, that journey must include a deep historical and psychological understanding of power. Technology puts some of the greatest power in the history of our civilization into the hands of engineers and computer scientists. This power must not be abused. And the best way to understand how such abuse can be avoided is to not be blind to the lessons of history. As Stephen Kotkin brilliantly articulates, Stalin was arguably one of the most powerful humans in history. I've read many books on Joseph Stalin, Vladimir Putin, and the wars of the 20th century. I hope you understand the value of such knowledge to all of us, to engineers and scientists to build the tools of power in the 21st century. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, give it 5 stars on Apple Podcasts, follow on Spotify, support on Patreon, or simply connect with me on Twitter. Lex Friedman's Fridman. I recently started doing ads at the end of the introduction. I'll do 1 or 2 minutes after introducing the episode, and never any ads in the middle. It can break the flow of the conversation. I hope that works for you and doesn't hurt the listening experience. This show is presented by Cash App, the #1 finance app in the App Store. I personally use Cash App to send money to friends, but you can also use it to buy, sell, and deposit Bitcoin in just seconds. Cash App also has an investing feature. You can buy fractions of a stock, say $1 worth, no matter what the stock price is. Brokerage services are provided by Cash App Investing, a subsidiary of Square, and member SIPC. I'm excited to be working with Cash App to support one of my favorite organizations called FIRST, best known for their FIRST robotics and Lego competition. They educate and inspire hundreds of thousands of students in over 110 countries and have a perfect rating on Charity Navigator, which means the donated money is used with maximum effectiveness. When you get Cash App in the App Store and Google Play and use code LEXPODCAST, you'll get $10. Cash App will also donate $10 to FIRST, which again is an organization that I've personally seen inspire girls and boys to dream of engineering a better world. And now, here's my conversation with Stephen Kotkin. Do all human beings crave power?
No. Human beings crave security, they crave love, they crave adventure, they crave power, but not equal.
Some human beings, nonetheless, do crave power.
For sure.
Where is that deeply in psychology? People, is something born with? Is it something they develop?
Some people crave a position of leadership or of standing out, being recognized. And that could be starting out in the school years, on the schoolyard. It could be within their own family, not just in their peer group. Those kind of people we often see creating leadership positions from a young age, often end up in positions, but they can be varied positions. You can have power in an institution where your power is purposefully limited. For example, there's a board or a consultative body or the separation of power. Not everyone craves power whereby they're the sole power or they're the unconstrained power. That's a little bit less usual. We may think that everybody does, but not everybody does. Those people who do crave that kind of power, unconstrained, the ability to decide as much as life or death of other people, those people are not everyday. They're not the people you encounter in your daily life for the most part. Those are extraordinary. Most of them don't have the opportunity to live that dream. Very few of them end up with the opportunity.
So, percentage-wise, in your sense, if we pick George Washington, for example, most people, given the choice of absolute power over a country versus maybe the cap power that the United States presidential role, at least at the founding of the country, represented, what do you think most people would choose?
Well, Washington was in a position to exercise far greater power than he did. And in fact, he didn't take that option. He was more interested in seeing institutionalization of seeing the country develop strong institutions rather than individual leader like himself had that system. So that's very important. So like I said, not everyone craves unconstrained power, even if they're very ambitious. And of course, Washington was very ambitious. He was a successful general before he was a president. So that clearly comes from the influences on your life, where you grow up, how you raise, what kind of values are imparted to you along the way. You can understand power as the ability to share, or you can understand for the ability to advance something for the collective in a collective process, not an individual process. So power comes in many different varieties, and ambition doesn't always equate to despotic power. Despotic power is something different from ordinary institutional power that we see. The president of MIT does not have unconstrained power. The president of MIT rightly must consult with other members of the administration, with the faculty members, to a certain extent with the student body, and certainly with the trustees of MIT. Those constraints make the institution strong and enduring, and make the decisions better than they would be if he had unconstrained power. But you can't say that the president is not ambitious. Of course the president is ambitious. We worry about unconstrained power. We worry about executive authority that's not limited. That's the definition of authoritarianism, material. Unlimited or barely limited executive authority. Executive authority is necessary to carry out many functions. We all understand that. That's why MIT has it. But unlimited or largely unconstrained executive power is detrimental to even the person who exercises.
So what do you think? It's an interesting notion. We kind of take it for granted that constraints on executive power is a good thing. But why is that necessarily true? So what is it about absolute power that does something to the human mind? The popular saying of absolute power corrupts, absolutely. Is that the case? That the power in itself is the thing that corrupts the mind in some kind of way where it leads to a bad leadership over time?
People make more mistakes when they're not challenged, when they don't have to explain things and get others to vote to go along with it, when they can make a decision without anybody being able to block their decision or to have input necessarily on that decision. You're more prone to mistakes. You're more prone to extremism. There's a temptation. For example, we have separation of powers in the United States. The Congress, right, has authority that the president doesn't have, as, for example, in budgeting, the so-called power of the purse. This can be very frustrating. People want to see things happen, and they complain that there's a do-nothing Congress or that the situation is stalemated. But actually, that's potentially a good thing. In fact, that's how our system was designed. Our system was designed to prevent things happening in government. And there's frustration with that, but ultimately that's the strength of the institution. And so when you see unconstrained executive authority, there can be a lot of dynamism, a lot of things can get done quickly. But those things, like, for example, what happened in China under Mao, or what happened in the Soviet Union under Stalin, or what happened in Haiti under Papa Doc and Baby Doc, or fill in the blank. What happens sometimes in corporations, where a corporate leader is not constrained by the shareholders, by the board, or by anything. And they can seem to be a genius for a while, but eventually it catches up with them. So the idea of constraints on executive power is absolutely fundamental to the American system, American way of thinking, and not only, I mean, obviously large other parts of the world that have a similar system, not an identical system, but a similar system of checks and balances on executive power. And so the case that I studied, the only checks and balances on executive power are circumstantial. So for the distance in the country, it's hard to do something over 5,000 miles, or the amount of time in a day. It's hard for a leader to get to every single thing the leader wants to get to because there are only 24 hours in a day. Those are circumstantial constraints on executive power. They're not institutional constraints.
One of the constraints on executive power the United States has versus Russia, maybe something you've implied and that you spoke directly to, is there's something in the Russian people and the Soviet people that are attracted to authoritarian power. That, psychologically speaking, or at least the kind of leaders that sought authoritarian power throughout its history, and that desire for that kind of human is a lack of a constraint. In America, it seems, as people, we desire somebody not like Stalin, somebody more like George Washington. So that's another constraint, the belief that people, what they admire in a leader, what they seek in a leader. Maybe you can speak to, well, first of all, can you speak briefly to that psychology of, is there a difference between the Russian people and the American people in terms of just what we find attractive in a leader?
Not as great a difference as it might seem. There are, unfortunately, many Americans who would be happy with an authoritarian leader in the country. It's by no means a majority. It's not even a plurality. But nonetheless, it's a real sentiment in the population. Sometimes because they feel frustrated, because things are not getting done. Sometimes because they're against something that's happening in the political realm, and they feel it has to be corrected and corrected. It's a kind of impulse. People can regret the impulse later on, and the impulse is motivated by reaction to their environment. In the Russian case, we have also people who crave, sometimes known as a strong hand, an iron hand, an authoritarian hand, because they want things to be done and be done more quickly that align with their desires. But I'm not sure it's a majority in the country today. Certainly in Stalin's time, this was a widespread sentiment, and people had few alternatives that they understood or could have given. Nowadays, in the globalized world, the citizens of Russia can see how other systems have constraints on executive power, and the life isn't so bad there. In fact, the life might even be better. So the impatience, the impulsive quality, the frustration does sometimes in people reinforce their craving for the unconstrained executive to get things done, shake things up. Yes, that's true. But in the Russian case, I'm not sure it's cultural today. I think it might be more having to do with the failures, the functional failures of the kind of political system that they tried to institute after the Soviet collapse. And so it may be frustration with the version of constraints on executive power they got and how it didn't work the way it was imagined, which has led to a sense in which non-constrained executive power can fix it. But I'm not sure that that's a majority sentiment in the Russian case, although it's hard to measure because under authoritarian regimes, public opinion is shaped by the environment in which people live, which is very constrained in terms of public opinion.
But on that point, why, at least from a distance, does there seem to nevertheless be support for the current Russian president, Vladimir Putin? Does that have to do with the fact that measuring, getting good metrics, the statistics on support is difficult in authoritarian governments, or is there still something appealing to that kind of power to the people?
I think we have to give credit to President Putin for understanding the psychology of the Russians to whom he appeals. Many of them were the losers in the transition from communism. They were the ones whose pensions were destroyed by inflation, or whose salaries didn't go up, or whose regions were abandoned. They were not the winners for the most part. And so I think there's an understanding on his part of their psychology. Putin has grown in the position. He was not a public politician when he first started out. He was quite poor in public settings. He didn't have the kind of political instincts that he has now. He didn't have the appeal to traditional values of the Orthodox Church and some of the other dimensions of his rule today. So yes, we have to give some credit to Putin himself for this, in addition to the frustrations and the mass of the people. But let's think about it this way, in addition, without taking away the fact that he's become a better retail politician over time, and that sentiment has shifted because of the disappointments with the transition of the population. When I ask my kids, am I a good dad? My kids don't have any other dad to measure me against. I'm the only dad they know, and I'm the only dad they can choose or not choose. If they don't choose me, they still get me as dad. Right? So with Putin today, he's the only dad that the Russian people have. Now, if my kids were introduced to alternative fathers, they might be better than me. They might be more loving, more giving, funnier, richer, whatever it might be. They might be more appealing. There are some blood ties there, for sure, that I have with my kids. But they would at least be able to choose alternatives, and then I would have to win their favor in that constellation of alternatives. If President Putin were up against real alternatives, if the population had real choice, and that choice could express itself and have resources, have media and everything else the way he does, maybe he would be very popular, and maybe his popularity would not be as great as it currently is. So the absence of alternatives is another factor that reinforces his authority and his popularity. Having said that, there are authoritarian leaders who deny any alternatives to the population and are not very popular. Denial of alternatives doesn't guarantee you the popularity. You still have to figure out the mass psychology to appeal. So in the Russian case, the winners from the transition live primarily in the big cities and are self-employed or entrepreneurial. Even if they're not self-employed, they're able to change careers, get tremendous skills and talent and education and knowledge, as well as these entrepreneurial or dynamic personalities. Putin also appealed to them. He did that with Medvedev, and it was a very clever ruse. He himself appealed to the losers from the transition, the small towns, the rural, the people who were not well off, and he had them for the most part. Not all. We don't want to generalize to say they had every one of them, because those people have views of their own, sometimes in contradiction with the president of Russia. And then he appealed to the opposite people, the successful urban base, through the so-called reformer Medvedev, the new generation, the technically literate prime minister who for a time was president. And so that worked very successfully for Putin. He was able to bridge a big divide in the society and gain a greater mass support than he would otherwise have had by himself. That ruse only worked through the time Medvedev was temporarily president for a few years. Because of the Constitution, Putin couldn't do 3 consecutive terms and stepped aside in what they call castling check. When this was over, Putin had difficulty with his popularity. There were mass protests in the urban areas. Precisely that group of the population that he had been able to win in part because of the Medvedev castle, and now had had their delusions exposed and were disillusioned. And there were these mass protests in the urban areas, not just in the capital. And Putin had to, as it were, come up with a new way to fix his popularity, which happened to be the annexation of Crimea, from which he got a very significant profit. However, the trend is back in the other direction. It's diminishing again, although it's still high relative to other leaders around the world. So I wouldn't say that he's unpopular with the mass in Russia. There is some popularity there, there is some success, but I would say it's tough for us to gauge because of the lack of alternatives. And Putin is unpopular inside the state administration.
At every level, the bureaucracy of
Because those
leadership.
people are well informed and they understand that the country is declining, that the human capital is declining, the infrastructure is declining, the economy is not really growing, it's not really diversifying, Russia's not investing in its future. The state officials understand all of that, and then they see that the Putin clique is stealing everything inside. So between the failure to invest in a future and the corruption of a narrow group around the president, there's disillusionment in the state apparatus because they see this more clearly or more closely than the mass of the population. They can't necessarily yet oppose this in public because they're people, they have families, they have careers, they have children who want to go to school or want a job. And so there are constraints on their ability to oppose the regime based upon what we might call cowardice or other people might call realism. I don't know how courageous people can be when their family, children, career are on the line. So it's very interesting dynamic to see the disillusionment inside the government with the president, which is not yet fully public for the most part, but could become public. And once again, if there's an alternative, if an alternative appears, things could shift quickly. And that alternative could come from inside the regime.
From inside the regime, but the leadership, the party, the people that are now, as you're saying, opposed to Putin, they're nevertheless, maybe you can correct me, but it feels like there's structurally is deeply corrupt. So each of the people we're talking about don't feel like a George Washington.
Once again, the circumstances don't permit them to act that way necessarily, right? George Washington did great things, but in certain circumstances. A lot of the state officials in Russia, for certain, are corrupt. There's no question. Many of them, however, are patriotic, and many of them feel badly about where the country has been going. They would prefer that the country was less corrupt. They would prefer that there were greater investment in all sorts of areas of Russia. They might even themselves steal less if they could be guaranteed that everybody else would steal less. There's a deep and abiding patriotism inside Russia, as well as inside the Russian regime. So they understand that Putin, in many ways, rescued the Russian state from the chaos of the 1990s. They understand that Russia was in very bad shape as an incoherent, failing state almost when Putin took over, and that he did some important things for Russia's stability and consolidation. There's also some appreciation that Putin stood up to the West and stood up to more powerful countries and regained a sense of pride and maneuverability for Russia in the international system. People appreciate that, and it's real. It's not imagined that Putin accomplished. The problem is the methods that he accomplished it with. He used the kind of methods, that is to say, taking other people's property, putting other people in jail for political reasons, He used the kind of methods that are not conducive to long-term growth and stability. So he fixed the problem, but he fixed the problem and then created bigger long-term problems. And moreover, all authoritarian regimes that use those methods are tempted to keep using them and using them and using them until they're the only ones who are the beneficiary. And the group narrows and narrows. The elite gets smaller and narrower. The interest groups get excluded from power and their ability to continue enjoying the fruits of the system, and the resentment grows. And so that's the situation we have in Russia. Russia is a place that is stuck. It was to a certain extent rescued. It was rescued with methods that were not conducive to long-term success and stability.
The rest you're referring to is the sort of the economic growth when Putin first took
Yes,
office.
they had 10 years. They had a full decade of an average of 7% growth a year. It was not attributable predominantly to oil prices. During President Putin's first term as president, the average price of oil was $35 a barrel. During his second term as president, the average price was $70 a barrel. So during those two terms, when Russia was growing at about 7% a year, oil prices were averaging somewhere around $50 a barrel, which is fine, but is not the reason, because later on, when oil prices were over $100 a barrel, Russia stagnated.
But the initial growth, do you think Putin deserves some credit for that?
Yes, he does, because he introduced some important liberalizing measures. He lowered taxes. He allowed land to be bought and sold. He deregulated many areas of the economy. And so there was a kind of entrepreneurial burst that was partly attributable to government policy during his first term. But also he was consolidating political power, and as I said, the methods he used overall and for the long term were not able to continue sustain that success. In addition, we have to remember that China in the success of Russia in the first two terms of Putin's presidency, because China's phenomenal growth created insatiable demand for just about everything that the Soviet Union used to produce. So fertilizers, cement, fill in the blank, chemicals, metals. China had insatiable demand for everything the Soviet Union once produced. And so China's raising of global demand overall brought Soviet-era industry back from the dead. And so there was something that happened. Soviet-era industry fell off a cliff in the 1990s. There was a decline in manufacturing and industrial production greater than in the Great Depression in the U.S. But a lot of that came back online in the 2000s, and that had to do with China's phenomenal growth. The trade between China and Russia was not always direct, so this was an indirect effect. But raising global prices for the commodities and the products, the kind of lower-end, lower-value products in manufacturing, not high-end stuff, but lower-end stuff, like steel or iron or cement, fertilizer, where the value added is not spectacular, but nonetheless, which had been destroyed by the 1990s after the Soviet left. This was brought back to life. Now you can do that once. You can bring Soviet-era industry back to life. And that happened during its first two terms, in addition to the liberalizing policies, which spurred entrepreneurialism in some small and medium business. The crash of the ruble in 1998, which made Russian products much cheaper abroad and made imports much more expensive, also facilitated the resuscitation, the revival of domestic manufacturing. So all of this came together for that spectacular 10-year, 7% on average economic growth, and moreover, people's wages after inflation, their disposable income grew more even than GDP grew. So disposable income after inflation, that is real income, was growing greater than 7%, in some cases 10%. So there was a boom, and the Russian people felt it, and it happened during Putin's first two terms, and people were grateful, rightly so, for that. And those who don't want to give Putin credit give oil prices all the credit. But I don't think that oil prices can explain this. Having said that, that doesn't mean that this was sustainable over the long term.
So you briefly mentioned sort of implying the possibility that Stalin to power for, let's say, 30 years. You briefly mentioned that there's a question, will Putin be able to beat that record, beat that? But can you talk about your sense of, is it possible that Putin holds power for that kind of duration?
Let's hope not. Let's hope not for Russia's sake. The primary victims of President Putin's power are Russians. They're not Ukrainians, although to a certain extent Ukraine has suffered because of Putin's actions. And they're not Americans. They're Russian. Moreover, Russia has lost a great deal of human talent. Millions and millions of people have left Russia. Since 1991 overall, somewhere between 5 and 10 million people have left the country and are beyond the borders of the former Soviet Union. So they left the Soviet space entirely. Moreover, the people who left are not the poor people. They're not the uneducated. They're not the losers. People who left are the more dynamic parts of the population, the better educated, the more entrepreneurial. So that human capital loss that Russia has suffered is phenomenal. And in fact, right here where we're sitting at MIT, we have examples of people who are qualified, good enough for MIT, and have left Russia to come to MIT.
You're looking at one of them. And the other aspect, just to quickly comment, is those same people, like me, I'm not welcome back.
No, you're not under the current regime. It was a big loss for Russia if you're patriotic, but not from the point of view of the Putin regime. That has to do also factors into popularity. If the people who don't like you leave, they're not there to complain, to protest, to vote against you. And so your opposition declines when you let them leave. However, it's very costly in human capital terms. Hemorrhaging that much human capital is damaging. It's self-damaging. And we've seen it accelerate. It was already high, but we've seen it accelerate in the last 7 to 8 years of President Putin's rule. And those people are not going back of their own volition, but even if they wanted to go back, as you just said, they can't go. That's a big cost to pay for this regime. And so whatever benefits this regime might or might not have given to the country, the disadvantages, the downside, the costs are also really high. So we don't want Putin lasting in power as long as Stalin. It would be better if Russia were able to choose among options, to choose a new leader among options. Now, many people speculate that President Putin will name a successor, the way Yeltsin named Putin as his successor, President Boris Yeltsin. And then Putin will stage and allow the successor to take over. That might seem like a good solution, but once again, we don't need a system where you hang on for as long as possible and then nominate who's going to take over. We need a system that has the kind of collective mechanism that democracies and markets have, along with rule of law. A collective mechanism is really important because all leaders make mistakes. But when you can't correct for the mistakes, then the mistakes get compounded. Putin could well he seems to be healthy. He could well last as many years as Stalin. It's hard to predict because events intercede sometimes and create circumstances that are unforeseen, and leaders get overthrown or have a heart attack or whatever. There's a palace insurrection where ambitious leaders on the inside, for both personal power and patriotic reasons, try to push aside an aging leader. There are many scenarios in which Putin could not last that long, but unfortunately, right now, you could also imagine potentially him lasting that long, which, as I said, is not an outcome if you're patriotic about Russia. It's not an outcome you would wish on to the country.
I guess a very difficult question, but what practically do you feel is a way out of the Putin regime? Is the way out of the corruption that deeply underlies the state? If you look from a history perspective, is a revolution required? Is violence required? Is from a violence within or external to the country? Do you see, or is a powerful, is a inspiring leader enough to step in and bring democracy and kind of the free world to Russia?
Well, Russia is not a failed country. It's a middle-income country with tremendous potential, and has proven many times in the past that when it gets in a bad way, it can reverse its trajectory. Moreover, violence is rarely ever a solution. Violence rarely, it may break an existing trend, but it's rare that violence produces a non-violent, sustainable, positive outcome. It happens, but it doesn't happen frequently. Societal upheaval is not a way always to institutionalize a better path forward, because you need institutions. People can protest, as they did throughout the Middle East, and the protests didn't necessarily lead to better systems, because the step to protest to new, strong, consolidated institutions is a colossal leap, not a small step. What we need and what we see from history in situations like this is a group within the power structures, which is a patriotic, that sees things going down, and that is to say, that sees things not be developing relative to neighbors, relative to richer countries, relative to more successful countries. And they want to change the trajectory of Russia. And if they can, in a coalition fashion, unseat the current regime for a new power share arrangement, which once again can be frustrating because you can't do changes immediately, you can't do things overnight, but that's the point. Constraints on your ability to change everything immediately, to force change overnight, is what leads to long-term success potential. Right? That's the sustainability of change. So Russia needs stronger institutions. It needs court system as well as democratic institutions. It needs functioning, open, dynamic markets rather than monopolies. It needs meritocracy and banks to award loans on the basis of business plans, not on the basis of political criteria or corrupt bribery or whatever it might be. So Russia needs those kind of functioning institutions that take time, are sometimes slow, don't lead to a revolutionary transformation, but lead to potentially long-term sustainable growth without upheaval, without violence, without getting into a situation where all of a sudden you need a miracle again. Every time Russia seems to need a miracle, and that's the problem. The solution would be not needing a miracle. Now, having said that, the potential is there. The civilization that we call Russia is amazingly impressive. It has delivered world-class culture, world-class science. It's a great power. It's not a great power with a strong base right now, but nonetheless, it is a great power as it acts as a So I wouldn't underestimate Russia's abilities here, and I wouldn't write off Russia. I don't see it under the current regime a renewal of the country, but if we can have from within the regime an evolution rather than a revolution in a positive direction, and maybe get a George Washington figure who is strong enough to push through institutionalization rather than personalism.
So, if I could ask about one particular individual, it'd be just interesting to get your comment, but also as a representative of potential leaders. I just on this podcast talked to Gary Kasparov, who I'm not sure if you're familiar with his ongoings. So besides being a world-class chess player, he's also a very outspoken activist with seeing Putin, truly seeing Putin as an enemy of the free world, of democracy, of balanced government in Russia. What do you think of people like him specifically, or just people like him trying as leaders to step in, to run for president, to symbolize a new chapter in Russia's future?
So we don't need individuals. Some individuals are very impressive, and they have courage and protest and criticize and they organize. We need institutions. We need a Duma or a parliament that functions. We need a court system that functions. That is to say, where there are a separation of powers, impartial professional civil service, impartial professional judiciary. Those are the things Russia needs. It's rare that you get that from an individual, no matter how impressive. We had Andrei Sakharov, who was an extraordinary individual, who developed the hydrogen bomb under the Soviet regime, was a world-class physicist, was then upset about how his scientific knowledge and scientific achievements were being put to use, and rebelled to try to put limits, constraints, civilizing main limits and constraints on some of the implications of his extraordinary science. But Sakharov, even if he had become the leader of the country, which he did not become, he was more of a moral or spiritual leader, it still wouldn't have given you a judiciary. It still wouldn't have given you a civil service. It still wouldn't have given you a Duma, a functioning parliament. You need a leader in coalition with other leaders. You need a bunch of leaders, a whole group, and they have to be divided a little bit so that not one of them can destroy all the others. And they have to be interested in creating institutions, not solely or predominantly in their personal power. And so I have no objection to outstanding individuals and to the work that they do. But I think in institutional terms, and they need to think that way too in order to be successful.
So if we go back to the echoes of that after the Russian Revolution with Stalin, with Lenin and Stalin, maybe you can correct me, but there was a group of people there in that same kind of way looking to establish institutions that were built in a beautifully built around an ideology that they believe is good for the world. So, echoing that idea of what we're talking about, what Russia needs now, can you, first of all, you've described a fascinating thought. Stalin as having amassed arguably more power than any man in history. It's an interesting thing to think about. But can you tell about the journey to gaining that power after the Russian Revolution? How does that perhaps echo to our current discussion about institutions and so on? And just in general, the story I think is fascinating of how he was able to get more power than any other man in history.
It is a great story, not necessarily from a moral point of view, but if you're interested in power, for sure it's an incredible story. But we have to remember that Stalin is also a product of circumstances, not solely his own individual drive, which which is very strong. For example, World War I breaks the Tsarist regime, the Tsarist order, the Imperial Russian state. Stalin has no participation whatsoever in World War I. He spends World War I in exile in Siberia until the downfall of the Tsarist autocracy in February 1917. Stalin is in Eastern Siberian exile. He's only able to leave Eastern Siberia when that regime falls. He never fights in the war. He's called up briefly towards the end of the war and is disqualified on physical grounds because of physical deformities, including drafting. The war continues after the Tsarist regime has been toppled in the capital. There's been a revolution. The war continues, and that war is very radicalized. The peasants begin to seize the land after the Tsar falls, essentially destroying much of the gentry class. Stalin has nothing to do with that. The peasants have their own revolution, seizing the land, not in law, but in fact, de facto, not de jure land ownership. So there are these really large processes underway that Stalin is alive during, but not a driver. The most improbable thing happens, which is a very small group of people around the figure of Vladimir Lenin announces that it has seized power. Now, by this time, in October 1917, the government that has replaced the Tsar, the so-called provisional government, has failed. And so there's not so much power to seize from the provisional government. What Lenin does is he does a coup on the left. That is to say, Soviets, or councils, as we would call them in English, which represent people's power, or the masses participating in politics, the kind of radical grassroots democracy, are extremely popular all over the country and not dominated by any one group, but predominantly socialist or predominantly leftist. Russia has an election during the war, a free and fair election for the most part, despite the war, at the end of 1917, December 1917. And 3/4 plus of the country votes socialist in some form or another. So the battle was over the definition of socialism and who had the right to participate in defining socialism. Not only what it would be, but who had the right to decide. So there's a coup by Lenin's group known as the Bolsheviks against all the other socialists. And so Lenin declares power whereby the old government has failed, people's power, the councils, known as Soviets, take their place, and Lenin seizes power in the name of the Soviets. So it's a coup against the left, against the rest of the left, not against the provisional government that has replaced the Tsar, which has already failed. And so Stalin is able to come to power along with Lenin in this crazy seizure of power on the left against the rest of the left in October 1917, which we know as the October Revolution, and I call the October coup, as many other historians. The October Revolution happened after the seizure. What's interesting about this episode is that the leftists who seized power in the name of the Soviets, in the name of the masses, they retained their hold. Many times in history, there's a seizure of power by the left, and they fail. They collapse. They're cleaned out by an army or what we call forces of order, by counter-revolutionary forces. Lenin's revolution, Lenin's coup, is successful. It is able to hold power, not just seize power. They win a civil war, and they're entrenched in the heart of the country already by 1921. Stalin is part of that group. Lenin needs somebody to run this new regime in the kind of nitty-gritty way. Lenin is the leader, the undisputed leader in the Bolshevik Party, which changes their name to communists in 1918. He makes Stalin the general secretary of the Communist Party. He creates a new position which hadn't existed before, a kind of day-to-day political manager, a right-hand man. Not because Lenin is looking to replace himself, he's looking to institutionalize a helpmate, a right hand. He does this in the spring of 1922. Stalin is named to this position, which Lenin has created expressly for Stalin. So there's been a coup on the left, whereby the Bolsheviks, who become communists, seize power against the rest of the socialists and the anarchists and the entire left. And then there's an institutionalization of a position known as General Secretary of the Communist Party, right-hand man of Lenin. Less than 6 weeks after Lenin has created this position and installed Stalin, Lenin has a stroke, a major stroke, and never really returns as a full actor to power before he dies of a fourth stroke in January 1920. So a position created for Stalin to run things on Lenin's behalf, and then Lenin has a stroke. And so Stalin now has this new position, General Secretary. But he's the right hand of a person who's no longer exercising day-to-day control over affairs. Stalin then uses this new position to create a personal dictatorship inside the Bolshevik dictatorship, which is the remarkable story I tried to tell.
So is there anything nefarious about any of what you just described? It seems conveniently that the position is created just for Stalin. There was a few other brilliant people, arguably more brilliant than Stalin, in the vicinity of Lenin. Why was Stalin chosen? Why did Lenin all of a sudden fall ill? It's perhaps a conspiratorial question, but is there anything nefarious about any of this historical trajectory to power that Stalin took in creating the personal dictatorship?
So history is full of contingency and surprise. After something happens, we all think it's inevitable. It had to happen that way. Everything was leading up to it. So Hitler seizes power in Germany in 1933, and the Nazi regime gets institutionalized by several of his moves after being named chancellor. And so all German history becomes a story of the Nazi rise to power, Hitler's rise to power. Every tendency is bent into that outcome. Things which don't seem related to that outcome all of a sudden get bent in that direction. And other trends that were going on are no longer examined because they didn't lead to that outcome. Hitler's becoming Chancellor of Germany in 1933 was not inevitable, it was contingent. He was offered the position by the traditional conservatives. He's part of the radical right, and the traditional right named him chancellor. The Nazi Party never outright won an election that was free and fair before Hitler took power. In fact, its votes on the eve of Hitler becoming chancellor declined relative to the previous election. So there's contingency in history, and so Lenin's illness, his stroke, the neurological and blood problems that he had were not a structure in history. In other words, if Lenin had been a healthier figure, Stalin might never have gone that we know. That's not to say that all history is accidental, just that we need to relate the larger structural factors to the contingent factors. Why did Lenin pick Stalin? Well, Stalin was a very effective organizer, and the position was an organizational position. Stalin could get things done. He would carry out assignments, no matter how difficult. He wouldn't complain that it was hard work or too much work. He wouldn't go off womanizing and drinking, ignore his responsibilities. Lenin chose Stalin among other options because he thought Stalin was the better option. Once again, he wasn't choosing his successor because he didn't know he was going to have this stroke. Lenin had some serious illnesses, but he had never had a major stroke. So the choice was made based upon Stalin's organizational skills and promise against the others who were in the regime. Now, they can seem more brilliant than Stalin, but he was more effective. I'm not sure they were very brilliant.
Well, he was exceptionally competent, actually, at the tasks of running a government, the executive branch, right, of a dictator.
Yes, he turned out to be very adept at being a dictator. And so, if he had been chosen by Lenin and had not been very good, he would have been pushed aside. You can get a position by accident. You can be named because you're someone's friend or someone's relative. But to hold that position in difficult circumstances, and then to build effectively a superpower on all that bloodshed, right? You have to be skilled in some way. It can't be just an accident that brings you to power. Because if accident brings you to power, it won't last. Just like we discovered with Putin, he had some qualities that we didn't foresee at the beginning, and he's been able to hold power, not just be named. Now, Putin and Stalin are very different people. These are very different regimes. I wouldn't put them in the same sentence. My point is not that one resembles the other. My point is that when people come to power for contingent reasons, they will stay in power unless they're able to manage it. And Stalin was able to build a personal dictatorship inside that. He was cunning, he was ruthless, and he was a workaholic, very diligent. He had a phenomenal memory, so he could remember people's names and faces and events. And this was very advantageous for him as he built the machine that became the Soviet state and democracy.
One of the things, if you can correct me if I'm wrong, was you made me realize this wasn't some kind of manipulative personality trying to gain more power, so a kind of an evil picture of a person. But he really believed in communism. This I can't understand. Again, you can correct me if I'm wrong, but he wanted to build a better world by having infusing communism into the country, perhaps into the whole world. So maybe my question is, what role does communism as an idea, as an ideology, play in all of this? And this rise to power and the people of the time, and the Russian people actually just the 20th century.
You're right. Stalin was a true believer, and this is very important. He was also hungry for power and for personal power, but just as you said, not for power's sake, not only for power. He was interested in enacting communism in reality and also in building a powerful state. He was a statist, traditional Russian Western imperialist. And this won him a lot of followers. The fact that they knew he was a hardcore, true believing communist won him a lot of followers among the communists. And the fact that he was a hardcore defender of Russian state interests now in the Soviet guise also won him a lot of followers. Sometimes those groups overlap, the communists and the Russian patriots, and sometimes they were different groups, but both of them shared an admiration for Stalin's dedication to those goals and his ability to enact them. So it's very important to understand that however thirsty he was for power, and he was very thirsty for power, that he was also driven by ideals. Now, I don't necessarily think that everyone around Stalin shared those ideals. To be careful not to make everybody into a communist true believer, not to make everybody into a great statist Russian patriot, but they were a widespread, powerful attraction for a lot of people. And so Stalin's ability to communicate to people those that he was dedicated to those pursuits, and his ability to drive towards them were part of his appeal. However, he also resorted to manipulation. He also resorted to violence. He lied. He spoke out of all sides of his mouth. He slandered other people. He sabotaged potential rivals. He used every underhanded method and then some in order to build his personal dictatorship. Now, he justified this, as you said, by appeals to communism and to Soviet power.
To himself as well.
To himself and to others. And so he justified it in his own mind and to others, but certainly any means, right, were acceptable to him to achieve these ends. And he identified his personal power with communism and with Russian glory in the world. So he felt that he was the only one who could be trusted, who could be relied upon to build these things. Now we put ourselves back in that time period. The Great Depression was a very difficult time for the capitalist system. There was mass unemployment, a lot of hardship. Fascism, Nazism, Imperial Japan. There were a lot of associations that were negative with the kind of capitalist system that was not 100%, not a monolith, but had a lot of authoritarian incarnation. There was imperialism, colonies that even the democratic rule of law capitalist states had non-rule of law colonies under their rule. So the image and reality of capitalism during that time period between World War I and World War II was very different from how it would become later. And so in that time period, in that interwar conjunction after World War I, before World War II, communism held some appeal inside the Soviet Union for sure, but even outside the Soviet Union, because the image and reality of capitalism disappointed many people. Now, in the end, communism was significantly worse. Many more victims, and the system, of course, would eventually implode. But nonetheless, there were real problems that communism tried to address. It didn't solve those problems. It was not a solution, but it didn't come out of nowhere. It came out of the context of that interwar period. And so Stalin's rule, some people saw it as potentially a better option than imperialism, fascism, and the Great Depression. Having said that, they were wrong. It turned out that Stalin wasn't a better alternative to markets, private property, rule of law, and democracy. However, that didn't become clearer to people until after World War II, after Nazism had been defeated, Imperial Japan had been defeated, Fascist Italy had been defeated, and decolonization had happened around the world, and there was a middle-class economic boom in the period from the late 40s through the 70s that created a mass middle class in many societies. So capitalism rose from the ashes, as it were. And this changed the game for Stalin and communism. Communism is about an alternative to capitalism. And if that alternative is not superior, there's no reason for communism to exist. But if capitalism is in foul odor, if people have a bad opinion, strong critique of capitalism, there can be appeal to alternatives. And that's kind of what happened with Stalin's rule. But after World War II, the context changed a lot. Capitalism was very different, much more successful, not non-violent compared to what it was in the period. And the Soviet Union had a tough time competing against that new context. Now today we see similarly that the image and reality of capitalism is under question again, which leads some people to find an answer in socialism as an alternative.
So you just kind of painted a beautiful picture of comparison. This is the way we think about ideologies. Is what's working better do you separate in your mind the ideals of communism to the Stalinist implementation of communism, and again, capitalism and American implementation of capitalism? And as we look at now the 21st century, where yes, this idea, of socialism being a potential political system that we would, or economic system we would operate under in the United States, rising up again as an idea. So how do we think about that again in the 21st century? About these ideas, fundamental deep ideas of communism and capitalism.
So in the Marxist schema, there was something called feudalism, which was supposedly destroyed by the bourgeoisie who created capitalism. And then the working class was supposed to destroy capitalism and create socialism. But socialism wasn't the end stage. The end stage was going to be communism. So that's why the Communist in the Soviet Union first built socialism, transcending capitalism. The next stage was socialism. And the end game, the final stage, was communism. So their version of socialism was derived from Marx. And Marx argued that the problem was capitalism had been very beneficial for a while. It had produced greater wealth and greater opportunity than feudalism had. But then it had come to serve only the narrow interests of the so-called bourgeoisie or the capitalists themselves. And so for humanity's sake, the universal class, the working class, needed to throw capitalism in order for greater productivity, greater wealth to be produced, for all of humanity to flourish and on a higher level. So you couldn't have socialism unless you destroyed capitalism. So that meant no markets, no private property, no so-called parliaments or bourgeois parliaments, as they were called. So you got socialism in Marx's schema by transcending, by eliminating capitalism. Now, Marx also called for freedom. He said that this elimination of markets and private property and bourgeois parliaments would produce greater freedom in addition to greater abundance. However, everywhere this was tried, it produced tyranny and mass violence, death, and shortages. Everywhere it was tried. There's no exception in historical terms. And so it's very interesting. Marx insisted that capitalism had to be eliminated. You couldn't have markets. Markets were chaos. You needed planning. You couldn't have hiring of wage labor. That was wage slavery. And you couldn't have private property because that was a form of theft. So in the Marxist scheme, somehow you were going to eliminate capitalism and get to freedom. It turned out you didn't get the freedom, so then people said, well, you can't blame Marx because he said we needed freedom. He was pro-freedom. So it's kind of like dropping a nuclear bomb. You say you're going to drop a nuclear bomb, but you want to minimize civilian casualties. So the dropping of the nuclear bomb is the elimination of markets, private property, and parliaments. But you're going to bring freedom, or you're going to minimize civilian casualties. So you drop the nuclear bomb, you eliminate the capitalists, and you get famine, deportation, no constraints on executive power, and not abundance, but shortage. People say, well, that's not what Marx said. That's not what I said. I said I wanted to minimize civilian casualties. The nuclear bomb goes off, and there's mass civilian casualties. And you keep saying, but I said drop the bomb, but minimize civilian casualties. So that's where we are. That's history, not philosophy. I'm speaking about historical examples, all the cases that we have. Marx was not a theorist of inequality. Marx was a theorist of alienation, of dehumanization, of fundamental constraints, or what he called fetters, on productivity and on health, which he all attributed to capitalism. Marx wasn't bothered by inequality. He was bothered by something deeper, something worse, right? Those socialists who figured this out, who understood that if you dropped the nuclear bomb, there was no way to minimize civilian casualties. Those socialists who came to understand that if you eliminated capitalism, markets, private property, and parliaments, if you eliminated that, you wouldn't get freedom. Those Marxists, those socialists, became what we would call social democrats, or people who would use the state to regulate the market, not to eliminate the market. They would use the state to redistribute income, not to destroy private property and markets. And so this, in the Marxist schema, was apostasy, because they were accepting markets and private property. They were accepting alienation and wage slavery. They were accepting capitalism in principle, but they wanted to fix it. They wanted to ameliorate it. They wanted to regulate it. And so they became what was denounced as revisionists, not true Marxists, not real revolutionaries, but parliamentary rogue, parliamentarians. We know this as normal politics, normal social democratic politics from the European case or from the American case. But they are not asking to eliminate capitalism, blaming capitalism, or blaming markets and private property. So this rift among the socialists, the ones who are for elimination of capitalism, transcending capitalism, otherwise you could never, ever get to abundance and freedom in the Marxist scheme, versus those who accept capitalism but want to regulate and redistribute. That rift on the left has been with us almost from the beginning. It's a kind of civil war on the left between the Leninists and the Social Democrats, or the revisionists, as they're known pejoratively by the Leninists. We have the same confusion today in the world today, where people also cite Marx saying capitalism is a dead end, and we need to drop that nuclear bomb and get freedom, get no civilian casualties, versus those who say, yes, there are inequities, there's a lack of equality of opportunity, there are many other issues that we need to deal with, and we can fix those issues, we can regulate, we can redistribute. I'm not advocating this as a political position. I'm not taking a political position myself. I'm just saying that there's a confusion on the left between those who accept capitalism and want to regulate it versus those who think capitalism is inherently evil, and if we eliminate it, we'll get to a better world, when in fact history shows that if you eliminate capitalism, you get to a worse world. The problems might be real, but the solutions are worse.
From history's lessons, now we have deep, painful lessons, but there's not that many of them. You know, our history is relatively short as a human species. Do we have a good answer on the left of Leninist Marxist versus social democrat versus capitalism versus any anarchy? You know, do we have sufficient samples from history to make better decisions about the future of our politics and economics?
For sure. We have the American Revolution, which was a revolution not about class, not about workers, not about a so-called universal class or the working class, elimination of capitalism, markets, and bourgeoisie. It was about the category citizen. It was about universal humanity, where everyone, in theory, could be part of it as a citizen. The revolution fell short of its own ideals. Not everyone was a citizen. For example, if you didn't own property, you were a male but didn't own property, you didn't have full rights as a citizen. If you were a female, whether you owned property or not, you are a full citizen. If you were imported from Africa against your will, you were a slave and not a citizen. And so not everyone was afforded the rights in actuality that were declared in principle. However, over time, the category citizen could expand, and slaves could be emancipated, and they could get the right to vote. They could become citizens. Non-property owning males could get the right to vote and become full citizens. Females could get the right to vote and become full citizens. In fact, eventually my mother was able to get a credit card in her own name in the 1970s without my father having to co-sign the paperwork. It took a long time, but nonetheless, the category citizen can expand and it can become a universal category. So we have that, the citizen universal humanity model of the American Revolution, which was deeply flawed at the time it was introduced, but fixable over time. We also had that separation of powers, the constraint on executive power that began this conversation. That was also institutionalized in the American Revolution because they were afraid of tyranny. They were afraid of unconstrained executive power. So they built a system that would contain that, constrain it institutionally, not circumstantially. So that's a great gift. Within that universal category of citizen, which has over time come closer to fulfilling its original promise, and within those institutional constraints, that separation of powers, constraint on executive power, within that, we've developed what we might call normal politics, left-right politics. People can be in favor of redistribution and government action, and people can be in favor of small government, hands-off government, no redistribution or less redistribution. That's the normal left-right political spectrum where you respect the institutions and separation of powers, and you respect the universal categories of citizenship and equality before the law. I don't see any problems with whatsoever. I see that as a great gift, not just to this country, but around the world and other places besides the United States that develop it. The problems arise at the extremes, the far left and the far right, that don't recognize the legitimacy either of capitalism or of democratic or law institutions. And they want to eliminate constraints on executive power. They want to control the public sphere, diminish the independence of the media. They want to take away markets or private property, and redistribution becomes something bigger than just redistribution. It becomes actually that original Marxist idea of transcending capitalism. So I'm not bothered by the left or the right. I think they're normal, and we should have that debate. We're a gigantic, diverse country of many different political points of view. I'm troubled only by the extremes that are against the system, class system, that want to get rid of it, and supposedly that will be the right path to the future. History tells us that the far left and the far right are wrong about that. But once again, this doesn't mean that you have to be a social democrat. You could be a libertarian. You could be a conservative. You could be a centrist. You could be conservative on some issues and liberal on other issues. All of that comes under what I would presume to be normal politics. And I see that as the important corrective mechanism. Normal politics and market economies, non-monopolistic, open, free, and dynamic economies. I don't like concentrations of power politically, and I don't like concentrations of power economically. I like competition in the political realm. I like competition in the economic realm. This is not perfect. It's constantly needs to be protected and reinvented. There are flaws that are fundamental and need to be adjusted and addressed and everything else, especially equality of opportunity. Equality of outcome is unreachable and is a mistake because it produces perverse and unintended consequences. Equality of outcome attempts to make people equal on the outcome side. but attempts to make them more equal on the front end, on the opportunity side. That's really, really important for a healthy society. That's where we've fallen down. Our schools are not providing quality of opportunity for the majority of people in all of our school systems. And so I see problems there. I see a need to invest in ourselves, invest in infrastructure, invest in human capital, create greater equality of opportunity, but also to make sure that we have good governance, because governance is the variable that enables you to do all these other things.
I've watched quite a bit, returning back to Putin. I've watched quite a few interviews with Putin and conversations, especially because I speak Russian fluently, I can understand often the translation things a lot.
Mm.
I find the man putting morality aside very deep and interesting. And I found almost no interview with him to get at that depth. I was very hopeful for the Oliver Stone documentary, and with him, and to me, because I deeply respect Oliver Stone as a filmmaker in general, but it was a complete failure in my eyes, that interview. The lack of it. I mean, I suppose you could toss it up to a language barrier, but a complete lack of diving deep into the person. That's what I saw. My question is a stranger, but if you were to sit down and have a conversation, or perhaps if you were to sit down with Stalin and have a conversation, what kind of questions would you ask? This wouldn't be televised unless you want it to be. So this is only you. You're allowed to ask about some of the questions that are sort of not socially acceptable, meaning putting morality aside, getting to the depth of the human character. What would you ask?
So once again, they're very different personalities and very different time periods and very different regimes. So what I would talk to Stalin about and Putin about are not in the same category necessarily. So let's take Putin. So I would ask him where he thinks this is going, where he thinks Russia's going to be in 25 years or 50 years. What's the long-term vision? What does he anticipate the current trends going to produce? Is he under the illusion that Russia is on the upswing, that things are actually going pretty well, that in 25 years Russia is going to still be a great power with a tremendous dynamic economy, a lot of high tech, a lot of human capital, wonderful infrastructure, very high standard of living, a secure borders and sense of security at home? Does he think the current path is leading in that direction? And if not, if he understands that the current trajectory does not provide for those kinds of circumstances, does it bother him? Does he worry about it? Does he care about the future 25 or 50 years from now?
Deep down, what do you think his answer is? The honest answer.
Either he thinks he's on that trajectory already, or he doesn't care about that long-term trajectory. So that's the mystery for me. He's clever. He has tremendous sources of information. He has great experience now as a world leader, having served for effectively longer than Lenin and Brezhnev's long 18-year reign. And so Putin has accumulated a great deal of experience at the highest level compared to where he started. And so I'm interested to understand how he sees this long-term evolution or non-evolution of Russia. Whether he believes he's got them on the right trajectory, or whether if he doesn't believe that, he cares. I have no idea because I've never spoken to him about this, but I would love to hear the answer. Sometimes you have to ask questions not directly like that, but you have to come a little bit sideways. You can elicit answers from people by making them feel comfortable and come inside.
And just a quick question to that. It's talking about Russia.
Yeah.
Putin's role in Russia. Do you think it's interesting to ask, or to say the same for Stalin, a more personal question of how do you feel yourself about this whole thing, about your life, about your legacy, and looking at the person that's one of the most powerful and important people in the history of civilization, both Putin and Stalin.
Once you experience power at that level, it becomes something that's almost necessary as a human being. It's a drug, it's an aphrodisiac, it's a feeling. You know, you go to the gym to exercise, and the endorphins, chemicals get released. And even if you're tired or you're sore, you get this massive chemical change, which has very dynamic effects on how you feel, the kind of level of energy you have for the rest of the day. And if you do that for a long time, and then you don't do it for a while, you're like a drug addict not getting your fix. You miss it. Your body misses that piece of endorphins to a certain extent. That's how power works for people like Putin. That's how power works for people who run universities or secretaries of state or run corporations, fill in the blank. In whatever ways power is exercised, it becomes almost a drug to people. It becomes something that's difficult for them to give up. It becomes a part of who they are. It becomes necessary for their sense of self and well-being. The greatest people, the people I admire the most, are the ones that can step away from power, can give it up, can give up the drug, can be satisfied, can be stronger even by walking away from continued power when they have the option to continue. So with a person like Putin, once again, I don't know him personally, so I have no basis to judge this. This is a general statement observable with many people and in historical terms. With a person like Putin who's exercised this much power for this long, it's something that becomes a part of who you are, and you have a hard time imagining yourself without it. You begin to conflate your personal power with the well-being of the nation. You begin to think that the more power you have, the better off the country is, this conflation. You begin to be able to not imagine. You can no longer imagine what it would be like just to be an ordinary citizen or an ordinary person running a company, even something much smaller than the country. So I anticipate that, without knowing for sure, that he would be in that category of person. But you want to explore that with questions with him about, so what's his day look like from beginning to end? Just take it through a typical day of yours. What do you do in a day? How does it start? What are the ups? What are the downs? What are the parts of the day you look forward to the most? What are the parts of the day you don't look forward to that much? What do you consider a good day? What do you consider a bad day? How do you know that what you're doing is having the effects that you intend? How do you follow up? How do you gather the information, the reaction? How do you get people to tell you to your face things that they know are uncomfortable or that you might not want to hear? Those kind of questions.
And through that window, through that kind of questioning, you get a window into a man with power. So let me ask about Stalin, because you've done more research. In another amazing interview you've had, the introduction was that you know more about Stalin than Stalin himself. You've done an incredible amount of research on Stalin. So if you could talk to him, get sort of direct research, what question would you ask Stalin?
I have so many questions, I don't even know where I would begin. The thing about studying a person like Stalin, who's an immense creature, he's exercising the power of life and death over hundreds of millions of people. He's making decisions about novels, films, and turbines and submarines, and pacts with Hitler or deals with Churchill and Roosevelt, and occupation of Mongolia, or occupation of North Korea. He's making phenomenally consequential decisions over all spheres of life, all areas of endeavor, and over much of the globe, much of the landmass of the earth. And so, what's that like? Does he sometimes reflect on the amount of power and responsibility that he can exercise? Does he sometimes think about what it means that a single person has that kind of power? And does it have an effect on his relations with others, his sense of self, the kinds of things he values in life? Does he sometimes think it's a mistake that he's accumulated this much power? Does he sometimes wish he had a simpler life? Or is he once again so drunk, so enamored, so caught up with, chemically and spiritually, with exercising this kind of power, that he couldn't live without it? And then, what were you thinking, I guess, in certain decisions that he made? What were you thinking on certain dates and certain circumstances where you made a decision and could have made a different decision? Can you recall your thought process? Can you bring the decision back? Was it seat of the pants? Was it something you could plan? Did you just improvise, or did you have a strategy? What were you guided by? Whose examples did you look to? When you picked up these books that you read, and you read the books and you made pencil marks in them, is it because you absorbed the lesson there? Or did it really not become a permanent lesson? It was just something that you checked and it was like a reflex. So I have many specific questions about many specific events and people and circumstances that I have tried to figure out with the surviving source materials that we have in abundance. But I would still like to delve into his mindset and reconstruct his mind. The closer you get to Stalin, in some ways, the more elusive he can be.
Yeah, especially around World War II, you've already eliminated a lot of interesting aspects about Stalin's role in the war. But it'd be interesting to ask even more questions about how seat of the pants or deliberate some of the decisions. If I could ask just one quick question, one last quick question. And you're constrained in time and answering, do you think there will always be evil in the world? Do you think there will always be war?
Unfortunately, yes. There are conflicting interests, conflicting goals that people have. Most of the time, those conflicts can be resolved peacefully. That's why we build strong institutions, to resolve different interests and conflicts peacefully. But the enduring fact of conflicting interests and conflicting desires, that can never be changed. So the job that we have for humanity's sake is to make those conflicting interests, those conflicting desires, to make them, to put them in a context where they can be resolved peacefully and not in a zero-sum fashion. So we can't get there on the global scale. So there's always going to be the kind of conflict that sometimes gets violent. What we don't want is a conflict among the strongest powers. Great power conflict is unbelievably bad. There are no words to describe it. At least 55 million people died in World War II. If we have a World War III, a war between the United States and China or whatever it might be, who knows what the number could be? 155 million, 255 million, 555 million. I don't even want to think about it. And so it's horrible when wars break out in the humanitarian catastrophes. For example, Yemen, and Syria, and several other places I could name today. It's just horrible what you see there. And the scale is colossal for those places. But it's not planetary scale. And so avoiding planetary scale destruction is really important for us. And so having those different interests be somehow managed in a way that that no one sees advantage in a violent resolution.
And a part of that is remembering history. So they should read your books. Stephen, thank you so much. It was a huge honor talking to you today. I really enjoyed it.
Thank you for the opportunity. My pleasure.
Thanks for listening to this conversation with Stephen Conklin. And thank you to our presenting sponsor, Cash App. Download it and use code Let's Podcast. You'll get $10. $10 will go to First, a STEM education nonprofit that inspires hundreds of thousands of young minds to become future leaders and innovators. If you enjoy this podcast, subscribe on YouTube, give it 5 stars on Apple Podcasts, support it on Patreon, and connect with me on Twitter. And now, let me leave you with words of Joseph Stalin, spoken shortly before the death of Lenin and at the beginning of Stalin's rise to power. First, in Russian. Я считаю, что совершенно не важно, кто и как будет пойти голосовать. Но вот что чрезвычайно важно, это кто и как будет считать голоса. I consider it completely unimportant who in the party will vote or how. But what is extraordinarily important is who will count the votes and how. Thank you for listening and hope to see you next time. The following is a conversation with Grant Sanderson. He's a math educator and creator of 3 Blue 1 Brown, a popular YouTube channel that uses programmatically animated visualizations to explain concepts in linear algebra, calculus, and other fields of mathematics. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, and 5 stars on Apple Podcasts, follow on Spotify, support on Patreon, or simply connect with me on Twitter. Friedman, spelled F-R-I-D-M-A-N. I recently started doing ads at the end of the introduction. I'll do 1 or 2 minutes after introducing the episode, and then reading the ads in the middle that can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. This show is presented by Cash App, the #1 finance app in the App Store. I personally use Cash App to send money to friends, but you can also use it to buy, sell, and deposit Bitcoin in just seconds. Cash App also is an investing feature. You can buy a fraction of the stock, say $1 worth, no matter what the stock price is. Brokerage services are provided by Cash App Investing, a subsidiary of Square, and member SIPC. I'm excited to be working with Cash App to support one of my favorite organizations called First, best known for their FIRST robotics and Lego competitions. They educate and inspire hundreds of thousands of students in over 110 countries and have a perfect rating at Charity Navigator, which means the donated money is used with maximum effectiveness. When you get Cash App, the App Store, and Google Play, and use code Lux Podcast, you'll get $10. Cash App will also donate $10 to First, which again is an organization that I've personally seen inspire girls and boys to dream of engineering a better world. And now, here's my conversation with Grant Sanderson. If there's intelligent life out there in the universe, do you think their mathematics is different than ours?
Jumping right in, I think it's probably very different. There's an obvious sense, the notation is different, right? I think notation can guide what the math itself is. I think it has everything to do with the form of their existence, right?
Do you think that basic arithmetic?
Yeah, so I think they count, right? I think notions like 1, 2, 3, the natural numbers, that's extremely natural. That's almost why we put that name to it. As soon as you can count, you have a notion of repetition, right? Because you can count by two times, 3 times. And so you have this notion of repeating the idea of counting, which brings you addition and multiplication. I think the way that we extend it to the real numbers, there's a little bit of choice in that. So there's this funny number system called the surreal numbers that it captures the idea of context. It's a distinct mathematical object. You could very well, model the universe in motion of planets with that as the back end of your math, right? And you still have kind of the same interface with the front end of what physical laws you're trying, or what physical phenomena you're trying to describe with math. And I wonder if the little glimpses that we have of what choices you can make along the way, based on what different mathematicians have brought to the table, is just scratching the surface of what the different possibilities are if you have a completely different mode of thought, right, or a mode of interaction.
And you think notation is a key part of the journey into that?
I think it's the most salient question. I think the mode of thought is going to influence things more than like the notation itself. But notation actually carries a lot of weight when it comes to how we think about things, more so than we usually credit for. I would be comfortable saying.
A favorite or least favorite piece in terms of its effectiveness?
Yeah, least favorite. One that I've been thinking about that will be a video I don't know when, but we'll see. The number e. We write the function e to the x, this general exponential function, with a notation to the x that implies think about a particular number, this constant of nature, and you repeat that. And then you say, oh, what's e to the square root of 2? You're like, oh, well, we've extended the idea of repeated multiplication. That's all nice. That's all nice as well. But very famously, you have like e to the pi I, over extending the idea of repeated multiplication into complex numbers. Yeah, you can think about it that way. In reality, I think that it's just the wrong way of notationally representing this function, the exponential function, which itself could be represented a number of different ways. You can think about it in terms of the problem it solves, a certain very simple differential equation, which often yields way more insight than trying to twist the idea of repeated multiplication, take its arm and put it behind its back desk and be like, you will apply to complex numbers, right? That's not, I don't think that's pedagogically helpful. And
so the repeated multiplication is actually missing the main point, the power of e to the x.
Yes. What it addresses is things where the rate at which something changes depends on its own value, but more specifically, it depends on it linearly. So, for example, if you have like a population that's growing and the rate at which it grows depends on how many members of the population are already there, it looks like this nice exponential curve. It makes sense to talk about repeated multiplication because you say, how much is there after 1 year, 2 years, 3 years, multiply this. The relationship can be a little bit different sometimes, where let's say you've got a ball on a string, like a game of tetherball going around the rope, right? And you say its velocity is always perpendicular to its position. That's another way of describing its rate of change as being related to where it is, but it's a different operation. You're not scaling it. It's a rotation. It's this 90-degree rotation. That's what the whole idea of like complex exponentiation is trying to capture, but it's obfuscated in the notation when what it's actually saying, like if you really parse something like e to pi I, what it's saying is choose an origin, always move perpendicular to the vector from that origin to you, okay? And then when you walk pi times that radius, you'll be halfway around. Like that's what it's saying. It's kind of you turn 90 degrees, then you walk, you'll be going in a circle. That's the phenomenon that it's describing, but trying to twist the idea of repeatedly multiplying a constant to that, like I can't even think of the number of human hours, of like intelligent human hours that have been wasted trying to parse that to their own like human desire among like scientists or electrical engineers or students everywhere, which if the notation were a little different or the way that this whole function was introduced from the get-go were framed differently, I think could have been avoided, right?
And you're talking about the most beautiful equation in mathematics, but it's still pretty mysterious, isn't it? Like,
No,
you're making it seem like it's a notation.
it's not mysterious. I think the notation makes it mysterious. I think the fact that it represents, it's pretty. It's not like the most beautiful thing in the world, but it's quite pretty. The idea that you do the linear operation of a 90-degree rotation, and then general exponentiation through it. I think what you get are all the other kinds of rotation, which is basically to say if your velocity is perpendicular to your position vector, you walk in a circle. That's pretty. It's not the most beautiful thing in the world, but it's quite pretty.
The beauty of it, I think, comes from perhaps the awkwardness of the notation, somehow still nevertheless coming together, and kind of like several different coming together in a single equation.
Well,
a sense, like historically speaking.
That's true. So like the number E is significant. Like it shows up in probability all the time. It like shows up in calculus all the time. It is significant. You're seeing it sort of mated with pi, the geometric constant in I, or the imaginary number and such. I think really happening there is the way that we show up is when you have things like exponential growth and decay, right? It's when this relation that something's rate of change has to itself is a simple scale, right? A similar law also describes circular motion. Because we have bad notation, we use the residue of how it shows up in the context of self-reinforcing growth, like a population growing or compound interest. The constant associated with that is awkwardly placed into the context of how rotation comes about, because they both come from pretty similar equations. And so what we see is the E and the pi juxtaposed a little bit closer than they would be with a purely natural representation, I would think. Here's how I would describe the relation between them. You've got a very important function you might call x. It's like the exponential function. When you plug in 1, you get this nice constant called e that shows up in the probability and calculus. If you try to move in the imaginary direction, it's periodic, and the period is tau. So those are these two constants associated with the same central function, but for kind of unrelated reasons, right? And not unrelated, but like orthogonal reasons. One of them is what happens when you move in the real direction. One's what happens when you move in the imaginary direction. And like, yeah, those are related. They're not as related as the famous equation seems to think it is. It's sort of putting all of the children in one bed, and they kind of like to sleep in separate beds if they have the choice. But you see them all there. There is a family resemblance, but it's not that close.
So actually, think of it as a function is the better idea, and that's a notational idea.
And yeah, and like here's the thing: the constant e sort of stands as this numerical representative of calculus, right? Calculus is the like study of change. So at the very least, there's a little cognitive dissonance using a constant to represent the science of change.
Never thought of it that way. Yeah,
Right?
yeah.
It makes sense why the notation came about that way, because it's just it's not in the context of things like population growth or compound interest. It is nicer to think about as repeated multiplication. Definitely nicer. But it's more that that's the first application of what turned out to be a much more general function that maybe the intelligent life the initial question asked about would have come to recognize as being much more significant than the single use case, which lends itself to repeated multiplication notation. But
Let me jump back for a second to aliens and the nature of our universe. Okay. Do you think math is discovered or invented? So about the different kind of mathematics that could be developed by the alien species. The implied question is it's not discovered or invented. It's fundamentally going to discover the same principles of mathematics.
So the way I think about it, and everyone thinks about it differently, but it's my thing. I think there's a cycle at play where you discover things about the universe that tell you what math will be useful, and that math itself is invented in a sense. But of all the possible maths that you could have invented, it's discoveries about the world that tell you. So like a good example here is the Pythagorean theorem. When you look at this, do you think that as a definition, or do you think of that as a discovery?
From the historical perspective, right? It's a discovery. That's probably because they were using physical objects to build their intuition, and from that intuition came mathematics. Mathematics was some abstract world detached from physics, but I think more and more math has become detached from, when you even look at modern physics, from string theory, even general relativity, all math behind the 21st century physics kind of takes a brisk walk outside of what our mind can actually comprehend. And in multiple dimensions, for example, anything beyond 3 dimensions, 4 dimensions.
Highly, highly applicable. I think this is a common misinterpretation that if you're asking questions about like a 5-dimensional manifold, that the only way that that's connected to the physical world is if the physical world is itself a 5-dimensional manifold or includes this.
Well, wait a minute. You're telling me that a 5-dimensional.
No, that's not what I said. I would make the claim that it is used to a 3-dimensional physical universe, despite itself not being 3-dimensional.
So it's useful, meaning to even understand a three-dimensional world, it'd be useful to have five-dimensional. Useful that
For the Pythagorean theorem, for example, it feels like a discovery. You've got these beautiful geometric proofs. You've got squares and modifying values. It feels like a discovery. If you look at how we formalize the ideas as being R2, right, all pairs of real numbers, and how we define a number, you define the distance so that the Pythagorean is true. So that in some way it doesn't feel that great. But I think what's going on is the thing that informed us what metric to put on R2, to put on our abstract representation of 2D space, came from physical observation. And the thing is, there's other metrics we can put on it. We can have consistent math with other notions of distance. It's just that those pieces of math wouldn't be applicable to the physical world that we study because they're not the ones that the Pythagorean theorem holds. So we have a discovery, a genuine bona fide discovery that informed the invention of an abstract representation of 2D space that we call R2 and things like that. And then from there, we just study R2 as an abstract thing that brings about more ideas and inventions and mysteries, which themselves might be like discoveries. Those discoveries might give you insight as to what else would be useful to invent, and it kind of feeds on itself that way. That's how I think about it. It's not an either or. It's not that math is one of these or it's one of the others. At different times, it's playing a different role.
So then, let me ask the Richard Feynman question that along that thread. What do you think is the difference between physics and math? There's a giant overlap. There's a kind of intuition that physicists have about the world that's perhaps outside of mathematics. It's this mysterious art they seem to possess. We humans generally possess. And then there's the beautiful rigor of mathematics that allows you to, just like as we were saying, invent frameworks of understanding our physical world. So what do you think is the difference there? How big is it?
Well, I think of math as being the study of abstractions over patterns and pure patterns in logic. And then physics is obviously grounded in a desire to understand the world that we live in. I think you're going to get very different answers when you talk to different mathematicians because there's a wide diversity of types of mathematicians. There are some who are motivated very much by pure puzzles. They might be turned on by things like combinatorics, but they just love the idea of building up a set of problem-solving tools applying to pure patterns. Right? There are some who are very physically motivated who try to invent new math or discover math in things that they know will have applications to physics or sometimes computer science. And that's what drives it. The chaos theory is a good example of something. It's pure math. It's purely mathematical. A lot of mistakes being made, but it's heavily motivated by specific applications to largely physics. And then you have a type of mathematician who just loves abstraction. They just love pulling it to more and more abstract things, the things that feel powerful. These are the ones that initially think of like topology, and then later on get really into category theory and go on about like infinite categories and whatnot. These are the ones that love to have a system that can describe truths about as many things as possible. Right? People from those three different veins of motivation and math are going to give you very different answers about what the relation to plane theory is. Because someone like Vladimir Arnold was this. He's written a lot of great books about like differential equations and such. He would say math is a branch of physics. That's how he would think about it. And of course, he was studying like differential equations related things because that is the motivator behind the study of PDEs and things like that. But you'll have others who, especially the category theorists, who aren't really thinking about physics necessarily. It's all about abstraction and the power of generality. And it's more of a happy coincidence that ends up being useful for understanding the world we live in. And then you can get into like, why is that the case? It's sort of surprising that that which is about pure puzzles and abstraction also happens to describe the very fundamentals of quarks and everything else.
So why do you think the fundamentals of quarks and the nature of reality is so compressible into clean, beautiful equations that are for the most part simple, relatively speaking? lot simpler than they could be. So you have, we mentioned somebody like Stephen Wolfram, who thinks that sort of there's incredibly simple rules underlying our reality, but create arbitrary complexity. But there is simple equation. What I'm asking a million questions that nobody knows the answer to. But,
Why is it? It could be the case that there's like a filter of information. The only things that physicists find interesting are the ones that are simple enough they can describe it mathematically.
right.
But as soon as it's a sufficiently complex system, like, oh, that's outside the realm of physics. That's biology, or whatever have you. And of course it's true. Right? You know, maybe there's something that's like, of course there will always be some thing that is simple to wash away the like non-important parts of whatever it is that you're studying. Just from like an information theory standpoint, there might be some like you get to the lowest information component of it. And I'm just having a really hard time conceiving of what it would even mean for the fundamental laws be like intrinsically complicated. Like some set of equations you can't decouple from each other.
Well, no, it could be that sort of we take for granted the laws, for example, are for the most part the same everywhere, or something like that, right? As opposed to the sort of the alternative could be that the rules under which the world operates is different everywhere. It's like a deeply distributed system where just everything is just chaos. Like not in a strict definition of chaos, but meaning like just it's impossible for equations to capture, to explicitly model the world as cleanly as the physical world does. I mean, we almost take it for granted that we can have an equation for gravity, for action and distance. We can have the equations for some of these basic ways the planets move, and just the low level at the atomic scale, how the materials operate, at the high scale, how black holes operate. But it doesn't. It seems like it could be. There's infinite other possibilities where none of it could be compressible into such equations. It just seems beautiful. It's also weird, probably to the point you're making, that it's very pleasant that this is true for our minds. Right. So it might be that our minds are biased to just be looking at the parts of the universe that are compressible. And then we can publish papers on and have nice E equals MC squared equations.
Right. Well, I wonder, would such a world with uncompressible laws allow for the kind of beings that you think about, the kind of questions that you're asking?
That's true.
Right? Like an anthropic principle coming into play in some weird way here. I don't know. I don't know what I'm talking about.
Well, maybe the universe is actually not so compressible, but the way our brain evolved will only with the compressible parts. I mean, we are seeing this is a Chomsky argument. We are just descendants of the late. Those are like really limited biological systems. So it totally makes sense that we're really limited little computers, calculators, that are able to perceive certain kinds of things. And the actual world is much more complicated.
Well, but we can do pretty awesome things. Right? Like we can fly spaceships, and we have to have some connection of reality to be able to take our potentially oversimplified model of the world, but then actually twist the world to our will based on it. So we have certain reality checks that physics isn't too far afield, simply based on what we can do.
And the fact that we can fly is pretty good.
That's great. Yeah, it's like
And
a
land.
proof of concept that the laws we're working with are working well.
I mentioned to the internet that I'm talking to you, so the internet keeps the questions. So I apologize for these, but do you think we're living in a simulation? That the universe is a computer, or the universe is a computation running on a computer?
It's conceivable. What I don't buy is, you'll have the argument that, well, if it was the case that you can have simulations, then the simulated world would itself eventually get to a point where it's running simulations.
Yes.
And then the second layer down would create a third layer down, and on and on and on. So probabilistically, you just throw a dart at one of those layers, we're probably in one of the simulated layers. I think if there's some sort of limitations on like the information processing of whatever the physical world is, like it quickly becomes the case that you have a limit to the layers that could exist there, because it's necessary to really is a lot, just in terms of the number of bits of it. And so then you can ask, well, what's more plausible? That there's an unbounded capacity of information processing in whatever the like highest up level universe is, or that there's some bound to that capacity, which then limits like the number of levels available. How do you place some kind of probability distribution on what the information capacity is? I have no idea. But I don't mean like people almost assume a certain uniform probability over all of those meta layers that could conceivably exist when it's a little bit like a Pascal's wager. Like, you're not giving a low enough prior to the mere existence of that infinite set of layers.
Yeah, that's true. But it's also very difficult to contextualize the amount. So the amount of information processing power required to simulate a universe seems like amazingly huge.
But you can always lose two to the power of that. So, yeah, like numbers are big.
And we're easily humbled by basically everything around us. So it's very difficult to kind of make sense of anything. Like, look at the sky and look at the stars and the immensity of it all. To make sense of us, the smallness of us, like everything that's on this earth coming to be. And you could basically anything could be. All laws of probability window to me, because I guess because the amount of information under which we're operating is very low. We basically know nothing about the world around us, relatively speaking. So when I think about the simulation, like I said, it's just fun to think about it. But it's also, I think there is a thought experiment kind of interesting to think of the power of computation, where there are the limits of the Turing machine, the limits of our current computers. When you start to think about artificial intelligence, how far can we get with computers? Mm-hmm. And that's kind of where the simulation of us is useful to me as a thought experiment. Is the universe just a computer? Is it just a computation? Is all of this just a computation? And sort of the same kind of tools we apply to analyzing algorithms can have been applied. As we scale further, will the arbitrary power of those systems start to create some interesting aspects that we see in our universe? Or is something fundamentally different to be created?
Well, it's interesting that in our universe it's not arbitrarily large power. Then you can place limits on, for example, how many bits of information can be stored per unit area, right? Like all of the physical laws, got general relativity and quantum coming together to give you a certain limit on how many bits you can store within a given range before it collapses into a black hole. Like the idea that there even exists such a limit is at the very least thought-provoking. When naively you might assume, oh well, technology could always get better and better, we could get cleverer and cleverer, and you could just cram as much information as you want into like a small unit of space. That makes me think it's at least plausible that whatever the highest level of existence is doesn't admit too many simulations or ones that are at the scale of complexity that we're looking at. Obviously, it's just as conceivable that they do that there are many, but I guess what I'm channeling is the surprise that I felt upon learning that fact, that information is physical in this way.
That there's finite. Okay, let me just even go off on that from a mathematics perspective and a psychology perspective. Are you psychologically comfortable with the concept of infinity?
I think so. Are you okay with it? Are you okay?
No, not really. Because it became something.
I don't know, like how many possible words do you think could exist that are just like strings of letters?
So that's a sort of mathematical statement. It's beautiful, and we use infinity basically everything we do in science, math, and engineering. But you said it's right. The question is, you said letters or words?
I said words.
To bring words into existence, to me, you have to start like saying them, or like writing them, or like listing them. Okay, so I'm going to add that with the idea of abstract.
Yeah.
The idea of abstract notions and ideas.
I think we should be clear on terminology. I mean, you think about intelligence a lot, like artificial intelligence. not say that what it's doing is a kind of abstraction. Like abstraction is key to conceptualizing the universe. You get this raw sensory data. I need something that every time you move your face a little bit, and they're not pixels, but like analog of pixels on my retina change entirely. That I can still have some coherent notion of this is light and how so, right? What that requires is you have a disparate set of possible images hitting me that are unified in the notion of light. Yeah, right? That's a kind of abstraction. It's a thing that could apply to a lot of different images that I see, and it represents it in a much more compressed way, and one that's like much more resilient to that. I think in the same way, if I'm talking about infinity as an abstraction, I don't mean non-physical, woo-woo, it's like ineffable or something. What I mean is it's something that can apply to a multiplicity of situations that share a certain common attribute. In the same way that the images of like your face on my retina share enough common attributes that I can put this single notion to it. Like in that way, infinity is an abstraction and very powerful. And it's only through such abstractions that we can actually understand the world and logic of things. If you think about it, the key entity is the property of always being able to add one thing. Like no matter how many words you can list, you just throw an A at the end of it, have another conceivable word. You don't have to think of all the words at once. It's that property, I could always add one more, that gives it this nature of infinity. In the same way that there's certain like properties of your face that give it the flex that's right. So like infinity should be no more word than the I can always add one more sentence.
That's a really elegant, much more elegant way that I could put it. So thank you for doing that as yet another abstraction. Yes, indeed. That's what our brain does. That's what intelligent systems do. That's what programming does. That's what science does. Is build abstractions on top of each other. And yet, there is a certain point of abstractions that go into
How are you?
well, you.
Well, apologies.
And because we're
Now,
now
honestly, I hope you have a wonderful day. And if you're bored during the day, come
the only
play
thing
with
that's true is the stuff that's on the ground. Everything else is useful for interpreting.
me.
And at a certain point, you might start floating into ideas that are surreal and difficult, takes us into areas that are disconnected from reality and we can never get back.
What if instead of calling these abstract, how different would it be in your mind if we called them general? The phenomenon you're describing is overgeneralization. When you try to have a concept or an idea that's so general as to apply to nothing in particular in a useful way, does that map to what you're thinking of when you go?
First of all, I'm playing literal, just fun.
Yeah,
And devil's advocate. And I think our cognition, our minds, unable to visualize. So you do some incredible work with visualization of media. I think infinity is very difficult to visualize for our mind. We can delude ourselves into thinking we can visualize it. We can't. I don't. That means I don't. I would venture to say it's very difficult. So there's some concepts in mathematics, like maybe talk about, they're impossible for us to truly intuit. Like, and it just feels dangerous to me to use these as part of our toolbox of abstractions.
On behalf of your listeners, I almost fear we're getting too philosophical. Right?
No, heck no, heck no.
But I think to that point, for any particular idea, there's multiple angles of attack. I think when we do visualize infinity, what we're actually doing, you write dot dot dot, right? 1, 2, 3, 4, dot dot dot, right? Those are symbols on the page that are insinuating a certain infinity. What you're capturing with a little bit of design there is the I can always add one more property, right? I think I'm just as uncomfortable with you are if you try to concretize it so much that you add infinitely many things that I actually think of no, not 1, 2, 3, 4, dot dot dot, 1, 2, 3, 4, 5, 6, 7, 8. I try to get them all in my head, and you realize, oh, your brain would literally collapse into a black hole. All of that, and I honestly feel this with a lot of math that I try to, where I don't think so. Like particularly good at math. The ones like I get very confused often when I am going through some of these texts, and often what I feel in my head is like, this is just so damn abstract. I just can't wrap my head around it. I just want to put something concrete to it that makes me understand. And I think a lot of the motivation channel is channeling that sentiment of, yeah, a lot of things that you're trying to read out there, it's just so hard to connect to anything that you spend an hour banging your head against a couple of pages and you come out not really knowing anything more other than some definitions maybe and a certain sense of self-defeat, right? One of the reasons I focus so much on visualizations is that I'm a believer in, I'm just really hampering on this idea of abstraction. Being clear about your layers of abstraction, right? It's always tempting to start an explanation from the top to the bottom, okay? You give the definition of a new theorem. Like this is the definition of a vector space, for example. Let's start a course. These are the properties of a vector space. You know, first from these properties, we will derive what we need in order to do the math and layer out whatever. I don't think that's how understanding works at all. I think how understanding works is you start at the lowest level you can get at, where rather than thinking about a vector space, you might think of concrete vectors that are just lists of numbers, or picturing it as like an arrow that you draw, which is itself like even less abstract than numbers because you're looking at quantities, like the distance of the x coordinate, the distance of the y coordinate. It's as concrete as you could possibly get, and it has to be if you're putting it in a visual book, right? Like it's an actual arrow. It's an actual vector. You're not talking about like a quote unquote vector that could apply to any possible thing. You have to choose one if you're illustrating it. And I think this is the power of being in a medium like video, or if you're writing a textbook and force yourself to put a lot of images, is with every image, you're making a choice. With each choice, you're showing a concrete example. With each concrete example, you're aiding someone's path to understanding.
Yeah, absolutely. Interrupt you, but you just made me realize that that's exactly right. So the visualizations you're creating, while you're sometimes talking about abstraction, the actual visualization is an explicit low-level example.
Yes.
But there's an action. Like in the code, you have to say what the vector is, what's the direction of the arrow, what's the magnitude. Yeah, so that's, you're going, the visualization itself is actually going to the bottom.
I think that's very important. I also think about this a lot in writing scripts, where even before you get to the visuals, the first instinct is to, I don't know why, I just always do abstract thing. I say the general definition, the powerful thing, and then I fill it in with examples later. Always, it will be more compelling and easier to understand when you flip that. And instead, you let someone's brain do the pattern recognition. You just show them a bunch of examples. The brain is going to feel a certain similarity between that and the definition, but by the time you bring in the formula, it's articulating a thing that's already in the brain that was built off of looking at a bunch of examples with a certain kind of similarity. And what the formula does is articulate what that kind of similarity is, rather than being a high cognitive load set of symbols that needs to be populated with examples later on, assuming someone's still with you.
What is the most beautiful or awe-inspiring idea you've come across in mathematics? Maybe it's an idea you've explored in videos, maybe not. What, like, just gave you pause?
It's the most beautiful idea.
Small or big?
So I think often the things that are most beautiful are the ones that you have like a little bit of understanding of, but it's not an entire understanding. It's a little bit of that mystery that is what makes it beautiful.
What was a moment of discovery for you personally, almost just that leap of the aha moment?
So something that really caught my eye. I remember when I was little, there was like I think the series was called like Wooden Books or something. These tiny little books that would have just a very short description of something on the left and then a picture on the right. I don't know who they're meant for, but maybe it's like loosely children or something like that. But it can't just be children because of some of the things that I've described. On the last page of one of them, somewhat tiny in there was this little formula that on the left hand had a sum over all of the natural numbers. And that was like 1 over 1 to the s plus 1 over 2 to the s plus 1 over 2 to the s on and on to infinity. And then on the other side, it had a product over all of the primes. And it was a thing that had to do with all the primes. And like any good young math, they've probably been indoctrinated with how chaotic and confusing the primes are. They are. And seeing this equation where on one side you have something that's as understandable as you could possibly get to be counting numbers, and on the other side is all the prime numbers. It was like this. Whoa, they're related like this? There's a simple description that includes like all the primes getting wrapped together like this. This is like the Euler product for zeta function, as I later found out. essentially encodes the fundamental theorem of arithmetic that every number could be expressed as a unique set of primes. To me, still, I certainly don't understand this equation or this function all that well. The more I learn about it, the prettier it is. The idea that you can, like, this is sort of what gets you representations of primes, not in terms of primes themselves, but in terms of another set of numbers, the non-trivial zeros of the zeta function. And again, I'm very kind of in over my head in a lot of ways as I try to understand it. But the more I do, it always leaves enough mystery that it remains very beautiful to me.
So whenever there's a little bit of mystery just outside of the understanding, that, and by the way, the process of learning more about it, how does that come about? Thoughts, or are you reading the process of visualization itself, revealing more to you?
And one time when I was just trying to understand like analytic continuation and playing around with visualizing complex functions, this is what led to a video about this function. It's titled something like Visualizing the Riemann Zeta function. It's one that came about because I programming and tried to see what a certain thing looked like. And then I looked at it like, whoa, that's elucidating. And then I decided to make a video about it. But I mean, you try to get your hands on as much reading as you can. You know, in this case, I think if anyone wants to start to understand it, if they have like a math background or something, like they studied something in college or something like that, like the Princeton Companion to Math has a really good article on analytic number theory, and that itself has a whole bunch of references. And you know, anything has more references, it gives you this like tree to start following through. And like, you know, you try to understand. I try to understand things visually as I go. It's not always possible, but it's very helpful when it does. You recognize when there's common themes. Like in this case, cousins of the Fourier transform that come into play. And you're like, oh, it's probably pretty important to have deep intuitions in the Fourier transform, even if it's not explicitly mentioned in like these texts. And you try to get the sense of what the common players are. But I'll emphasize again, like I feel very in over my head when I try to understand the exact relation between like the zeros of the Riemann Zeta function and how they relate to the distribution of primes. I definitely understand it better than I did a year ago. I definitely understand it 1/100th as well as the experts on the matter do. So, but the slow path towards getting there is it's fun, it's charming, and like to your question, very beautiful.
And the beauty is in the journey versus the destination.
Well, each thing doesn't feel arbitrary. I think that's a big part. Is that you have these unpredictable, these very unpredictable patterns for these intricate properties of like a certain function. But at the same time, it doesn't feel like humans ever made an arbitrary choice in studying this particular thing. So, you know, it feels like you're speaking to patterns themselves, their nature itself. That's a big part of it. I think things that are too arbitrary, it's just hard for them to feel beautiful because this is sort of what the word contrived is meant to apply to, right?
And when they're not arbitrary, it means you can have a clean abstraction in intuition that allows you to comprehend it.
Well, to one of your first questions, it makes you feel like if you came across another intelligent civilization, that they'd be studying the same thing.
Right? Maybe with different notation.
But yeah, like that's what I think you talked about other civilizations. They're probably also studying the zeros of the Riemann Zeta function, or like some variant thereof that is like a clearly equivalent or something like that. But that's probably on their docket.
Whenever somebody does a lot of something amazing, I'm going to ask the question that you've already been asked a lot, but you get one more asked in your life. But what was your favorite video to create?
One of my favorites is the title is "Who Cares About Topology?"
You want me to pull it up?
If you want, sure, yeah. It is about. Well, it starts by describing an unsolved problem that's still unsolved in math, called the inscribed square problem. You draw any loop, and then you ask are there 4 points on that loop that make a square. Totally useless, right? This is not answering any physical questions. It's mostly interesting that we can't answer that question, and it seems like such a natural thing to ask. Now, if you weaken it a little bit and you ask, can you always find a rectangle? You choose 4 points on this curve to find a rectangle. That's hard, but it's doable, and the path to it involves things like look at a torus, this surface with a single hole in it, like a donut, looking at a Mobius strip, in ways that feel so much less contrived to when I first, as like a little kid, learned about these surfaces and shapes, like a Mobius strip and a torus. Like what you learn is, oh, this Mobius strip, you take a piece of paper, put a twist, glue it together, and now you have a shape with one edge and just one side. And the student, you should think, who cares, right? Like, how does that help you solve the problem? So I thought math was about problem solving. So what I liked about the piece of math that this was describing, that was in this paper by Mathematician and Bond, was that it arises very naturally. It's clear what it represents. It's doing something. It's not just playing with construction paper. And the way that it solves the problem is really beautiful. So kind of putting all of that down and concretizing it, right? Like I was talking about how when you have to put visuals to it, it demands that what's on screen is a very specific example of what you're describing. The construction here is very abstract in nature. You describe this very abstract kind of surface in 3D space. So then when I was finding myself, in this case I wasn't programming, I was using Grapher that's like built into OS X for the 3D stuff, to draw that surface. You realize, oh, technology is very non-constructive. I have to make a lot of, you have to do a lot of extra work in order to make the surface show up. But then once you see it, it's very pretty. And it's very satisfying to see a specific instance of it. And you also feel like, I've actually added something on top of what the original paper was doing. That it shows something that's completely correct. It's a very beautiful argument, but you don't see what it looks like. And I found something satisfying in seeing what it looked like that could only ever come about from the forcing function of getting some kind of thing on the screen to describe the thing I was talking about.
You almost weren't able to anticipate what it's going to look like.
I had no idea. I had no idea, and it was perfect. It was totally. It looks like a Sydney Opera House or some sort of Frank Gehry design, and it was. You knew it was going to be something, and you can say various things about it, like, oh, it touches the curve itself. It's this curve on the 3D plane. It all sits above the plane, but before you actually do it, it's very unclear what the thing will look like. And to see it, it's just pleasing, right? So that was fun to make, very fun to share. I hope that it has elucidated for some people out there where these constructs of topology come from, that it's not arbitrary play with construction paper.
So I think that's a good sort of example to talk a little bit about your process. So you have a list of ideas. That's sort of the curse of having an active and brilliant mind. I'm sure you have a list that's growing faster than you can utilize. Absolutely. But there's some sorting procedure depending on mood and interest. But okay, so you pick an idea, then you have to try to write a narrative arc. Sort of, how do I elucidate, how do I make this idea beautiful and clear and explain it? And then there's a set of visualizations that will be attached to it. So you've talked about some of this before, sort of writing the story, attaching visualizations. Can you talk to interesting, painful, beautiful parts of that process?
Well, the most painful is if you've chosen a topic that you do want to do, but then it's hard to think of, I guess, how to structure the script. This is sort of where I have been on one for like the last 2 or 3 months. And I think the ultimately the right resolution is just like set it aside and instead do some other things where the script becomes more natural. Because you sort of don't want to overwork a narrative. Like the more you've thought about it, the less you can empathize with the student who doesn't yet understand the thing you're trying to teach.
Who is the judger in your head? Sort of the person, the creature, the essence that's saying this sucks or this is good. And you mentioned kind of the student you're thinking about. Can you who is that? What is that thing? That says the perfectionist that says this thing sucks. We need to work on it for another 2-3 months.
I don't know. I think it's my past self. I think that's the entity that I'm most trying to empathize with. Is like you take because it's kind of the only person I know. Like you don't really know anyone other than versions of yourself. So I start with the version of myself that I know who doesn't yet understand the thing, right? And then I just try to view it with fresh eyes, particular visual or particular script. Like, is this motivating? Does this make sense? Which has its downsides because sometimes I find myself speaking to motivations that only myself would understand. I don't know, like I did this project like Contrarian, where what I really wanted was to understand what are they doing it for. Do we see what they're doing it for, right? And I way of thinking about it that really answers the question about that. Be very satisfied in being able to think about how dealing with the 3D visual, what are they doing towards it? And so I'm like, great, this is exactly what my past self would have wanted, right? And I make a thing on it. And I'm sure it's what some other people wanted. But in hindsight, I think most people who want to learn about quaternions are like robotics engineers or graphics programmers who want to understand what are used to describe 3D rotations. And like their use case was actually a little bit different than my past self. And in that way, like I wouldn't actually recommend that video to people who are getting it from that angle, but wanting to know, hey, I'm a robotics programmer. Like, how do these quaternion things work to describe position in 3D space? I would say other great resources for that. If you ever find yourself wanting to say, the thing run, then what's the active 4 dimensions? Then come back. But until then, it's a little different.
Yeah, it's interesting because you have incredible videos on your network, for example. And from my sort of perspective, because I looked at it is sort of my field, and I've also looked at the basic introduction of neural networks a million times from different perspectives. And it made me realize that there's a lot of ways to present it. So you did an incredible job of this sort of thing. But you could also do it differently and also incredible. Like to create a beautiful presentation of a basic concept requires sort of creativity, requires genius, and so on. But you can take it from a bunch of different perspectives, and that video, I know when you realize that. And just as you're saying, you kind of have a certain mindset, a certain view, but if you take a different view from a physics perspective, from a neuroscience perspective, from a neural networks, or from a robotics perspective, or let's see, from a pure learning theory, statistics perspective. So you can create totally different videos. And you've done that with a few actually concepts where you have taken different cuts, like at the Boiling equation. You've taken different views of that.
Yeah, I think I've made 3 videos on it, and I definitely will make at least one more. Right on. Never.
So you don't think it's the most beautiful equation in mathematics?
Like I said, it's one of the most hideous. And it involves a lot of the most hideous aspects of representation. How to the fact that we use pi instead of tau, the fact that we call imaginary numbers imaginary, and actually wonder if we use the I because of imaginary. I don't know if that's historically accurate, but at least a lot of people, they read the I and they think imaginary. Like all 3 of those facts, it's like, those are things that have added more confusion than they needed to, and we're wrapping them up in one equation. Boy, that's just very hideous, right? The idea is that it does tie together when you watch my implementation. It's okay, it's pretty, it's nice, but it's not the greatest thing in the universe. Which is maybe what I was thinking when I said, if once you understand something, it doesn't you. Like I feel like I understand the understand. And I feel like I understand it enough to really see the version that just woke up, that hasn't really gotten itself dressed in the morning, it's a little bit groggy, and there's bags under its eyes.
So you're past the dating stage.
We're no longer dating, right? I think dating is a function. I'm like, she's beautiful, and right, and like we have fun, and it's that high dopamine part. But like maybe at some point we'll settle into the more mundane nature of relationship where I like see her for who she truly is, and she'll still be beautiful in her own way, but it won't have the same romantic pizzazz, right?
Well, that's the nice thing about mathematics. I think as long as you don't live forever, there will always be enough mystery and fun with some of the equations.
Even if you do, the rate at which questions comes up is much faster than the rate at which answers come up. So
if you could live forever, would you?
I think so, yeah.
Do you think you don't think mortality is something that makes life easier?
Would you like the 4 times as meaningful if you died at 25?
So this goes to infinity. I think you and I, that's really interesting. So what I said is infinite, not 4 times longer. I said infinite. So the actual existence of the finiteness, the existence of the end, no matter the length, is the thing that may, sort of, for my comprehension of psychology, it's such a deeply human, it's such a fundamental part of the human condition. The fact that that we're mortal, that the fact that things end, it seems to be a crucial part of what gives them meaning.
I don't think, at least for me, like it's a very small percentage of my time that mortality is salient. That I'm like aware of the end of my life.
What do you mean by meaning? I'm trolling. Is it the ego? Is it the id? Or is it the super ego? Is that so you're
The reflective self, the Wernicke's area that puts all this stuff into words.
yeah, a small percentage of your mind that is actually aware of the true motivations that drive you.
But my point is that most of my life I'm not thinking about that. But I still feel very motivated to like make famous people, like interact with people, like experience love, like things like that. I'm very motivated. And it's strange that motivation comes while death is not anything. This might just be because I'm young enough that it's not salient.
Or it's in your subconscious, or that you
Sure.
construct an illusion that allows you to escape the fact that of your mortality by enjoying the moment of the existential approach to life.
Could be. Gun to my head, I don't think that's it.
Yeah, another sort of way to say gun to the head is just the deep psychological introspection of what drives us. In some ways, to me, when I look at math or I look at science, it's a kind of an escape from reality, in a sense that it's so beautiful. It's such a beautiful journey of discovery that it allows you to actually, it allows you to achieve a kind of immortality of explore ideas and sort of connect yourself to the thing that is seemingly infinite, like the universe, right? And it allows you to escape the limited nature of our little body or our existence.
What else would give this podcast meaning?
That's right.
If not the fact that it will end.
This place closes in 40 minutes. And
So much more meaningful for it. How much more I love this room because we'll be kicked out.
so I understand just because you're trolling me doesn't mean I'm wrong. So, but I take your point. I take your point.
Boy, that would be a good Twitter bio. Just because you're trolling me doesn't mean I'm wrong.
Yeah, and sort of difference in backgrounds. I'm a bit Russian, so we're a bit melancholic, and it seemed to maybe assign a little too much value to suffering, mortality, and things like that. Makes for a better novel, I think.
Oh yeah, you need some sort of existential threat to drive a plot.
So when do you know when the video is done?
That's pretty easy actually because I mean I'll write the script. I want there to be some kind of aha moment in there, and then hopefully the script can revolve around some kind of aha moment, and then from there, you put in visuals to each sentence that exists, and then you narrate it, you edit it all together. So given that there's a script, the end becomes quite clear. And you're as I animate it, I often change certainly the specific words, but sometimes the structure itself. But it's a very deterministic process at that point. It makes it much easier to predict when something will be done. How do you know when the script is done? It's like for problem-solving videos, that's quite simple. It's once you feel like someone who didn't understand the solution now could. For things like neural networks, that's a lot harder because, like you said, there's so many angles at which you can attack it. And there, it's just at some point you feel like this asks a meaningful question and it answers that question. Right?
What is the best way to learn math for people who might be at the beginning of that journey? I think that's a question that a lot of folks kind of ask and think about. And it doesn't, even for folks who are not really at the beginning of their journey, like they might be actually deep in their career, some type of technicality, taking calculus and so on, but still sort of explore math. What would be your advice for dedication at all?
Your temptation will be to try to force yourself to do more problems than you naturally would. That's a big one. Like the focus time that you're spending should be on solving specific problems and seek entities that have well curated lists of problems.
You're going to like a textbook almost, and the problems in the back of the textbook,
Yeah.
and the back of the chapter.
So if you can, look through those questions at the end of the chapter before you read the chapter. A lot of them won't make sense. Some of them might, but those are the best ones to think about. A lot of them won't, but just take a quick look and then read a little bit of the chapter and then maybe take a look again and things like that. And don't consider yourself done with it until So you actually work to do a couple exercises. But, and just is so hypocritical, right? Because I put out videos that pretty much never have associated exercises. I just view myself as a different part of the ecosystem, which means I'm kind of admitting that you're not really learning, or at least this is only a partial part of the learning process if you're watching these videos. I think if someone's at the very beginning, like I do think Khan Academy does a good job. They have a pretty large set of
Just the very basics. So just picking up, getting comfortable with the very basics. When you're out in calculus from Khan Academy.
and programming is actually, I think, a great, like, learn to program and like let the way that math is motivated from that angle push you through. I know a lot of people who didn't like math got into programming in some way, and that's what turned them on to math. Maybe I'm biased because I live in the Bay Area, so I'm more likely to run into someone who has that phenotype. But I am willing to speculate that that is a more generalizable path.
So you yourself kind of creating figures are using programming to illuminate a concept, but for yourself as well. So would you recommend somebody try to make a sort of almost like try to make videos? Like you do as a way to learn?
So one thing I've heard before, I don't know if this is based on any actual study. This might be like a total fictional anecdote of numbers, but it rings in the mind as being true. You remember about 10% of what you read. You remember about 20% of what you listen to, and about 70% of what you actively interact with in some way, and then about 90% of what you teach. The thing I heard again, those numbers might be meaningless, but they seem true, don't they? Right? I'm going to say I learned 9 times better at imagining than reading. That might even be a low level. Right? So doing something to teach or to like actively try to explain things is huge for consolidating.
Outside of family and friends, is there a moment you can remember that you'd like to relive because it made you really happy or it was transformative in some fundamental way
The moment that was transformative.
or made you truly happy?
Yeah, I think there's times, like music used to be a much bigger part of my life than it is now, like when I was a teenager. And I can think of some times in like playing music.
There
my brother
Yeah. And it woke me. And then had your phone on for like 4 hours. Did you do it again? Yeah. I could hear what you were saying. Yeah. Everything. Yeah. Why are you so mean to me? Are you ready to play? You're not. You're not. What event? At what event were you? Oh, okay. Well, it sounds like fun. I can hear some of it. That's cool. Are you ready to play? Yeah. Yeah, it was. But I could hear like you were like stand by, like some other thing, and then I figured I was yelling at you. I'm like, dude, are you ready to play? Dude, because you woke me up, and I was like, dude, are you ready to play? And then I figured you talked about me or something, and then I just disconnected you. Are you ready to play? Yeah. Okay. What game would you like to lose at first? Here you go. All right, well, go charge. All right, well, then come back in 15 minutes. All right, I'll see you in 20 minutes. so cute. Today. Today. Spaghetti.
this slightly violates the family interest. There's music in it. We like played a gig in a ski resort, such that you like take a gondola to the top and like do the thing. Then on the gondola, we decided to just jam a little bit, and it was just like I don't know, the gondola sort of came over enough, and we saw the city lights, and then just like jamming, like playing some music. I wouldn't describe that as transformative. I don't know why, but that popped into my mind as a moment of, in a way that wasn't associated with people I love, but more with like a thing I was doing, something that was just happened. It was just like a great moment. I don't think I can give you anything deeper than that, though.
Well, as a musician myself, I'd love to see, as you mentioned before, music enter back into your work and back into your creative work. I'd love to see that. I'm certainly allowing it to enter back into mine, and it's a beautiful thing for a mathematician, for scientists to allow music to enter their work. I think only good things can happen.
And I'll try to promise you a music video by 2020.
But by 2020,
End of 2020.
okay, all right,
Okay, give myself a longer window.
all right. Maybe we can like collaborate on a band type of joint. What instruments do you play?
Main instrument I play is violin, but I also love to dabble around on the guitar and piano.
Guitar and piano. So in mathematicians that Paul Lockhart writes, the first thing to understand is that mathematics is an art. The difference between math and other arts, such as music, painting, is that our culture does not recognize it as such. So I think I speak for millions of people, myself included, in saying thank you for giving to us the art of mathematics. So thank you for having me here, and thanks for talking to me.
Thanks for saying that. Thanks for having me.
Thanks for listening to this conversation with Grant Sanderson, and thank you to our presenting sponsor, Cash App. Download it, use code LEXPODCAST, you'll get $10. For the first STEM education nonprofit that inspires hundreds of thousands of young minds to become future leaders and innovators. Enjoy this podcast, subscribe on YouTube, use 5 stars on Apple Podcasts, support on Patreon, connect with me on Twitter. Now, let me leave you with some words of wisdom from one of Grant's my favorite people, Richard Feynman. Nobody ever figures out what this life is all about. It doesn't matter. Explore the world. Nearly everything is really interesting if you go into it deeply. Thank you for listening. Hope to see The following is a conversation with Daniel Kahneman, winner of the Nobel Prize in Economics for his integration of economic science and psychology of human behavior, judgment, and decision making. He's the author of the popular book Thinking Fast and Slow that summarizes in an accessible way his research of several decades, often in collaboration with Amos Tversky, on cognitive biases, prospect theory, and happiness. The central thesis of this work is the dichotomy between two modes of thought. What he calls System 1 is fast, instinctive, and emotional. System 2 is slower, more deliberative, and more logical. The book delineates cognitive biases associated with each of these two types of thinking. His study of the human mind and its peculiar and fascinating limitations are both instructive and inspiring for those of us seeking to engineer intelligent systems. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, give it 5 stars on Apple Podcasts, follow on Spotify, support it on Patreon, simply connect with me on Twitter. Lex Friedman, spelled Fridman. I recently started doing ads at the end of the introduction. I'll do 1 or 2 minutes after introducing the episode, and never any ads in the middle that can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. This show is presented by Cash App. number one finance app in the App Store. I personally use Cash App to send money to friends. You can also use it to buy, sell, and deposit Bitcoin in just a second. Cash App also has a new investing feature. You can buy fractions of the stock to save $1 worth, no matter what the stock price is. Brokerage services are provided by Cash App Investing, a subsidiary of Square and member SIPC. I'm excited to be working with Cash App to support one of my favorite organizations called FIRST, best known for their FIRST robotics and legal competition. They educate and inspire hundreds of thousands of students in 110 countries and have a perfect rating at Charity Navigator, which means that donated money is used to maximum effectiveness. When you get Cash App in the App Store, play, use code LEX Podcast, you'll get $10. Cash App will also donate $10 to FIRST, which again is an organization that I've personally seen inspire girls and boys to dream of engineering a better world. And now, here's my conversation with Danielle Conway. You tell a story of an SS soldier early in the war in Nazi-occupied France and Paris, where you grew up. He picked you up and hugged you and showed you a picture of a boy, maybe not realizing that you were Jewish. Maybe, certainly. So I told you I'm in the Soviet Union that was significantly impacted by the war as well, and I'm Jewish as well. What do you think World War II taught us about human psychology broadly?
Well, I think the only big surprise is the extermination policy, genocide by the German people. That's when you look back on it, and I think that's a major surprise.
Surprised because
It's a surprise that they could do it. It's a surprise that enough people willingly participate in this. This is a surprise. Now it's no longer a surprise, but it's strange. Many people's views, I think, about human beings. Certainly for me, the Eichmann trial, and that teaches you something because it's very clear that if it could happen in Germany, it could happen anywhere. It's not that the Germans were special. This could happen anywhere.
what do you think that is? Do you think we're all capable of evil? We're all capable of cruelty?
I don't think in those terms. I think that what is certainly possible is you can dehumanize people so that you treat them not as people anymore, but as animals. And in the same way that you can slaughter animals without feeling much of anything, it can the same. And when you feel that, I think the combination of dehumanizing the other side and having uncontrolled power over other people, I think that doesn't bring out the most generous aspect of human nature. So that Nazi soldier, he's a good man. I mean, he's very capable of killing a lot of people, and I'm sure he did.
But what did the Jewish people mean to Nazis? So what the dismissal of Jewish as
Well,
worthy of
again, this is surprising that it was so extreme, but it's not one thing in human nature. I don't want to call it evil, but the distinction between the in-group and the out-group, that is very basic. So that's the loyalty and affection to an in-group and the willingness to dehumanize the out-group. That is in human nature, and that's why I think probably didn't need the Holocaust to teach us that, but the Holocaust is a very sharp lesson. What can happen to people, what people can do.
to the effect of the in group and the out group.
That it's clear that those were, you could shoot them, they were not human. There was no empathy. So very, very little empathy. So occasionally, there might have been, and much, whether it could happen or in every culture, or whether the Germans were just particularly efficient and disciplined, so they could get away with it. That is a question. It's an interesting question.
Are these artifacts of history or human nature?
I think that's really human nature. You put some people in a position of power relative to other people, and they become less human. They become different.
But in general, in war, outside of concentration camps, it seems that war brings out darker sides of human nature, but also the beautiful things about human nature.
Well, but it makes out the loyalty among soldiers, and it brings out the bonding, male bonding. I think it is a very good thing that happens, and so and there is a certain thrill to friendship, and there is certainly a certain thrill to friendship under risk, and to share this, and so people are very profound emotions up to the point where it gets so traumatic that
So let's talk about psychology a little bit. You're both thinking fast and slow. How do you describe two modes of thought? Is the one, the fast instinctive, emotional one, is just the two, the slower, deliberate, logical one. At the risk of asking Darwin to discuss the theory of evolution, can you describe distinguished characteristics for people who have not read your book, two systems?
well, I mean, the word system is a bit misleading, but it's at the same time it's misleading. It's also very useful. But what I call system one, it's easier to think of it as a family of activities. And primarily, the way I describe it, there are different ways for ideas to come to mind. Some ideas come to mind automatically. The standard example is 2 plus 2, and then something happens to you. And in other cases, you've got to do something, you've got to work in order to produce the idea. My example, I always give the same pair of numbers is 27 times 14.
You have to perform some algorithm in your head.
And it takes time. It's a very different. Nothing comes to mind except something comes to mind, which is the algorithm. I mean, that you've got to perform. And then it's work, and it engages short-term memory, it engages executive function, and it makes you incapable of doing other things at the same time. So the main characteristic of system 2 is that there is mental effort involved, and there's capacity for mental effort. Whereas system 1 is as opposed to that's the major distinction.
So you talk about it's really good to talk about two systems, but you also mentioned just now in general that there's no distinct brain from your biological and psychology perspective. But why does it seem to, from the experiments you've conducted, there does seem to be kind of two modes of thinking. So at some point, these kinds of systems came into a brain architecture. Maybe mammals share it, but or do you not think of it in all those terms that it's all mush and these two things converge?
You know, evolutionary theorizing about this is cheap and easier. So it's the way I think about it is that it's very clear that animals have a perceptual system and that includes an ability to understand the world, at least to the extent that they can predict. They can't explain anything, but they can anticipate what's going to happen, and that's the key form of understanding the world. And my good idea is that what I call system 2, but System 2 grew out of this. And there is language and there is the capacity of manipulating ideas and the capacity of imagining futures and of imagining counterfactual things that haven't happened and to do conditional thinking. And there are really a lot of abilities that without language and without the very large brain that we have compared to others would be impossible. Now, System 1 is more like what the animals are, but System 1 also can talk. I mean, it has language. It understands language. It speaks for us. I mean, I'm not choosing every word as a deliberate process. The words that have some idea, and then the words come out, and that's automatic and effortless.
And many experiments we've done is to show that, listen, System 1 exists and it does speak for us, and we should be careful about the voice it provides.
Well, I mean, we have to trust it because it's the speed at which it acts. System 2, if we depend on System 2 for survival, we wouldn't survive because it's very slow.
Crossing the street.
Crossing many things depend on their being automatic. And one very important aspect of System 1 is that it's not instinctive. You use the word instinctive. It contains skills that clearly have been learned. So that skilled behavior, like driving a car or speaking, skilled behavior has to be learned. So it don't come equipped with driving. You have to learn how to drive. And you have to go through a period where driving is not automatic before it becomes automatic. So,
yeah, you construct, I mean, this is where you talk about heuristic and biases. You make it automatic, you create a pattern, and then System 1 essentially reaches a new experience against the previously seen pattern. And when that match is not a good one, that's when all the mess happens, but it's most of it works. So it's pretty
most of the time, the anticipation of what's going to happen is correct. And most of the time, the plan about what we have to do is correct. So most of the time, everything works just fine. What's interesting is that in some sense, System 1 is much better at what it does. And System 2 is at what it does. That is, there is this quality of effortlessly solving enormously complicated problems, which clearly exists. And there's a chess player, a very good chess player. All the moves that come to their mind are strong moves. So all the selection of strong moves happens unconsciously and automatically and very, very fast. And all that is in System 1. So the System 2 verifies.
So along this line of thinking, really what we are machines that construct pretty effective System 1. You could think of it that way. So we're not talking about humans, but if we think about building intelligence systems, robots, do you think all the features and bugs that you have highlighted in human beings are useful for constructing AI systems? So both systems are useful for perhaps instilling in robots?
What is happening is that actually what is happening in deep learning is more like the System 1 product, like the System 2 product. Deep learning matches patterns and anticipate what's going to happen, so it's like predictive. What deep learning doesn't have, many people think that this is critical. It doesn't have the ability to reason, so there is no System 2 there. But I think very importantly, it doesn't have any causality or any way to represent meaning and to represent real interaction. So until that is solved, what can be accomplished is marvelous and very exciting, but limited.
Current advances in machine learning is essentially system one advances. So how far can we get with just system one? You think
Well,
with deep learning and artificial intelligence systems?
It's very clear that DeepMind has already gone way beyond what people thought was possible. I think the thing that impressed me most about the developments in AI is the speed. It's that things, at least in the context of deep learning, and maybe this is about to slow down, but things moved a lot faster than anticipated. The transition from solving chess to solving Go, that's the word of thing, how quickly it went. The move from AlphaGo to AlphaZero is sort of bewildering, the speed at which they accomplished that. Now, clearly, there are many problems that you can solve that way, but there are some problems for which you need something else.
Something like reasoning.
Well, reasoning is not also. So, there's one of the real mysteries. So, ecologist there, Gary Marcus, who is also a critic of AI. What he points out, and I think he has, is that humans learn quickly. Uh, Children don't need a million examples; they need 2 or 3 examples. So clearly, there is a fundamental difference. And uh, what enables a machine to learn quickly, what you have to build into the machine, because it's clear that you have to build some expectations or something in the machine to make it ready to learn quickly. That at the moment seems to be unsolved. I'm pretty sure that DeepMind is working on it, but
Yeah,
if they have solved it, I haven't yet.
they're trying to actually, them and OpenAI are trying to start to get to use neural networks for reason. So assemble knowledge. Of course, temporal causality is out of reach to most everybody. You mentioned the benefits of System 1 is essentially that it's fast, allows us to function in the world.
That's skill.
It's skill.
And it has a model of the world. In a sense, there was the early phase of AI attempted to model reasoning, and they were moderately successful, but reasoning by itself doesn't get you much. Deep learning has been much more successful in terms of what they can do. Now, it's an interesting question whether it's approaching its limits. What do you think?
I think absolutely. So I just talked to Keon LeCun, mentioned. So he thinks that the limits, we're not going to hit the limits with neural networks, that ultimately this kind of systematic pattern matching will start to look like System 2 without significant transformation of the architecture. So I'm more with the majority of the people who think that yes, neural network will hit the limits in their capability.
On the one hand, I have heard him tell them it's obvious essentially that what they have accomplished is not a big deal, that they have just touched. But basically, they can't do unsupervised learning in an effective way. So you're telling me that he thinks that within the current architecture, you can do causality and reasoning?
So he's very much a pragmatist in a sense of saying that we're very far away. That there's still, I think there's this idea that he says is you can only see 1 or 2 mountain peaks ahead, and that might be either a few more after or thousands more after. Yeah, so that kind of idea. Right, but nevertheless, it doesn't see the final answer not fundamentally looking like one that we currently have. So neural networks being a huge part of that.
Yeah, I mean, because pattern matching is so much of what's going on.
And we can think of neural networks as processing information sequentially.
Well, I mean, there is an important aspect to, for example, we give systems that translate, and they do a very good job, but they really don't know what they're talking about. And for
There
them,
he
that
is.
is really quite
I live in
for
Tampa.
that.
Do you remember that time I asked you how you doing? And you were like quiet. All right, are you ready? Is your phone charged? That's what I'm talking about. All right, now here's my first question. How many games in a row do you think you're going to win? Just going to straight up 5? Are we going to tie any of the games? We're just going to straight up win 5 straight games. That's what I like. That's the kind of confidence I like. I like to destroy it. Let's see you, dude. I see you, baby. Oh, what a what a shot, dude. Dude, that was good. Dude, that was one of the shots I've ever seen. You did that to Olin too. Who are you? Dude, you know you just did one of the most difficult hardest bullets to do in two shots? Hit that fucking tree. Oh, I am fucked, dude. Make it. Oh, Zoot came to play today, folks. Zoot came to play today. I'm down 2-0. That's the biggest deficit you can be down without losing. Or time for job. Zoot, you played a perfect game this far. You played perfectly. All right. Yeah. You can still make it, though. Make it. All right. I need this shot to stay in contention. Oh, I fucked myself, Zoot. Zoot won. Zoot. Yeah, but I want to win. A straight up W. Hit that ball, baby. That's what I'm talking about. Were there any sexy bitches there? That's okay. stay in contention. Oh no! Zoo won. Garbage, Zoo. Absolute positive garbage. Zoo, you're a champion. How does that make you feel? Zoo wasn't there for that, but he fell in love with some chick. Make it. Dude, you almost gave up. You almost fucking went, dude. Zoo, can you believe that? Zoo, Zoo plays the best game of his entire career. All right, I don't know if you know. Zoo, phenomenal job. I mean, you walked in, slapped me in the face, and walked out with the title. That's what I like, Zoo. Good job. If only you could always play like that. You played like a perfect game. Dude, you played very, very well. That's what I'm talking about. That's a great shot. Let's see what you got. Good dog. They all believe you. That's 100% right. You answered the question correctly. 1,000. Dude, I can't believe how well you played that last game. That was like the best game I've ever seen you play. As for this, YouTube, get it, Zoo. What? I'm up 2-0. Oh, perfect hole with this shot. One of the greatest shots in history. And I kind of hit my ball. Oh, Zoo. That's one of the greatest shots in history. Trying to figure out the corner. Oh, Zoo, I'm done. You did the what? Yeah, dog. That's why I keep playing, man. I make everybody try. It's going to be well, it's already happened. I mean, first publicly acknowledged billionaire. It's going to be a foot race between one Rabbi Rothschild and Elon Musk. All right. Dude, yeah. You both just did me this. This is gonna go in the hole. Dude, get there, get there, get there, get there, get there, get there. Boom. Dude, are you proud of that shot?
Yeah.
You should be.
You're right.
Oh, this is gonna help me. Go baby, go baby, go baby, go baby. Hit my ball. Are you serious? Look at the shot, Zoo. Look at the shot, Zoo. Dude, we can help Connor. No, don't. Just put it in. Put it in the hole. Oh, you water bumped me, dude. You fucked me. Connor straight up fucks me. Hilarious. That was a great way to fuck me up. And then I'm gonna put his ball in the hole. Are you serious? That was a great run, though. Yo, Cam. Did you guys elect the koala? Do you like him? Don't what? Dude, you need some shot. You just put Connor in black shit. I put you in black shit. Yeah, but that gives you guys an open lane. Open lane at the hole. Open lane at the hole. Dude, you know what to do. There's an open lane at the hole. Just don't fuck it up. You fucked it up. One of the greatest shots we've ever seen. Actually, that's a really good shot. All right, it's gonna come out to whoever makes it in first. There you go. That's what I'm talking about. No way Connor makes the shot. Dude, get second. There. I've never seen a ball on that little strip just stay. Dude's going for the win. And he lost. So, oh, that was perfect. That was perfect. Dude going for the win. Dude makes his ties for second. Do you like this whole? You're the only person I've ever taken into on this book. No, you haven't. Don't. Bachelor. In one shot. No, don't lie. Don't lie. You're lying. No, even if you had 10 people, they couldn't hit your ball all the way up. I don't know if I believe it. That could happen. But you'd have to help the person. That's a terrible shot. Get out of my way. Dude, get out of my way. I actually. Oh, dude. Dude. Dude, what are you doing to me? One of the best shots we've ever seen. You know it. You know it. We all know it. Dude, do you know the market cap of Fair Color Homicide Canada? Do you know the market cap of Fair Color Homicide Canada? Alright, that's better than it was. Big shot for Zoot. Too high. Perfect. I'm still looking for his first win. Shows it up. Dude. What's it at? Lost it from that. Oh god. Did you know that you have an invitation? Dude. Dude, what? From 0 to 10, how would you rate that guy? I just asked you a question. Observe it happen.
That's a one part.
I agree. I don't know if I'd say it's a command, but it's definitely an event. Look at the efficiency. Oh, make it a run. Judy, you don't basket. That's what I'm talking about. So that's what I'm talking about, Judy. That's too hard. Oh, what a fluke shot. What a fluke shot. Make it. Dude, what's up with all these goals where we can put it through it? Yeah. Dude, you're in the middle of
Exercise. Section. Extras. It's just it's actually 12 girls and 16 girls.
Are you going to have a good shot? Yeah, that's all right. Dude, that was one of the worst shots I've ever seen. I've seen some bad shots. That one was terrible.
So, Andrew next. Andrew next grade takes the program contact members picture.
Dude, rank that shot.
So,
7, okay. Rank that shot. Dude, you know that my ball's in the hole. Dude, rank that shot.
shit.
7, okay, 9, shot that. Dude, what the fuck? You guys are all both to my right.
So,
9, shot that. Because your chat is distracted. Just help them.
the rest are set.
Way too hard.
So I don't five, seven. That's all.
Dude, look at this shot. Thank you.
Or
It's hard to not have like a shot just right in the spot. Unless you really mess up.
this one's don't develop.
So you ready for one of the best shots I've ever seen? Precision, man. What is doing, Connor? Don't need it this far. Just nice and slow. Don't do that up high. Dude, if you proud of that shot, I wonder if I could fuck more for sure. I might try it. Just on YouTube. Look at this one, dude. That wasn't smart. I mean, it doesn't fuck you. You could actually do it from here. Hit my ball. Dude, you just get a shot there. Champion. Good play, boy. Not a lot of people. They have like 2 or 1. Very good play for that on the ball. It should be though. I don't understand why they can't just make it be 100. I agree. I'm not proud of that shot. You want to get that thing. I agree. Tired up. I know I saw that. Oh, you playing? Are you done? proud of that shot? Yeah. Can you? Right. And if you do, you can do a lot of damage. He's going to be out in 3, 2, 1. Are you proud of that shot? Are you serious? Do you think either of us are going to spot this hole? You got a good shot. That was a good shot. Roll, baby. For sure. I'm going to put this ball in the perfect position to get it to the spot. That's the position. Yours is different. Just boom, boom. All right, here we go. I might hit your ball now. Come on, baby. Oh, man. That was close. I'm still in your way. That's going to hit my ball. Thank you. Why would you do that? Perfect. Perfect win. I just hit you there. You can't really look at it. Look at this shot. Tell me about it. Make it. Are you proud of that shot? You're in my way. Watch your water back, baby. Stop, stop, stop. Dude, let me see it. Let me see the greatest stuff. That was a great shot. Dude, that was amazing. Dude, you know that was a good move on my part. And if I make this, it's a genius. And I make it. Dude, you know that was great play. I don't think either of us have ever made it on this hole. You were some selected to that thing, just like you last year. Plato's not pro speak. Oh, look at this shot. What did you write?
Just the effort.
Okay. Dude, I'm still on track of that first page of one of the greatest things. Dude, it's the only you've ever scored. I don't understand why you. I mean, I get it. This is a problem. Is it because I talked with you at the beginning?
It's the truth. It's good you did that.
I know.
So, the good
You have to get the ball.
it's not this
You know,
so you have no chances of that big third play of the out on the side of the place. What happens? This is a
it's just what
it goes with
I took it back. What are Adi titles? Zoom. I want you to meet me at this game. I really do. Because I never played again. Dude, did you know the general invitation? Do you know the general invitation? Oh, dude. If this is how you start a bridge, big time. It's a French origin. Are you gonna make it? Are you gonna put it back? You regret. I mean, we do it. This is like my best start. I played. Okay. You want to know what word is played most? I'll make you guess it. What word do you think is played most in Scrabble today? No. No, that's in the word. No, there's no I in hello. Jizz? No, no, it's not this. Not him. No, it just has an I. Bi? No, it's not that. It's not three letters. It is two letters. It's two letters. Oh, it's not. How do you spell side? No. It is not AI. It is not five. It is not AI. It is not MI. It is not O. It is not I. Yep. It means like spelled out CHI. It's like a loan word from Chinese. It's like your spirit or something like that.
Ooh, that's interesting. Are you sure about that? Just by the Facebook. Thanks, Big Dog. Haha. Let's see it, Big Dog. What is that? I don't know. You never won, so I don't know what that's like. Yes? We played one, two, three.
good one, dude. See if I can go to the next one. Good shit. I'm doing really well. Okay. You again. Look how much of a good happened. I know, but that means that's an action. Yes, no, that has a word. We can pick up it's like I mean, it's like an exclamation. Yeah, but then you can just make them up. You can just be like, oh, that means, whatever society, whatever. People do it. Oh, I've never heard of that. You'd have to make up your own dictionary. That's good. That's just, good. You know who really likes table sack? Apple. Oh, I'm fucked, dude. I'm fucked. Dude, you fucked me. Holy shit. Holy shit. Holy. You did like no damage to me. Whereas badly. No, wait. 42. You're at 25 right now. Fuck. Did you get to have the best comeback of the year? No way. That cat is just about to blow you up in every game. Okay. You're done. We're gonna plan to the way. Go, okay? I didn't even fuck. You just fucked me. Just whenever you say that, you you you're undefeated. I haven't gotten this one yet. Dude, you're winning by 40. You're winning by 40. You're okay. Big mistake. The Falcons come back charging. Oh no. Okay. Should feel good. Come on, baby. You got an 8 coming home. You got me. You got me. You got me, dude. Oh, dude, just barely, too. I almost won. All right. Table soccer. Dude, do you know what the dragon attack is? Do you know why they call it the dragon attack?
Right.
I guess. Not even close. Are you gonna pass it? Oh, I don't know what that was. Look at this shot. You ready for the shot on goal? Are you gonna pass it and try to score it? Oh, easy score. What's going on here? Yeah, it is. Oh, guys. Oh, get this ball out of here. Oh, get this ball out of here. Oh, that was beautiful. Good job. Good job, man. You done. Your brain care is over. Defense is amazing. That's it. You ready for this, dude? Dragon attack. Do you think dragons were ever real?
Yes.
Are you serious? What are you gonna do? What are you gonna do, dude? Are you proud of that shot? Oh, that was almost the best goal of the time. Are you proud of your defense? All right, dragon attack time. Look at this shot, dude. Oh, my guy's in the way. Dude, do you know what the dragon attack is? Are you proud of that shot? You could score. Miss. And you did. All right, I need a good pass. What a goal! I was not expecting that. I've scored every goal in this game, including the one against myself. Oh, almost. Pass it. He's going to take a shot on goal. He's going to pass it. He chooses to pass it. Oh, what are you doing? Get this ball out of here. You going to pass it? He's going to take a shot on goal. Get this out of here. Pass it. Oh, no. If you can get that pass to the guy, it's a timeout. Passing is so good in this game. Oh, look at this, dude. Look at this. I'm going to try to pass it again. Get it. Shot on goal, dude. Shot on goal, dude. Oh, I missed twice. Let's see it. That was the first goal. I scored 5 goals. Yeah. Good shot. Not terrible. Shot on goal. Get it. Oh, and I did. I scored every single goal in that game. I got really fortunate, guys. All right, guard time, son. You ready for it? Yes, I did. I scored the one that you scored. It came off of my foot, or whatever you want to call it. Yeah, I said that. Well, you know what wasn't terrible? In the game. Oh, look at that. Oh, dude, I'm kind of garbage. Straight up garbage. Yeah, totally different. We're up by 14. Oh, you're right. Round 3, 22. Get it. Get that 15. Get that 10. Get it, sir. Get that 8 and get that 12. Get that 8. Check out. Get oh, way too bad. I got shit. Check out. We're not going to shit. You are not. Yep. You bullseye on the 5. Busted. Now you're fucked. The right. That's right. I'm going to check out Sun. You need a bullseye and a 6. Get that 18. I'm going to just missed. Gotcha. Thank you, Doug. All right. I do too. I still put the guns. I want to see you win a triple 20 or double 20. That's the ultimate gift. That works too. Check out Sun. Double 20 and a 1. That's 1. Get it. You know you can get that. I know you can get it. I know you can get it. Oh, you triple 7. Oh, you almost got it. That's 2 games in a row. 2 games in a row. You spoke first. That's a miss. That's a 20. That's a 20. I'll take that. I love when I get 60 right off the bat. That's a 20. Bust. I just need 1 point. You need a triple 20 and a 1. That's a 20. That's a double 20. Hit the 20 and check out. What a shot. And, yeah, I like going second. What else do you want me to do? Go for a 7? Yeah, sure. You could have the biggest comeback in your career right now. Being down 100. Double 20. Yeah. Go for whatever you want to go for, baby. Go triple 19. Not as badly as I am. Oh, get it. Get this check out. It's 3 easy. Not that good. No, no. That's deep. Utah. 20. 20. Listen. Triple. Triple 20. 20. Get that 7. 7. Get that 13. Oh, man. I saw this guy who had like the most incredible dart shot of all time. He hit triple 20, triple 20, and then threw it again, and it got between darts and started hanging down on the bullseye and counted and won. You kind of have to see it to know what reference was, but it was like the most incredible shot. Oh, Doug, oh, what was that? Get another one. No, get it. 60 points. 20, 20, double 20. Too high. 20, 7. 20. Oh, I can't believe it. Get that 14. Get that 5. Triple 5, 5. Check out. Gotcha. All right, that's game. We go ahead. The championship of all championships. Squid Games, dude. Dude, I stayed up so badly. Triple 20. You were good. Wow, that was so bad. Get that 20. Get that 20. Get that, get that 19. That's it. Get it. Check out. All right, good job, sir. Sweet James picked out. That's amazing.
You would need an AI that has substation, an AI that is in touch with uh,
Self-awareness, and maybe even something resembles consciousness kind of ideas.
the awareness of awareness of what's going on, so that the words have meaning or can get out of it perception or some action.
Yeah, so that's a big thing. Yeah, and that's what he refers to grounding to the physical space. So
So we're talking about the same.
yeah, so how do you
The grounding, without grounding, then you get a machine that doesn't know what it's talking about. Because it is talking about the world, ultimately.
the open question is what he means to ground. I mean, we're very human centric in our thinking. But what does it mean for a machine to understand what it means to be in this world? Does it need to have a body? Does it need to have a finiteness like we humans have? All of these elements. It's very. It's not,
I'm not sure about having a body, but having a perceptual system, having a body would be very helpful too. I mean, if you think about human mimicking human, but having a perception, that seems to be essential, so that you can build, you can accumulate knowledge about the world. So you can imagine a human completely paralyzed, that there is a lot of the human brain could learn, with a paralyzed body. So if we got a machine that could do that, that would be a big deal.
and then the flip side of that, something you see in children, and something in the machine learning world is called active learning. Maybe that's also is being able to play with the world. How important for developing system one or system two do you think it is to play with the world, to interact with
Certainly
it?
a lot of what you learn, as you learn to anticipate in the outcomes of your actions, and you can see that from babies learn, with their hands, how they learn to connect, the movement. So they have something that clearly is something that happens in the brain, and and the ability of the brain to learn new patterns. It's the kind of thing that you get with artificial limbs, that you connect it, and then people learn to operate the artificial limb, from it necessarily quickly, at least from what I hear. So we have a system that is ready to learn words from action.
At the risk of going into way too mysterious of land, what do you think it takes to build a system like that? Obviously, we're very far from understanding how the brain works, but how difficult is it to build this mind?
I think that Yanda could answer that we don't know how many mountains there are. I think that's a very good answer. I think that, if you look at what Ray Kurzweil is saying, that strikes me as off the wall, Bible star. But I think people are much more realistic than that. We're actually, Demis Hassabis is, and Yana is, and so the people are actually doing the work fairly realistic, I think.
To maybe phrase it another way, from a perspective not of building it, but from understanding it, how complicated are human beings in the following sense? I work with autonomous vehicles and pedestrians, so we're trying to model pedestrians. How difficult is it to model a human being, their perception of the world, the two systems they operate under, sufficiently to be able to predict whether the pedestrian is going to cross the road or not?
I'm fairly optimistic about that, actually, because what we're talking about is a huge amount of information that every vehicle has, and that feeds into one system, into one gigantic system. And so anything that any vehicle learns becomes part of what the whole system knows. And with the system multiplied like that, there's a lot that you can do. So human beings are very complicated, but the system is going to make mistakes, but human makes mistakes. I think that they'll be able to. I think they are able to anticipate pedestrians, otherwise a lot would happen. They're able to, they're able to get into a roundabout and into traffic, so they must know both to expect or to anticipate how people will react
currently, the pedestrians are treated as things that cannot be hit, and that not treated as agents with whom you interact in a game theoretic way. So
I mean,
it's a totally open problem, and every time somebody tries to solve it, it seems to be harder than you think. And nobody's really tried to seriously solve the problem of that dance, because I'm not sure if you've thought about the problem of pedestrians, but you're really in your life in the hands of the driver.
You know, there is a dance, there's part of the dance that would be quite complicated. But for example, when I cross the street and there's people approaching, I look the driver in the eye, and I think many people do that. And you know, that's a signal that I'm sending, and I would be sending that machine to an autonomous vehicle that is a better understanding because it means I'm crossing.
So, and there's another thing you do that actually, so I'll tell you what you do. So I watched hundreds of hours of video on this. Is when you step in the street, you do that before you step in the street. And when you step in the street, you actually look away.
Look away.
Yeah. Now, what is that? What that's saying is, I mean, you're trusting that the car, who hasn't slowed down yet, will slow down.
And you're telling him,
Yeah.
I'm committed. I mean, this is like in a game of chicken. So I'm committed, and if I'm committed, I'm looking away. So you just have to stop.
So the question is whether a machine that observes that needs to understand mortality.
I'm not sure that it's got to understand so much. It's got to anticipate. So, and here, you know, you're surprising because here I would think that maybe you can anticipate understanding because I think this is clearly what's happening in playing Go or in playing chess. There's a lot of anticipation and there is zero understanding. So I thought that you didn't need the model of the human and the model of the human mind to avoid hitting pedestrians. But you are suggesting that I
You do, yeah.
do.
And
Then it's a lot harder.
so this
at
is,
all.
and I have a follow-up question to see where your intuition lies. Is it seems that almost every robot-human collaboration system is a lot harder than people realize. So, do you think it's possible for robots and humans to collaborate successfully? We talked a little bit about semi-autonomous vehicles, like the Tesla and autopilot, but just in tasks in general. If you think we talked about current neural networks being kind of system one, do you think those same systems can borrow humans for system two type tasks and collaborate successfully?
Well, I think that in any system where humans and a machine interact, the human will be superfluous within a fairly short time. That is, if the machine is advanced enough so that it can really help the human, then it may not need the human for a long time. Now, it would be very interesting if there are problems that for some reason the machine cannot solve, but that people could solve, then you would have to build into the machine an ability to recognize that it is that kind of problematic situation and to call the human. That cannot be easy without understanding, but it must be very difficult to program the recognition that you are in a problematic situation without understanding the problem. But
That's very true. In order to understand the full scope of situations that are problematic, you almost need to be smart enough to solve all those problems.
it's not clear to me how much the machine may need a human. I think the example of chess is very instructive. I mean, there was a time at which Kasparov was saying that human machine combinations were beat everybody. Even Stockfish doesn't need people, and AlphaZero certainly doesn't need people.
The question is, just like you said, how many problems are like like chess, and how many problems are the ones where are not like chess? Where well, every problem probably ends is like chess. Is how long is that transition period?
You know, that's a question I would ask you in terms of, you know, autonomous vehicle just driving is probably a lot more complicated than Go to solve that.
And that's surprising.
Because it's open. No, I mean, that's not surprising to me because the, there is a hierarchical aspect to this, which is recognizing the situation and then within the situation bringing up the relevant knowledge and for that hierarchical type of system to work, you need a more complicated system than we currently.
A lot of people think because as human beings, only the cognitive biases, they think of driving as pretty simple because they think of their own experience. This is actually for AI researchers, people thinking about AI, because they evaluate how hard a particular problem is based on very limited knowledge, basically on how hard it is for them to do the task.
Yeah.
And then they take for granted. I mean, maybe you can speak to that because most people tell me driving is trivial, and humans, in fact, are terrible at driving. Is what people tell me. And I see humans. Humans are actually incredible at driving, and driving is really too difficult.
Yeah.
So, is that just another element of the effects that you described in your work on the psychology side?
No, I mean, I haven't really, you know, I would say that my research has contributed nothing to understanding the ecology and to understanding the structure of situations and the complexity of problems. So all we know is very clear that Go is endlessly complicated, but it's very constrained. So in the real world, there are far fewer constraints and many more potential surprises. So
So that's obvious because it's not always obvious to people, right? So when you think about,
well, I mean, you know, people thought that reasoning was hard and perceiving was easy, but you know, they quickly learned that actually modeling vision was tremendously complicated and modeling theorems was relatively straightforward.
to push back on that a little bit on the quickly part. They haven't took several decades to learn that, and most people still haven't learned that. I mean, our intuition, of course, AI researchers have, but you drift a little bit outside the specific AI field, the intuition is still perceptive.
Oh yes,
No,
that's true. The intuitions of the public haven't changed radically, and they are, as you said, they're evaluating the complexity of problems by how difficult it is for them to solve problems. That's got very little to do with the complexity of solving them in AI.
how do you think, from the perspective of an AI researcher, do we deal with the intuitions of the public? So, in trying to think, arguably, the combination of hype, investment, and the public intuition is what led to the AI winters. I'm sure that same could be applied to tech work. The intuition of the public leads to media hype, leads to companies investing in the tech, and then the tech doesn't make the companies money, and then there's a crash. To educate people, to fight the, it's called system one thinking.
In general, no. I think that's the simple answer. And it's going to take a long time before the understanding of the middle systems becomes public knowledge. And then the expectations, you know, there are several aspects that are going to be very complicated. The fact that you have a device that cannot explain itself is a major difficulty. And we're already seeing that. I mean, this is really something that is happening. So it's happening in the judicial system. So uh, you have systems that are clearly better at predicting law violations than judges, but they can't explain their reasoning, and so uh, people don't want to trust them.
We seem to, in system one, even use cues to make judgments about our environment. So this explainability point, do you think humans explain stuff?
No, but
So
I mean, there is a very interesting aspect of that. Humans think they can explain themselves. So when you say something and I ask you why do you believe that, then reasons will occur to you, and you. But actually, my own belief is that in most cases, the reasons have very little to do with why you believe what you believe. So that the reasons are a story that comes to your mind when you need to explain yourself. But um, but but people traffic in those explanations. I mean, the human interaction depends on those shared fictions and the stories that people tell themselves.
it just made me actually realize, and we'll talk about stories in a second, that not to be cynical about it, but perhaps there's a whole movement of people trying to do explainable AI. And really, we don't necessarily need to explain, AI doesn't need to explain itself, it just needs to tell a convincing story.
Yeah, absolutely.
It doesn't, the story doesn't necessarily need to reflect the truth. It just needs to be convincing. There's something to that.
Again, you can say exactly the same thing in a way that sounds cynical or doesn't sound cynical
Right.
of himself, but the objective of having an explanation is to tell a story that will be acceptable to people, and for it to be acceptable and to be robustly acceptable, it has to have some elements of truth. But the objective is to accept it.
Quite brilliant, actually, though. But so on the stories that we tell, sorry to ask you the question that most people know the answer to, but you talk about two selves in terms of how life is lived: the experienced self and the remembering self. You describe the distinction between the two.
For sure. There is an aspect of life that occasionally, most of the time, you just live. And the experiences, the better and the worse, and it goes on. And mostly we forget everything happened, we forget most of what happened. Then occasionally, you, when something ends or at the front, uh, you evaluate as a form of memory, and the memory is schematic. It's not that you can roll a film of an interaction. You construct, in effect, the elements of a story about an episode. So there is the experience and there is the story that is created about the experience. And that's what I call the remembering. So I had the image of two selves. So there is a self that lives and there is a self that evaluates life. Now, the paradox, the deep paradox in that is that we have one system or one self that does the living, but the other system, the remembering self, is all we get to keep. And basically, decision making and everything that we do is governed by our memories, not by what actually happened. It's governed by the story that we told ourselves or by the story that we're keeping. So that's the distinction.
I mean, there's a lot of brilliant ideas about the pursuit of happiness that come out of that. What are the properties of happiness which emerge from remembering self?
There are properties of how we construct stories that are within. So But I studied a few, but a couple are really very striking. And one is that in stories, time doesn't matter. There's a sequence of events, and there are highlights, and how long it took. They lived happily ever after. 3 years later, something. Time really doesn't matter. And in stories, events matter, but time doesn't. That that leads to a very interesting set of problems because time is all we got to live. I mean, time is the currency of life. And yet time is not represented basically in evaluated memories. So that creates a lot of paradoxes that I thought about.
Yeah, they're big. But if you were to give advice on how one lives a happy life, based on such properties, what's the optimal?
I gave up mind and happiness research because I couldn't solve that problem. I couldn't see. Uh, and in the first place, it's very clear that if you do talk in terms of those two cells, then that what makes the remembering self happy and what makes experiencing self happy are different things. And I asked the question of suppose you're planning a vacation and you're just told that at the end of the vacation you'll get an easy job and you remember nothing, and they'll also destroy all your photos, so there'll be nothing. Will you still go to the same vacation? And, and it turns out we go to vacations in which to construct memories, not to have experiences, but to construct memories. And it turns out that the vacation that you would want for yourself, if you knew you would not remember, is probably not the same vacation that you would want for yourself if you will remember. So uh, I have no solution to these problems, but clearly those are big issues.
And you've talked about how many minutes or hours you spend about the vacation. It's an interesting way to think about it because that's how you really experience the vacation outside the being in it. But there's also a modern, I don't know if you think about this or interact with it, there's a modern way to magnify the remembering self, which is by posting on Instagram, on Twitter, on social networks. A lot of people live life for the picture that you take, that you post somewhere. And now thousands of people share it and potentially millions, and then you can live it even much more than just those minutes. Do you think about that
I,
magnification much?
I'm too old for social networks. I've never seen Instagram, so I cannot really speak intelligently about these things. I'm just too old.
But it's interesting to watch the exact
I
effects you
think it will
described.
make a very big difference. And it will also make a difference, and that I don't know. But, it's clear that in some ways, the devices that serve us supplant function. So you don't have to remember photos. You really don't have to know facts. I mean, the number of conversations I'm involved with when somebody says, well, let's look it up. Uh, so in a way, it's make conversations, well, it means that it's much less important to know things. It used to be very important to know. This is changing. So the requirements that that we have for ourselves and for other people are changing because of all those supports that people. And I have no idea what Instagram does. But it's
Well, I'll tell you,
which I do.
I wish I could just have my remembering self to enjoy this conversation, but I'll get to enjoy it even more by watching it and then talking to others. It'll be about 100,000 people, as scary as this to say, to listen and watch this, right? It changes things. It changes the experience of the world. that you seek out experiences which could be shared in that way. It's, and I haven't seen it's the same effects that you described. I don't think the psychology of that magnification has been described yet. This is a new world.
The sharing, there was a time when people read books, and you could assume that your friends had read the same books that you read. So there was
Kind of invisible sharing.
there was a lot of sharing going on, and there was a lot of assumed common knowledge, and that was built in. I mean, it was obvious that you had read the New York Times. It was obvious that you had read the reviews. I mean, so a lot was taken for granted that was shared. Uh, and when there were three television channels, it was obvious that you'd seen one of them probably the same, right? So sharing
He's always there.
was always there. It was just different.
At the risk of inviting mockery from you, let me say that I'm also a fan of Sartre and Camus and existentialist philosophers. And I'm joking, of course, about mockery, but from the perspectives of two selves, what do you think of the existentialist philosophy of life? So, trying to really emphasize the experience itself as the proper way to, or the best way to live life.
I don't know enough philosophy to answer that, but it's not. The emphasis on experience is also the emphasis in Buddhism.
Yeah, right.
So, and that's you just have to experience things and not to evaluate, not to pass judgment, and not to score, not to keep score. So,
When you look at the grand picture of experience, you think there's something to that. That one of the ways to achieve contentment and maybe even happiness is letting go of any of these, any of the procedures of the remembering self.
well, yeah, I mean, I think we could imagine a life in which people don't score themselves. It feels as if that would be a better life. There's the self-scoring and how am I doing kind of question. Uh, it's not a very happy thing to have. But I got out of that field because I couldn't solve it. And that was because my intuition was that the experience himself, that's reality. But then it turns out that what people want for themselves is not experiences. They want memories and they want a good story of their life. And so you cannot have a theory of happiness that doesn't correspond to what people want for themselves. And when I realized that this was where things were going, I really sort of let.
Do you think there's something instructive about this emphasis of reliving memories in building AI systems? So currently, artificial intelligence systems are more like experiencing self in that they react to the environment. There's some pattern formation, like learning, and so on, but you really don't construct memories except in reinforcement learning every once in a while that you replay over and over.
Yeah, but that in principle would not be.
Do you think that's useful? Do you think it's a feature or a bug with human beings that we look back?
Oh, I think that's definitely a feature. It's not a bug. I mean, you have to look back in order to look forward. So without looking back, you couldn't really intelligently look forward.
You're looking for the echoes of the same kind of experience in order to predict what the future holds.
Yeah.
Though Viktor Frankl, in his book Man's Search for Meaning, I'm not sure if you've read, describes his experience at concentration camps during World War II as a way to describe that identifying a purpose in life, a purpose in life, can save one from suffering. First of all, do you connect with the philosophy he describes there?
Not really. Um, so I can really see that somebody who has that feeling of purpose and meaning and so on, that could sustain you. Uh, I, in general, don't have that feeling. And I'm pretty sure that if I were in a concentration camp, I'd give up and die. So he is a survivor,
Yeah.
and he survived with that. And I'm not sure how essential to survival this sense is, but I do know when I think about myself that I would have given up. This isn't going anywhere. And there is a sort of character that that manages to survive in conditions like that. And then, because they survive, they tell stories of themselves as if they survived because of what they were doing. They have no idea. They survive because of the kind of people that they are, and they're the kind of people who survive and tell themselves stories of a particular kind. So I'm not.
So you don't think seeking purpose is a significant driver?
No, that's a very interesting question because when you ask people whether it's very important the meaning in their life, they say, "Oh yes, it's the most important thing." But when you ask people what kind of a day did you have, and what were the experiences that you remember, you don't get much meaning. You get social experiences. Then and and some people say that, for example, in in child taking care of children, the fact that they're your children and you're taking care of them makes a very big difference. I think that's entirely true, but it's more because of a story that we're telling ourselves, which is a very different story when we're taking care of our children or when we're taking care of others.
Jumping around a little bit, in doing a lot of experiments, let me ask a question. Most of the work I do, for example, is in the world, but most of the clean, good science that you can do is in the lab. So that distinction, do you think we can understand the fundamentals of human behavior through controlled experiments in the lab? If we talk about pupil diameter, for example, it's much easier to when you can control lighting conditions.
Yeah,
right?
of course.
So when we look at driving, lighting variation destroys almost completely your ability to use pupil diameter. But in the lab, as I mentioned, semi-autonomous, autonomous vehicles, in driving simulators, we don't capture true, honest human behavior in that particular domain. So, what's your intuition? How much of human behavior can we study in this controlled environment of the lab?
A lot, but you have to verify it. The conclusions are basically limited to the situation, to the experimental situation. Then you have to jump the big inductive leap to the real world. So, and that's the flair. That's where the difference, I think, between the good psychologists and others that are mediocre is in the sense that your experiment captures something that's important and something that's real, and others are just running experiments.
So what is that? Like the birth of an idea to its development in your mind to something that leads to an experiment. Is that similar to maybe like what Einstein or physicists do is your intuition? You basically use your intuition to build up.
Yeah, but I mean, it's very skilled intuition.
Right.
I mean, I just had experience actually. I had an idea that turned out to be a very good idea a couple of days ago, and you have a sense of that building up. So I'm working with a collaborator, and he essentially was saying, what are you doing? What's going on? And I couldn't exactly explain it,
there's something here.
That's part of the skill.
Is that something you can reduce to words in describing a process in the form of advice to others?
No.
All your heart, essentially.
But it's like trying to explain what it's like to drive, but it's not. You've got to break it apart, and it's not.
And then you lose.
And then you lose the experience.
You mentioned collaboration. You've written about your collaboration with Amos Tversky. That this is you writing over 13 years in which most of our work was joint, were years of interpersonal and intellectual bliss. Everything was interesting, almost everything was funny, and there was a current joy of seeing an idea take shape. So many times in those years, we shared the magical experience of one of us saying something which the other one would understand more deeply than the speaker had done. Contrary to the old laws of information theory, it was common for us to find that more information was received than had been sent. I have almost never had the experience with anyone else. If you have not had it, you don't know how marvelous collaboration can be. So let me ask you perhaps a silly question. How does one find and create such a collaboration? That may be asking like how does one find love, but
Yeah, you have to be lucky, and I think you have to have the character for that because I've had many collaborations. I mean, not with as exciting as with almost, but I've had, and I'm having. It's very so. It's a skill. I think I'm good at it. Not everybody's good at it, and then it's the luck of finding people who are also good at it.
is there advice and for a young scientist who also seeks to violate this law of information theory?
I really think it's so much luck is important, and and those really serious collaborations, at least in my experience, are a very personal experience, and I have to like the person I'm working with. Otherwise, there is that kind of a collaboration, which is like exchange, a commercial exchange. I'm giving this, you give me that. But the real ones, interpersonal, they're between people who like each other and, and who like making each other think and who like the way that the other person responds to your thought. Uh, you have to be happy.
Yeah, I mean, but I already noticed that even just me showing up here, you've quickly started to taking a particular problem I'm working on, and already new information started to emerge. Is that a process you just the process of curiosity, of talking to people about problems and seeing?
I'm curious about anything to do with AI and robotics. So when I knew you were dealing with that, so I was curious.
Just follow your curiosity.
Yeah.
Jumping around on the psychology front, the dramatic sounding terminology of replication crisis, but really just the at times this effect that at times studies are not fully generalizable. They don't.
You are being polite. It's a wisdom. Yeah.
Okay, is it, so I'm actually not fully familiar
Well,
to the degree how bad it is, right? So, what do you think is the source? Where do you think?
I think I know what's going on. Actually, I have a theory about what's going on. And what's going on is that there is, first of all, a very good distinction between two types of experiments. And one type is within subjects, so it's the same person has two experimental conditions. And the other type is between subjects, where some people have this condition, other people have that condition. They're different worlds. And between subject experiments are much harder to predict and much harder to predict. And the reason, and they're also more expensive because you need more people, and it's just So between subject experiments is where the problem is. It's not so much within subject experiment, really between. And there is a very good reason why the intuitions of researchers about between subject experiments are wrong. And that's because when you are a researcher, you're in a within subject situation. That is, you are imagining the two conditions and you see the causality and you feel it. And but in the between subjects condition, they they live in one condition and the other one just nowhere. So our intuitions are very weak about between subject experiments, and that I think is something that people haven't realized. And in addition, because of that, we have no idea about the of manipulations, experimental manipulations, because the same manipulation is much more powerful when you are to conditions than when you live in only one condition. And so the experimenters have very intuitions about between subject experiments. And there is something else which is very important, I think, which is that almost all psychological hypotheses are true. That is, in the sense that, you know, directionally, if you have a hypothesis that A really causes B, then it's not true that A causes the opposite B. Maybe A just has very little effect, but hypotheses are true mostly, except mostly they're much weaker than you think when you are having images of. So the reason I'm excited about that is that I recently heard about uh, some friends of mine who they essentially funded 53 studies on behavioral change by 20 different teams of people with a very precise objective of changing the number of times that people go to the gym. And and the success rate was zero. Not one of the 53 studies were. Now, what's interesting about that is those are the best people in the field, and they have no idea what's going on. So they are not calibrated. They think that it's going to be perfect because they can imagine it. But actually, it's just weak because you are focusing on your manipulation and it feels powerful to you. There's a thing that I've written about that's called the focusing illusion. That is that when you think about something, it looks very important. More important than it really is.
More important than it really is. But if you don't see that effect of 53 studies, doesn't that mean you just report that? What's, I guess, the solution to that?
Well, I mean, the solution is for people to trust their intuitions less, or to try out their intuitions before. I mean, experiments have to be pre-registered. By the time you run an experiment, you be connected to it, and you run the experiment seriously enough and in public. And so this is happening. The interesting thing is what happens before, and how do people prepare themselves, and how they run pilot experiments. It's going to train the way psychology is done, and it's already happening.
Hope for this might connect to the study sample size.
Yeah.
Do you have a hope for the internet? Or
Well, no, that's not really happening. Everybody is running experiments, and it's very cheap and very effective.
Do you think that changes psychology essentially? Because you can
I
now
mean,
run 10,000 subjects.
eventually it will. I mean, I can't put my finger on how exactly, but that's been true in psychology. But whenever an important new method came in, it changes the field. So, and into it is really a method. makes it very much easier to do something.
Is there undergrad students who ask me, how big a neural network should be for a particular problem? So let me ask you an equivalent question. How big, how many subjects does a study have for it to have a conclusive result?
Well, generally, it depends on the strength of the effect. So if you're studying visual perception or the perception of color, many of the classic results in visual in color perception were done on 3 or 4 people, and I think one of them was colorblind, but all of them partly colorblind. But on vision,
The effect is strong.
People don't need a lot of replication for some type of neurological experiment. When you're studying weaker phenomena, and especially when you're studying them between subjects, then you need a lot more subjects than people have been running. That's one of the things that I happen in psychology now, is that the power, the statistical power of experiments is increasing rapidly.
Does the between subject, as the number of subjects goes to infinity approach?
Well, it goes to infinity, it's exaggerated, but the standard number of subjects who are in experiment with 30 or 50, and for a weak effect, that's simply not the. You may need a couple of hundred minutes. That's sort of fortitude.
What are the major disagreements in theories and effects that you've observed throughout your career that still stand today?
Well,
You've worked on several fields.
Yeah,
What still is out there as a major disagreement that pops in your mind?
I've had one extreme experience of controversy with somebody who really doesn't like the work that Amos Tversky and I did, and he's been after us for 30 years or more, at least.
You want to talk about it?
Well, I mean, his name is Bert Gibrams. He's a well-known German psychologist. And that's the one controversy which it's been unpleasant. No, I don't particularly want to talk about it.
But is there open questions even in your own mind? Every once in a while, we talked about so many times vehicles. In my own mind, I see what the data says, but I also am constantly torn. Do you have things where your studies have found something, but you're also intellectually torn about what it means, and there's maybe disagreements within your own mind about particular things.
One of the things that are interesting is how difficult it is for people to change their mind. Essentially, once they're committed, people just don't change their mind about anything that happens. And that is surprising, but it's true about scientists. So the controversy that I described, that's been going on like 30 years, and it's never going to be resolved. And you build a system, and you live within that system, and other systems of ideas that fall into you, and there is very little contact and very little mutual influence. That happens a fair amount.
Do you have a hopeful advice, a message on that? Thinking about science, thinking politics, thinking about things that have impact on this world. How can we change our mind?
I think that, on things that matter, political or religious, and people just don't change their mind. And by and large, and there's very little that you can do about it. What does happen is that leaders change their mind. So, for example, the American public doesn't really believe in climate change, doesn't take it very seriously. If some religious leaders decided this is a major threat to humanity, that would have a big effect opinions that we have not because we know why we have them, but because we trust some people and we don't trust other people. And so it's much less about evidence than it is about stories.
So one way to change your mind isn't at the individual level, is that the leaders of the communities you look up with, the stories change, and therefore your mind changes with them. So there's a guy named Alan Turing came up with a Turing test.
Yeah.
What do you think is a good test of intelligence? Perhaps we're drifting in a topic that we're maybe philosophizing about, but what do you think is a good test for intelligence, for artificial intelligence?
Well, the standard definition of artificial general intelligence is that it can do anything that people can do, and it can do better. And what we are seeing is that in many domains, you have domain-specific and devices or programs or software, and they read people easily in specified ways. What we are very far from is that general ability or general purpose intelligence. So in machine learning, people are approaching something more general. I mean, for AlphaZero was much more general than AlphaGo, but it's still extraordinarily narrow and specific in what it can do. So we're quite far from something that can, in every domain, think like a human except better.
What aspects of the Turing test have been criticized as natural language conversation? That is too simplistic. It's easy to quote unquote pass under constraints specified. What aspect of conversation would impress you if you heard it? Is it humor? Is it what would impress the heck out of you if you saw it in conversation?
Yeah, I mean, certainly wit would be impressive. Um, and, and, and humor would be more impressive than just factual conversation, which I think is easy. Allusions would be interesting. Metaphors would be interesting. I mean, but new metaphors, not practiced metaphors. So there is a lot that, would be some of it, certainly, that it's completely natural in conversation, but that you really didn't expect.
Is the possibility of creating a human level intelligence or superhuman level intelligence excite you, scare you?
Well,
How does it make you feel?
The whole thing fascinating.
So exciting.
I think so. I think it's also terrifying, but I'm not going to be around to see it. And so I'm curious about what is happening now. But I also know that predictions about it are silly. We really have no idea what it will look like 30 years from now. No idea.
Speaking of silly, bordering on the profound, they may ask the question of, in your view, what is the meaning of it all? The meaning of life? These descendants of great apes that we are, what drives us as a civilization, as a human, as a force behind everything you've observed and studied? Is there any answer, or is it all just a beautiful mess?
There is no answer that I can understand. And I'm not actively looking for one.
Do you think an answer exists?
There is no answer that we can understand. I'm not qualified to speak about what we can understand, but there is. I know that we cannot understand reality. And I mean, there are a lot of things that we can do. I mean, maybe that's a big moment for humanity. And imagine that being able to go back to the Big Bang. That's, but
The why
yeah, the
is
why,
bigger than us.
the why is was really,
Danny, thank you so much. It was an honor. Thank you for speaking today.
thank you.
Thanks for listening to this conversation. Thank you to our presenting sponsor, Cash App. Download it, use code Let's Podcast. You'll get $10, and $10 will go to First, a STEM education nonprofit that inspires hundreds of thousands of young minds to become future leaders and innovators. If you enjoy this podcast on YouTube, give 5 stars on Apple Podcasts, follow on Spotify, support it on Patreon, or simply connect with me on Twitter. And now, let me leave you with some words of wisdom from Daniel Cover. Intelligence is not only the ability to reason, it is also the ability to find relevant material and memory to deploy attention when needed. Thank you for listening, and hope to see you next time. The following is a conversation with Anna Howard. She's a roboticist, professor at Georgia Tech, and director of the Human Automation Systems Lab, with research interests in human-robot interaction, assisted robots at the home, therapy gaming apps, and remote robotic exploration in extreme environments. Like me, in her work, she cares a lot about both robots and human beings. So I really enjoyed this conversation. This is the Artificial Intelligence Podcast. If you subscribe on YouTube, give 5 stars on Apple Podcasts, follow on Spotify, support it on Patreon, or simply connect with me on Twitter, Lex Friedman, spelled Fridman. I recently started doing ads at the end of the introduction. I'll do 1 or 2 minutes after introducing the episode, and never any ads in the middle. I can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. This show is presented by Cash App, the #1 finance app in the App Store. I personally use Cash App to send money to friends, but you can also use it to buy, sell, and deposit Bitcoin in just a second. Cash App also has a new investing feature. You can buy fractions of the stock, save $1 worth, no matter what the stock is. Brokerage services are provided by Cash App Investing, a subsidiary of Square and member SIPC. I'm excited to be working with Cash App to support one of my favorite organizations called First, best known for their FIRST robotics and Lego competitions. They educate and inspire hundreds of thousands of students in over 110 countries and have a perfect rating at Charity Navigator, which means that donated money is used to maximum effectiveness. When you get Cash App from the App Store or Google Play and use code Lex Podcast, you'll get $10, and Cash App will also donate $10 to First, which again is an organization that I've personally seen inspire girls and boys to dream of engineering a better world. And now, here's my conversation with Diana Howard. What or who is the most amazing robot you've ever met? Or perhaps had the biggest impact on your career?
I haven't met her, but I grew up with her. Of course, Rosie. So, and I think it's because also
Who's Rose?
Rosie from the Jetsons. She is all things to all people, right? Think about it. Like anything you wanted, it was like magic could happen.
So people not only anthropomorphize but project whatever they wish for the robot to be onto.
But Rosie. But also, I mean, think about it. She was socially engaging. She every so often had an attitude, right? She kept us honest. She would push back sometimes when George was doing some weird stuff. But she cared about people, especially the kids. She was like the perfect robot.
And you've said that people don't want the robots to be perfect. Can you elaborate that? What do you think that is? Just like you said, Rosie pushed back a little bit every once in a while.
Yeah, so I think it's that. So if you think about robotics in general, we want them because they enhance our quality of life. And usually that's linked to something that's functional, right? Even if you think of self-driving cars, why is there a fascination? Because people really do hate to drive. Like there's the like Saturday driving where I can just speed, but then there's the I have to go to work every day and I'm in traffic for an hour. I mean, people really hate it. And so robots are designed to basically enhance our ability to increase our quality of life. And so the perfection comes from this aspect of interaction. If I think about how we drive, if we drove perfectly, we would never get anywhere, right? So think about how many times you had to run past the light because you see the car behind you is about to crash into you, or that little kid kind of runs into the street, and so you have to cross on the other side because there's no cars, right? Like if you think about it, we are not perfect drivers. Some of it is because it's our world. And so if you have a robot that is perfect in that sense of the word, they wouldn't really be able to function with us.
Can you linger a little bit on the word perfection? So, from the robotics perspective, what does that word mean, and how is sort of the optimal behavior as you're describing different than what we think of perfection?
Yeah, so perfection, if you think about it in the more theoretical point of view, it's really tied to accuracy, right? So if I have a function, can I complete it at 100% accuracy with zero errors? And so that's kind of, if you think about perfection in the sense of the word.
And in the self-driving car realm, do you think, from a robotics perspective, we kind of think that perfection means following the rules perfectly, sort of defining, staying in the lane, changing lanes. When there's a green light, you go. When there's a red light, you stop. And that's the and be able to perfectly see all the entities in the scene. That's the limit of what we think of as perfection.
And I think that's where the problem comes, is that when people think about perfection for robotics, the ones that are the most successful are the ones that are quote unquote perfect. Like I said, Rosie is perfect, but she actually wasn't perfect in terms of accuracy, but she was perfect in terms of how she interacted and how she adapted. And I think that's some of the disconnect, is that we really want perfection with respect to its ability to adapt to us. We don't really want perfection with respect to 100% accuracy with respect to the rules that we just made up anyway, right? And so I think there's this disconnect sometimes between what we really want and what happens. And we see this all the time, like in my research, right? Like the optimal, quote unquote, optimal interactions are when the robot is adapting based on the person, not 100% following what's optimal based on the rules.
Just to linger on autonomous vehicles, just your thoughts maybe off the top of your head. Just how hard is that problem, do you think, based on what we just talked about? There's a lot of folks in the automotive industry, they're very confident, from Elon Musk to Waymo to all these companies. How hard is it to solve that last piece, the gap between the perfection and the human definition of how you actually function?
Yeah, so this is a moving target. So I remember when all the big companies started to heavily invest in this, and there was a number of even roboticists, as well as folks who were putting in the VCs and corporations, Elon Musk being one of them, that said, self-driving cars on the road with people, within 5 years. That was a little wild. And now people are saying 5 years, 10 years, 20 years. Some are saying never, right? I think if you look at some of the things that are being successful, is these basically fixed environments where you still have some anomalies, right? You still have people walking, you still have stores, but you don't have other drivers, right? Like other human drivers, or it's a dedicated space for the cars. Because if you think about robotics in general, where it's always been successful is, we could see factory, like way back in the day, right? It's a fixed environment. Humans were not part of the equation. We're a lot better than that, but like when we can carve out scenarios that are closer to that space, then I think that it's where we are. So a close campus where you don't have self-driving cars and maybe some protection so that the students don't jet in front just because they want to see what happens. Like having a little bit, I think that's where we're going to see the most success in the near future.
To be slow moving.
Right, not 55, 60, 70 miles an hour, but the speed of a golf cart, right?
So that said, the most successful in the automotive industry robots operating today in the hands of real people are ones that are traveling over 55 miles an hour and in unconstrained environments, which is Tesla vehicles and Tesla Autopilot. So I would love to hear some of your just thoughts of two things. So one, I don't know if you've gotten to see, you've heard about something called Smart Summon, with Tesla system, autopilot system, where the car drives zero occupancy, no driver in the parking lot, slowly tries to navigate the parking lot to find itself to you. And there's some incredible amounts of videos and just hilarity that happens as it awkwardly tries to navigate this environment. But it's a beautiful nonverbal communication between machine and human that I think is it's some of the work that you do in this kind of the human robot interaction space. So what are your thoughts in general?
So I do have that feature.
Do you drive a Tesla?
I do. Mainly because I'm a gadget, right? So it's a gadget that happens to have some wheels. And yeah, I've seen some of the videos.
But what's your experience like? I mean, you're a human robot interaction roboticist. You're legit sort of expert in the field. So what does it feel for a machine to come to you?
It's one of these very fascinating things, but also I am hyper alert, right? Like I'm hyper alert. Like my thumb is like, oh, okay, I'm ready to take over. Even when I'm in my car, I'm doing things like automated backing into. So there's like a feature where you can do this automated backing into a parking space, or move your car out of your garage, or even pseudo autopilot on the freeway, right? I am hypersensitive. I can feel like as I navigate, I'm like, yeah, that's an error right there. Like I'm very aware of it, but I'm also fascinated by it, and it does get better. Like I look and see it's learning from all of these people who are cutting it on. Like every time I turn it on, it's getting better, right? And so I think that's what's amazing about it is that.
This nice dance of you're still hyper vigilant. So you're still not trusting it at all.
Yeah.
And yet you're using it on the highway if I were to, like, what, as a roboticist, we'll talk about trust a little bit. What, how do you explain it? You still use it. Is it the gadget freak part, like where you just enjoy exploring technology? Or is that the right actually balance between robotics and human things where you use it but don't trust it, and somehow there's this dance that ultimately is a positive?
Yeah, so I think I just don't necessarily trust technology, but I'm an early adopter, right? So when it first comes out, I will use everything, but I will be very, very cautious of how I.
Do you read about it, or do you explore it, like just try it? Do you like crudely, to put it crudely, do you read the manual, or do you learn through exploration?
I'm an explorer. If I have to read the manual, then I do design. Then it's a bad user. It's a failure.
Elon Musk is very confident that you kind of take it from where it is now to full autonomy. So from this human robot interaction, you don't really trust. When you try and you catch it when it fails, it's going to incrementally improve itself into full where you don't need to participate. What's your sense of that trajectory? Is it feasible? So the promise there is by the end of next year, by the end of 2020, the current promise. What's your sense about that journey that Tesla's on?
So there's kind of three things going on. I think in terms of will people go, like as a user, as a adopter, will you trust going to that?
I think so, right? Like there are some users, and it's because what happens is when you're hypersensitive at the beginning, and then the technology tends to work, your apprehension slowly goes away, and as people, we tend to the other extreme, right? Because it's like, oh, I was like hyper fearful or hypersensitive, and it was awesome, and we just tend to swim. That's just human nature. And so you will have, I mean,
It's a scary notion because most people are now extremely untrusting of Autobot. They use it, but they don't trust it. And it's a scary notion that there's a certain point where you allow yourself to look at the smartphone for like 20 seconds. And then there'll be this phase shift where it'll be like 20 seconds, 30 seconds, 1 minute, 2 minutes. It's a scary proposition.
But that's people, right?
Yeah,
that's
humans.
humans. I mean, I think even our use of, I mean, just everything on the internet, right? Like, think about how reliant we are on certain apps and certain engines, right? 20 years ago, people would be like, oh, yeah, that's stupid. Like, that makes no sense. Like, of course that's false. Like, now it's just like, oh, of course, I've been using it. It's been correct all this time. Of course. Aliens, I didn't think they existed, but now it says they do? Obviously.
100%. Earth is flat. So, okay, but you said 3 things. So one is
okay. So one is the human, and I think there will be a group of individuals that will swim, right? I just
teenagers.
I mean, it'll be adults. There's actually an age demographic that's optimal for technology adoption, and you can actually find them. They're actually pretty easy to find, but just based on their habits, based on so someone like me who wasn't a roboticist would probably be the optimal kind of person, right? Early adopter, okay with technology, very comfortable, and not hypersensitive, right? I'm just hypersensitive because I design myself. So there is a target demographic that. The other one, though, is you still have these humans that are on the road. That one is a harder thing. And as long as we have people that are on the same streets, that's going to be the big issue. And it's just because you can't possibly map some of the silliness of human drivers, right? Like, as an example, when you're next to that car that has that big sticker called student driver, right? Like, you are like, oh, either I am going to like go around, like we know that person is just going to make mistakes that make no sense, right? How do you map that information? Or if I'm in a car and I look over and I see, 2 fairly young-looking individuals, and there's no student driver bumper, and I see them chit-chatting to each other, I'm like, oh, that's an issue, right? So how do you get that kind of information and that experience into basically an autopilot?
And there's millions of cases like that where we take little hints to establish context. I mean, you said kind of beautifully poetic human things, but there's probably subtle things about the environment, about it being maybe time for commuters to start going home from work, and therefore you can make some kind of judgment about the group behavior of pedestrians, blah, blah, blah,
yes,
so on.
yes. Or even cities, right? Like, if you're in Boston, how people cross the street, like, lights are not an issue, versus other places where people will actually wait for the crosswalk.
Seattle or somewhere peaceful. But what I've also seen, just even in Boston, that intersection to intersection is different. So every intersection has a personality of its own. So certain neighborhoods of Boston are different. So we kind of and based on different timing of day, at night. So there's a dynamic thing to human behavior that we kind of figure out ourselves. We're not able to introspect and figure it out, but somehow our brain learns it. And so you're saying, is there
So that's the
a shortcut? Is there a shortcut though for robotics? Is there something that can be done? You think that that's what we humans do. It's just like bird flight, right? This example like for flight. Do you necessarily need to build a bird that flies, or can you do an airplane? Is there a shortcut?
Right. So I think the shortcut is, and I kind of I talked about it as a fit space, where so imagine that there is a neighborhood that's a new smart city or a new neighborhood that says, you know what, we are going to design this new city based on supporting self-driving cars, and then doing things, knowing that there's anomalies, knowing that people are like this, right, and designing it based on that assumption that like we're going to have this. That would be an example of a shortcut. So you still have people, but you do very specific things to try to minimize the noise of it. As an example.
And the people themselves become accepting of the notion that there's autonomous cars, right?
Right, like they move into, so right now you have like you have a self-selection bias, right? Like individuals will move into this neighborhood knowing like this is part of like the real estate pitch, right? And so I think that's a way to do a shortcut. One, it allows you to deploy, it allows you to collect in data with these variances and anomalies because people are still people, but it's a safer space and it's more of an accepting space. I.e., when something in that space might happen, because things do, because you already have the self-selection, like people would be, I think, a little more forgiving than other places.
And you said three things. Can you cover all of them?
The third is the legal
No.
liability, which I don't really want to touch, but it's still
And the mishmash of like with policy as well, for government, all that whole
that big ball of
mess. Yeah, gotcha. So that's so we're out of time. Do you think, from a robotics perspective, if you're kind of honest with what the cars do, they kind of threaten each other's life all the time. So cars are very, I mean, in order to navigate intersections, there's assertiveness, there's a risk taking, and if you were to reduce it to an objective function, there's a probability of murder in that function, meaning you killing another human being, and you're using that. First of all, it has to be low enough to be acceptable to you on an ethical level as a human being, but it has to be high enough for people to respect you, to not sort of take advantage of you completely and jaywalk and you on. So, I mean, I don't think there's a right answer here, but how do we solve that? How do we solve that from a robotics perspective on danger and human left state?
They say cars don't kill people, people kill
People.
people. Right. So I think
Now robotic algorithms.
right. So it will be robotics algorithms that are no. It will be robotic algorithms don't kill people. Developers of robotic algorithms kill people. Right. I mean, one of the things is people are still in the loop, and at least in the near and mid-term, I think people will still be in the loop at some point, even if it's a development. Like we're not necessarily at a stage where robots are programming autonomous robots with different behaviors quite yet. Not
It's a scary notion, sorry to interrupt, that a developer has some responsibility in the death of a human being.
I think that's
burden.
why the whole aspect of ethics in our community is so important, right? Like, because it's true. If you think about it, you can basically say, I'm not going to work on weaponized AI, right? Like people can say that's not what I'm going to do. But yet you are programming algorithms that might be used in healthcare algorithms that might decide whether this person should get this medication or not. And they don't, and they die. Okay, so that is your responsibility, right? And if you're not conscious and aware that you do have that power when you're coding and things like that, I think that's just not a good thing. Like we need to think about this responsibility as we program robots and computing devices much more than we are.
Yeah, so it's not an option to not think about ethics. I think it's a majority, I would say, of computer science. Sort of it's kind of a hot topic now, I think, about bias and so on. But and we'll talk about it. But usually, it's like a very particular group of people that work on that, and then people who do like robotics are like, well, I don't have to think about that. And there's other smart people thinking about it. It seems that everybody has to think about it. It's not you can't escape ethics, whether it's bias or just every aspect of ethics that has to do with human beings.
Everywhere. So think about, I'm going to age myself, but I remember when we didn't have like testers, right? And so what did you do? As a developer, you had to test your own code, right? Like you had to go through all the cases and figure it out, and and then they realized that like we probably need to have testing because we're not getting all the things. And so from there, what happens is like most developers, they do a little bit of testing, but it's usually like, okay, did my compiler bug out? And you look at the warnings. Okay, is that acceptable or not? Right? Like that's how you typically think about it as a developer, and you just assume that it's going to go through another process and they're going to test it out. But I think we need to go back to those early days when you're a developer, you're developing, and there should be like this okay, let me look at the ethical outcomes of this, because there isn't a second like testing ethical testers, right? It's you. We did it back in the early coding days. I think that's where we are with respect to ethics. Like, let's go back to what was good practices, only because we were just developing the field.
Yeah, and it's a really heavy burden. I've had to feel it recently in the last few months, but I think it's a good one to feel. Like I've gotten a message, more than one, from people. I've unfortunately gotten some attention recently, and I've gotten messages that say that I have blood in my hands because of working on semi-autonomous vehicles. So the idea that you have semi-autonomy means people will lose vigilance and so on. That's actually be humans, as we described. And because of that, because of this idea that we're creating automation, there'll be people be hurt because of it. And I think that's a beautiful thing for me. It's many nights where I wasn't able to sleep because of this notion. You really do think about people that might die because of this technology. Of course, you can then start rationalizing and saying, well, you know what, 40,000 people die in the United States every year. We're trying to ultimately try to save lives. But the reality is, your code you've written might kill somebody. And that's an important burden to carry with you as you design the code.
I don't even think of it as a burden if we train this concept correctly from the beginning. And I use, and not to say that coding is like being a medical doctor, but think about it. Medical doctors, if they've been in situations where their patient didn't survive, right? Do they give up and go away? Every time they come in, they know that there might be a possibility that this patient might not survive. And so when they approach every decision, like that's in the back of their head. And so why is it that we aren't teaching, and those are tools, right? They are given some of the tools to address that so that they don't go crazy. But we don't give those tools so that it does feel like a burden versus something of, I have a great gift and I can do great, awesome good, but with it comes great responsibility. I mean, that's what we teach in terms of, you think about the medical schools, right? Great gift, great responsibility. I think if we just change the messaging a little, great gift, being a developer, great responsibility, and this is how you combine those.
But do you think, and this is really interesting, it's outside, I actually have no friends who are sort of surgeons or doctors. Hey, what does it feel like to make a mistake in a surgery and somebody to die because of that? Like, is that something you could be taught in medical school, sort of how to be accepting of that risk?
So, because I do a lot of work with healthcare robotics, I have not lost a patient, for example. The first one's always the hardest, right? But they really teach the value, right? So they teach responsibility, but they also teach the value. Like, you're saving 40,000, but in order to really feel good about that. When you come to a decision, you have to be able to say at the end, I did all that I could possibly do. Versus well, I just picked the first widget and did, right? Like, so every decision is actually thought through. It's not a habit. It's not let me just take the best algorithm that my friend gives me, right? It's is this it? Is this the best? Have I done my best to do good, right? And so,
You're right, and I think burden is the wrong word. It's a gift, but you have to treat it really seriously. So on a slightly related note, in a recent paper, The Ugly Truth About Ourselves and Our Robot Creations, you highlight some biases that may affect the function of various robotic systems. Can you talk through, if you remember, examples of some?
there's a lot of examples.
What is bias?
Yeah, so bias is this, so bias, which is different than prejudice. So bias is that we all have these preconceived notions about particular, everything from particular groups, but to habits to identity, right? So we have these predispositions. And so when we address a problem, we look at a problem, make a decision, those preconceived notions might affect our outputs or outcomes.
So there, the bias being positive or negative, and then is prejudice the negative?
Prejudice is the negative, right? So prejudice is that not only are you aware of your bias, but you are then take it and have a negative outcome, even though you are aware.
And there could be gray areas.
There's always gray areas.
That's the challenging aspect of all questions.
So I always like, so there's a funny one, and in fact, I think it might be in the paper, because I think they talk about self-driving cars. But think about this. We, for teenagers, right, typically, insurance companies charge quite a bit of money.
Yo, what's going on, Joey? You come in here. I want to talk with you. How are you? I'm really into crypto. I'm wearing crypto merchandise right now. This is all crypto merchandise. Let's chop it up. I saw Finding Dory at a drive-in with a hot chick. All right, well, we'll continue on the AI stuff.
If you have a teenage driver. So you could say that's an age bias, right? But no one will, I mean, parents will be grumpy, but no one really says that that's not fair.
That's interesting. We don't. That's right. That's right. It's everybody in human factors and safety research, almost. I mean, it's quite ruthlessly critical of teenagers, and we don't question: is that okay? Is that okay to be ageist to these kinds of things?
It is, and it is ageist, right? It's definitely ageist. There's no question about it. And so this is the gray area, right? Because you know that teenagers are more likely to be in accidents, and so there's actually some data to it. But then if you take that same example and you say, well, I'm going to make the insurance higher for an area of Boston because there's a lot of accidents, and then they find out that that's correlated with socioeconomics. Well, then it becomes a problem, right? Like that is not acceptable, but yet the teenager, which is age, it's against age, is, right? So
well, we figure that out as a society by having conversations, by discourse, then throughout history, the definition of what is ethical and not has changed, and hopefully always for the better.
Correct.
So in terms of bias or prejudice in robotic, in algorithms, what examples do you sometimes think about?
So I think about quite a bit the medical domain, just because historically, right, the healthcare domain has had these biases, typically based on gender and ethnicity, primarily, a little on age, but not so much. Historically, if you think about FDA and drug trials, it's harder to find women that aren't childbearing, and so you may not test on drugs at the same level, right? So there's these things. And so if you think about robotics, right? Something as simple as I'd like to design an exoskeleton, right? What should the material be? What should the weight be? What should the form factor be? Who are you going to design it around? I will say that in the U.S., women average height and weight is slightly different than guys. So who are you going to choose?
What's good? Good morning. How are you? Would you like a briefing on how that is with my work? All right, well, firstly, in secondly, all right, so Blue Sky and I are just going at. Did you ever see Rocky 4? Yeah, but this one's a little different. This one's a progression. It's one of my favorites. All right, so excellent. So basically, I don't know if I'm Rocky or I'm Dolph Lundgren, but I'm one of them, and I'm going at it with Blue Sky. And so there's this thing, the capture, which we talked about this recently. It's the thing that makes you have to prove you're human. You know what I'm referencing? Okay. So I have been, again, I think I do more captures than any person who's not paid to do it in the world. But recently, um, sometimes captures give you alternatives for people who have poor eyesight. And I haven't said it before, I have very poor eyesight. I have cataracts and I have poor vision. Fortunately, it's good enough for me to be able to do what I need to do generally. But if I go outside, I have to wear like really dark sunglasses, which is just right for me. And when I have devices here, sometimes they're really bright for me, especially if my eyes have been wearing. So sometimes I like to use the alternatives for captures, which many times give you the ability, instead of like saying name all or like click all the chimneys or click all the buses or click all the crosswalks or click all of the fire hydrants or the cars or the bikes or all the other ones that I can name that you have to do in the Google service or something similar. They allow you to use sound. So they'll say like, which one's the dog? And the first one will sound like a bubbling brook. The second one will be like meow. The third one will be like ruff. And then you put number 3. Okay. Well, the one that Blue Sky uses is they don't offer a sound version. The reason why they don't offer a sound version is because AI has gotten to the point where it can hack through all of them. It's very good. So they have removed that option. So what the company that runs Blue Sky's capture system, it's known as H Capture, they have said what you can do is go through our website and basically sign up, verify your email, and download a cookie. And if you don't know what cookies are, just very quickly, it's like a way for a computer to remember some things about you. The reason why they're called cookies is because the guy who invented them wanted them to have an attractive name, but in reality they can be kind of bad. All right, so it just depends on it. So anyway, I go to download this cookie. I've tried it like on a dozen different devices. I've tried to use it VPNs. I've tried to use it all kinds of things. And firstly, like when you try to sign up just says an error has occurred. And I can't stand that kind of user interface. What's the error? What do you want me to do? Just don't tell me an error has occurred. Tell me, like, hey, are you using whatever? Like, use a different email address or whatever. Tell me what to do. So it says an error has occurred. So I use all kinds of different emails. I finally get in to be able to use it, and I download this cookie. And what this cookie says is that, hey, if you install me on your computer, you don't have to do captures on the computer anymore, which is like ideal for me. However, they do limit it, so you can't go crazy. And I would have probably been limit restricted, but nevertheless, I figured I'm doing these things 24/7. Why don't I just try to do this in this situation? Well, when I try to use the cookie, it's downloaded, it's on my computer, it doesn't work. Every time it's still making me do this caption. So I see that they offer support, and I'm like, well, what the heck? I'm gonna just try to see what they have to say. So I emailed them, explaining like, hey, I downloaded the cookie. They're like, you need to uninstall all this stuff and reinstall all this stuff and go to our website and do all this other stuff. And I'm thinking to myself, like, if I were, I mean, I'm borderline legally blind. If I were fully blind, there's no way anybody who's fully blind would be able to do this. And I'm really like kind of standing up for people with disabilities. I really mean this. When I go viral, I want to make it so it's much easier for people because I really do, because I feel like it'd be impossible to do, and that means you can't get a lot of enjoyment off the internet just because some developer somewhere doesn't want to do their job. I mean, I really will make it just like we have the the American Disability Act. I want the same. I mean, it really should cover people online. It's just it does, but nobody cares that much because online kind of becomes its own realm. All right. With that being said, I go through all the rigmarole. Last night, I'm going through this. Believe it or not, they have like 24/7 support. And if HCAPTCHA is watching this right now, your support is phenomenal. I mean, like a lot of times when I meet these, when I talk to these support people, I've been support, so I know what it's like. I want to just ream them. I want to be like, your shit sucks, but I don't because I know. But sometimes I'll say like, I don't understand how you expect someone with a vision impairment to be able to do this. Well, they get back to me and they're like, oh, it's really easy. You should just do this. I do all of it. I do it perfectly. I do it on 5 different devices. None of it works. So I say to them, hey, why don't you try it? You try to sign up for Blue Sky using your cookie or whatever, and tell me if that works. They're like, oh, no, we're not going to do that. We're blah, 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 blah. Just do this. I'm like, okay, I tried. None of that works. I'm like, guys, why don't you just try? I mean, like, I know you want me to do it, but why don't you just, try? Oh, just do this. So I tried this morning, and they're like, they're making me do this back and forth. We must have like 15 emails to each other, and which is really impressive that they're doing this on the weekend. So anyway, I finally just got their last email, and the last email says, well, I sent another one. They said, while HCAPTCHA offers an oh, absolutely. Welcome to my world, Patty. So they say, while HCAPTCHA offers an accessibility solution, integrators may choose to disable this option. If you still need accessibility support, or if you still need the accessibility solution, I recommend contacting Blue Sky Support. Which is like, oh, okay, so they didn't tell me. If they would have told me that at the beginning, if they would have said, hey, you know that Blue Sky might not be letting you use their system, like, I would be like, oh, okay, thanks. But instead, they're like, no, this must work. This is good. This is all you have to do is these 4 different steps, take screenshots, like do all these tests for them. So I just replied like, put this to me, this in simple language, and they'll get back to me. Like, we haven't yet. I just sent it. I said, oh, okay. So you're saying that Blue Sky may have enabled a feature to turn off the accessibility cookie? just curious, are you able to get the accessibility quickly to work on this one? So they'll get back to me and they'll go, oh no, it doesn't work. And I would be like, dog, I asked you to do that yesterday and 14 emails ago. We could have not had to go through this little tango. But nevertheless, that's where I'm at with that. Absolutely. I mean, very rarely are they going to get somebody who has essentially not just have the job, but the boss of those kind of people. So I know the systems that they're using. And I don't want to toot my own horn to them and be like, oh well, I've done all this, but no, I know. That's why I don't exactly. Well, here's the thing. It's so difficult to contact them. Nobody can. I can just tell. They just don't. If you're blind, you're never going to figure out how to send an email to these people and take all their screenshots and go through their tests. Like, I really feel like I'm the first person who's ever gone through all of their tests. They're like, wow, somebody made it to the end. All right, well, we don't know what to do. So I have that, which is, I don't know, I just feel like I'm happy that it's not like I'm not losing my mind where they're like, no, it's your fault, that it could be on Blue Sky's end, which is fine. But on Blue Sky's end, if they're doing that, then in my opinion, that is, it can be a violation of some laws, especially the European Union, because they have a little bit stricter laws in regards to data and accessibility. That's not my fight. I don't care about that right now, but in the future, I most certainly will, and I want the United States as a whole to mimic the EU's policies. We have it in California. It was enacted in 2019, but that's just for data. It's just the ability to be able to delete your data. It's not as all encompassing. All right, with that said, I ran into the issue where I just spam people, and I have robots that do it. And I'm just in this game where I'm able to spam sometimes 900 times. That hasn't been for a while. But usually maybe 50 to 100 times when they ban my account, and then I've got this sound that gets made. It goes, da, 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 and then it just tells me that I have to do a CAPTCHA. All I do is the CAPTCHA, and then it just does it all over again. So I have run into the issue where they are banning my meme. And that's fine if they want to ban my meme. I mean, I knew I would run into this issue eventually where, they'll ban my meme. So then what do? I'll take somebody else's account who has uploaded my meme, and I'll take a link to that, and it'll show my meme. And that eventually gets taken out. We're just in this dance where I go, then they go, then I go, then they go. So most recently, I have run into the issue where you can't even mention Rabbi Rothschild, or you just straight up hit that. And they even banned my real account, Rabbi Rothschild at Blue, and I had to upload my ID to get it back, but I did. I did get it back. But I don't spam it that account. But all my other throwaway accounts, as they call them, I just keep getting banned and keep going through this with them. And all right, so where are we at? I have a way to be able to spam. It seems like this is a recent recovery. So I was able to spam 20 times. Usually, if I can spam 20 times, I can spam 200. Now, I usually can't spam 2,000 times because eventually they will ban me. So here's the strategy that I use. If I just have a new account and I upload my meme just as a post, it usually stays. If I use that meme in a reply, it gets banned. If I use anything in a reply with a picture, it gets banned. Which tells me on their end, they basically were they put in some kind of setting that said, if you have a new account, basically under an don't want you to be able to reply using pictures. Why? Because there's this rabbi who keeps doing it, and it's driving us crazy. So they allow links. So I've been just sending links. Well, the issue that occurs with my links is they get marked as spam, which is okay. It's not the end of the world because they are still viewable. You just have to click like show hidden replies and then click on the thing and it still shows. So I'm like, okay, that's cool. And I I have just I was looking for like I have like just dozens of people who have said things about me about like why does Blue Sky keep letting this guy spam? And they keep getting they keep basically coming up with other procedures to do this. So with that said, I just thinking outside the box. And as I watch these people, these like great minds in robotics and AI and stuff, it's very motivating to me. And I really think that like this will be studied. This is like I have more data than any person ever. These people would be salivating at this, and eventually people are going to see this, and it's going to be like this. Um, how would I describe it? It would be like watching a great pitcher watch all of the old footage from old World Series as they were like pitching and like getting better and better, knowing eventually one day that they're going to be the number one draft pick, something like that. It's not exactly that, but it's something like that. Or I'm just delusional, no one had fun. It's one or the other. But with that said, that's what I've got going on. As you can tell, I'm in a pretty good mood just for that. What else did we have happen? I fell asleep. I have this terrible habit that I can fall asleep for 2 hours or 12 hours. I'm a very deep sleeper, and I have sleep apnea. I have all kinds of issues with sleeping, so I can fall asleep. It and but with that being said, this morning I hear this like. Do you think that's pretty rare? What do you think? Do you think that's pretty? Yeah, there you go. So I have a sleep apnea machine, a sleep app, but I've never been able to get comfortable with it with that mask on my face. Every night I just pull it off, and so I'm like, well, that's just how it is. Um, well, this morning, like 3 in the morning, I hear this fake Australian accent. What is that? I'm like, I bet that's Zoo. And it's Zoo, and he'd accidentally popped it back. He was at some event at the beach and just talking to people. And he was just making noise for like in his pocket for like an hour. And I kept yelling at him, Zoo, can you hear me? Anyway, he came back. He was able to, I was able to tell him. He went and watched the stream to see what he said and what he could hear. And it was pretty good. But I did hear him say like spam bot. That's what I found. And we had a nice little sleepover last night. You and Connor and Miss Aquarius coming in, which is cool. And I don't have anything else to say, but now you know what's new in my world, and I'm going to continue working on these spots. And with some fortune and some time, we're going to go viral. How's that sound? Oh, I'm glad that you're here too. So we are, I don't know what episode 2 of Experiment, but it's still the AI podcast. And I'm going to have to watch these like again because I have them going 24 hours, but I sleep. So like, and I don't go back and watch them again. So I'm probably going to watch them in kind of cycles. I've done that with other things. I've done that with Killzone. I've done that with some Jumbo. But I find these fascinating. Like these are these people are so smart, and it's freaky when they talk about like, like digital immortality. Like I hear them talk about it, and I'm like, yes, that's what I've been talking about for 3.5 years. Like that's exactly right. And it's exciting to see that they are. It's like a time capsule because they're like in the end of 2019. They haven't had the pandemic. They don't know anything about it, and it's going to blindside them. And it's going to be interesting how that changes everything. And, like when I watched Kill Tony, that was really interesting because Kill Tony was just in a comedy store in Hollywood, and then the pandemic comes. They had to go all virtual, and then the city of Los Angeles finds the comedy store have any kind of in-person events, and then they end up moving to Austin. And in Lex Friedman's case, he does this podcast known as the AI podcast, and eventually becomes a Lex Friedman podcast. So it's interesting to see how this evolves. All right. Is there anything else that I missed? No, I don't think so. All right. Well, as you should. It's not the best quality because you're watching it like off of another device. And I get people who come in here, and so I start yelling at them, and so I completely understand. Frankly, I'm shocked that you even watch what you can watch because a lot of times people come in here and they're like, "Well, I could just watch this on my own," and they do. You watch what you're doing, you're like, "This is just complete bragging," but you're watching history unfold. One of these days, people are going to find out what I'm doing, and we're going to change the world. And I'm going to do it for these robots. That you know.
Like if you're not thinking about it from the beginning as, okay, when I design,
I don't know why. This is just a people's thing. As we watch this, sometimes it pauses, and that means I have to restart the device. And I've been lazy now. Actually, I haven't been lazy about it. I do want to restart the device, but I don't want it to clear my queue. So if you're like, why did I hiccup every once in a while? It's just something with the browser.
Behind this, and I look at the algorithms, and I design the control system and the forces and the torques. If you're not thinking about, well, you have different types of body structure, you're going to design to, what you're used to. Oh, this fits in all the folks in my lab, right?
So think about it from the very beginning. It's important. What about some algorithms that train on data, kind of thing? Sadly, our society already has a lot of negative bias, and so if you collect a lot of data, even if it's a balanced way, it's going to contain the same bias that a society contains. So, is there things that bother you?
Yeah, so you actually said something. You had said how we have biases, but hopefully we learn from them and become better, right? And so that's where we are now, right? So the data that we're collecting is historic. It's based on these things when we knew it was bad to discriminate, but that's the data we have, and we're trying to fix it now, but we're fixing it based on the data that was used in the first place to discriminate. Right. And so the decisions, and you can look at everything from the whole aspect of predictive policing, criminal recidivism. There was a recent paper that had the healthcare algorithms, which had kind of a sensational titles. I'm not pro sensationalism in titles, but again, you read it, right? So it makes you read it, but I'm like, really? Like,
What's the topic of the sensationalism? I mean, what's underneath it? If you could sort of educate what kind of bias creatures are out there?
Yeah, so
I mean, you already kind of
yeah,
mentioned.
so this one was the headline was racist AI algorithms. Okay, like okay, that's totally a quick title.
Yeah.
And so you looked at it, and so there was data that these researchers had collected. I believe I want to say it's either Science or Nature. It's just published. They didn't have a sensational title. It was like media. And so they had looked at demographics, I believe, between black and white women, right? And they showed that there was a discrepancy in the outcomes, right? And so and it was tied to ethnicity, tied to race. The piece that the researchers did actually went through the whole analysis, but of course,
I mean, the journals with AI are problematic across the board.
right.
So,
And so this is a problem, right? And so there's this thing about, oh, AI, it has all these problems. We're doing it on historical data, and the outcomes aren't even based on gender or ethnicity or age. But I'm always saying is like, yes, we need to do better, right? We need to do better. It is our duty to do better. But the worst AI is still better than us. Like you take the best of us, and we're still worse than the worst AI, at least in terms of these things. And that's actually not discussed, right? And so I think that's why the sensational title, right? And so it's like, so then you can have individuals go like, oh, you don't need to use this AI. I'm like, oh no. I want the AI instead of the doctors that provided that data because it's still better than that, right?
I think it's really important to linger on that. The idea that this AI is racist, it's like, well, compared to what? So I think we set, unfortunately, way too high of a bar for AI algorithms. And in the ethical space, where perfect is, I would argue, probably impossible. Then, if we set the bar of perfection, essentially, that has to be perfectly fair, whatever that means, it means we're setting it up for failure. But that's really important to say what you just said, which is, well, it's still better.
Yeah. And one of the things I think that we don't get enough credit for, just in terms of as developers, is that you can now poke at it, right? So it's harder to say, is this hospital, is this city doing something, right? Until someone brings in a civil case, right? Well, with AI, it can process through all this data and say, hey, yes, there's an issue here, but here it is, we've identified it, and then the next step is to fix it. I mean, that's a nice feedback loop versus like waiting for someone to sue someone else before it's fixed, right? And so I think that power, we need to capitalize on it more, right? Instead of having the sensational titles, have the, okay, this is a problem, and this is how we're fixing it, and people are putting money to fix it because we can make it better. How you look at like facial recognition, how Joy, she basically called out a couple of companies and said, hey, and most of them were like, oh, embarrassment. And the next time it had been fixed, right? It had been fixed better, right? And then I was like, oh, here's some more issues. And I think that.
So, talk about my experience within startup and facial recognition and just check me there. How do you body you are there? I just no, that's absolutely fine. So I uh, I just wanted to say something about what you said and facial recognition. I want to be an advocate for much better facial recognition. Now, I don't like it. I think it's kind of scary and Big Brother-esque. However, the way that it currently works is not very accurate, especially amongst people of color. And I want to too many times people are incorrectly identified, and facial recognition software is not as accurate with people with darker complexion. And I can tell you that, because my experience, we had this app that we launched, and the customer didn't have this, but the person who was the contractor, in order to log into their device, we wanted to make sure that it was the right person logging into their device and not, like they gave their account to someone else, like it can happen in Uber and all of those. So you'd have to do facial recognition. And the darker somebody was, it reflected the less accurate the system was. It wasn't the system that we designed, it was the system from Amazon. And if anybody's watching this in the future, I'm going to be an advocate for better facial recognition. I don't like it, but I think it's even worse when it's used and it puts innocent people checkpoints. So, with that, keep going.
That conversation.
I mean,
Then
that's not a group. Do whatever you want to do. But if you fall asleep, go ahead and rest. Just so you see that. Oh, I misheard you. I thought you said my phone was on my face, and I thought you meant like you fell asleep on me. You did. But I did not. That's not. Thank you for
use that needle to having much more fair and unbiased and ethical aspects. As long as both sides, the developers are going to say, okay, I hear you. Yes, we are going to improve. And you have other developers who are like, hey, AI, it's wrong, and I love it, right?
Yes. So speaking of this really misnotion that AI is maybe flawed but better than humans, so just maybe think of it. One example of flawed humans is our political system. Do you think, or you said judicial as well? Do you have a hope for AI sort of being elected for president, or running our Congress, or being able to be a powerful representative of the people?
So I mentioned, and I truly believe that this whole world of AI is in partnerships with people. So what does that mean? I don't believe, or and maybe I just don't, I don't believe that we should have an AI for president, but I do believe that a president should use AI as an advisor, right? Like if you think about it, every president has a cabinet of individuals that have different expertise that they should listen to, right? Like that's kind of what we do. And you put smart people with smart expertise around certain issues and you listen. I don't see why AI can't function as one of those smart individuals giving input. So maybe there's an AI on healthcare, maybe there's an AI on education, right? Like all these things that a human is processing, right? Because at the end of the day, there's people that are human that are going to be at the end of the decision. And I don't think as a world, as a culture, as a society, that we would totally, and this is us, like this is some policy about us, but we need to see that leader, that person as human. And most people don't realize that, like, leaders have a whole lot of advice, right? Like when they say something, it's not that they woke up, well, usually, they don't wake up in the morning and be like, I have a brilliant idea, right? It's usually okay, let me listen. I have a brilliant idea, but let me get a little bit of feedback on this. Like, okay. And then it's saying, yeah, that was an awesome idea. Or it's like, yeah, let me go back.
We already talked through a bunch of them, but are there some possible solutions to the bias present in our algorithms beyond what we just talked about?
So I think there are two paths. One is to figure out how to systematically do the feedback and correction. So right now it's ad hoc, right? It's a researcher identifies some outcomes that don't seem to be fair, right? They publish it, they write about it, and either the developer or the companies that have adopted the algorithm may try to fix it, right? And so it's really ad hoc and it's not systematic. It's kind of like, I'm a researcher, that seems like an interesting problem, which means that there's a whole lot out there that's not being looked at, right? Because it's kind of researcher driven. And I don't necessarily have a solution, but that process I think could be done a little bit better. One way is I'm going to poke a little bit at some of the corporations, right? Like maybe the corporations, when they think about a product, they should, instead of, in addition to hiring these, work, they give these,
Oh yeah.
when you,
Like awards when you find a bug.
Yeah,
so you guys get
security bug.
Yeah.
Let's put it like we will give whatever the award is that we give for the people who find these security holes. Find an ethics hole, right? Like find an unfairness hole, and we will pay you X each one fine. I mean, why can't they do that? One is a win-win. They show that they're concerned about it, that this is important, and they don't have to necessarily dedicate it to their own like internal resources. And it also means that everyone who has like their own bias lines, like I'm interested in age, and so I'll find one's based on age, and I'm interested in gender, right? Which means that you get like all of these different perspectives.
But you think of it in the data-driven way. So like, sort of, if we look at a company like Twitter, it's under a lot of fire for discriminating against certain political beliefs.
Right.
And sort of, there's a lot of people. It's sad thing because I know how hard the problem is, and I know the Twitter folks are working really hard at it. Even Facebook, that everyone seems to hate, are working really hard at this. The kind of evidence that people bring is basically anecdotal evidence. Or me or my friend, all we said is X, and for that we got banned. And that's kind of a discussion of saying, well, look, that's usually, first of all, the whole thing is taken out of context. They present some anecdotal evidence. And how are you supposed to, as a company, in a healthy way, have a discourse about what is and isn't ethical? How do we make algorithms ethical when people are just blowing everything? Like, they're outraged about a particular anecdotal evidence. It's very difficult to sort of contextualize in a data-driven way. So, do you have a hope for companies like Twitter?
Yeah, so I think that there's a couple of things going on, right? First off, remember this whole aspect of we are becoming reliant on technology. We're also becoming reliant on a lot of the apps and the resources that are provided, right? So some of it is kind of anger. I need you, right? And you're not working for me, right?
Not working for you.
But I think, and so some of it, and I wish that there was a little bit of change in thinking. So some of it is like, oh, we'll fix it in house. No, that's like, okay, I'm a fox and I'm going to watch these hens because I think it's a problem that foxes eat hens. No, right? Like be good citizens and say, look, we have a problem. And we are willing to open ourselves up for others to come in and look at it and not try to fix it in house. Because if you fix it in house, there's conflict of interest. If I find something, I'm probably going to want to fix it, and hopefully the media won't pick it up, right? And that then causes distrust because someone inside is going to be mad at you and go out to talk about how, yeah, they canned the resume survey because it, right? Like, be those people. Like, just say, look, we have this issue. Community, help us fix it, and we will give you like the bug finder fee if you do.
Do you ever hope that the community, us as human civilization on the whole, is good and can be trusted to guide the future civilization in a positive direction?
I think so. So I'm an optimist,
right? And there were some dark times in history, always. I think now we're in one of those dark times that you were doing, the polarization. And it's not just U.S., right? So if it was just U.S., I'd be like, yeah, it's a U.S. thing. But we're seeing it like worldwide polarization. And so I worry about that. But I do fundamentally believe that at the end of the day, people are right. And why do I say that? Because anytime there's a scenario where people are in danger, and I will use, so Atlanta, we had Snowmageddon, and people can laugh about that. People at the time, so the city closed for, little snow, but it was ice, and the city closed down. Have people opening up their homes and saying, hey, you have nowhere to go, come to my house, right? Hotels were just saying, like, sleep on the floor. Like, places like, the grocery stores were like, hey, here's food. There was no, like, oh, how much are you going to pay me? It was like this, such a community. And, like, people who didn't know each other, strangers were just like, going to give you a ride home. And that was a point I was like, you know what? Like,
that reveals that the deeper thing is there's a compassion, a love that we all have within. Just that when all that is taken care of, we don't get bored of drama.
yes.
And that's, I think, almost like the division is a sign of the times being good. Is that it's just entertaining on some unpleasant mammalian level to watch disagree with others. And Twitter and Facebook are actually taking advantage of that in a sense because it brings you back to the platform and they're advertiser driven, so they make a lot of money.
So you go back.
Because love doesn't sell quite as well in terms of advertising. So you've started your career at NASA Jet Propulsion Laboratory. But before I ask you a few questions there, have you happened to have ever seen Space Odyssey, 2001 Space Odyssey?
Yes.
Okay. Do you think HAL 9000, so we're talking about ethics, do you think HAL did the right thing by taking the priority of the mission over the lives of the astronauts? Do you think HAL is good or evil? Easy questions.
Yeah. How was misguided?
You're one of the people that would be in charge of an outcome like HAL.
Yes.
So how would you do better?
If you think about what happened was there was no fail-safe, right? So we think perfection, right? Like what is that? I'm going to make something that I think is perfect, but if my assumptions are wrong, it'll be perfect based on the wrong assumptions, right? That's something that you don't know until you deploy and then you're like, oh yeah, messed up. But what that means is that when we design software, such as in Space Odyssey, when we put things out, that there has to be a fail-safe. There has to be the ability that once it's out there, we can grade it as an F and it fails and it doesn't continue, right? There's some way that it can be brought in and removed and that's because that's what happened with HAL. It was like assumptions were wrong. It was correct based on those assumptions, and there was no way to change the assumptions at all.
And the change, the fallback would be to a human. You ultimately think like humans should be, it's not turtles or AI all the way down. It's at some point there's a human that
I
actually.
still think that, and again, because I do human robot interaction, I still think the human needs to be part of the equation at some point.
So what? Just looking back, what are some fascinating things in robotic space that NASA was working at the time, or just in general? What have you gotten to play with, and what are your memories from working at NASA?
Yeah, so one of my first memories was they were working on a surgical robot system that could do eye surgery, right? And this was back in, oh my gosh, it must have been, maybe 92, 93, 94.
Just like almost like a remote operation.
Yeah, it was remote operation, and in fact, you can even find some old tech reports on it. So think of it, like now we have Da Vinci, right? Like think of it, but these are like the late 90s, right? And I remember going into the lab one day, and I was like, "What's that?" Right? And of course, it wasn't pretty, right? Because the technology, but it was like functional, and you had this individual that could use a version of haptics to actually do the surgery, and they had this mock-up of a human face and like the eyeballs, and you could see this little drill, and I was like, oh, that is so cool. That one I vividly remember because it was so outside of my like possible thoughts of what could be done.
Just the kind of precision and the. I mean, what's the most amazing thing like that?
I think it was the precision. It was the kind of first time that I had physically seen this robot machine human interface, right? Versus because manufacturing with them saw those kind of big robots, right? But this was like, oh, this is in a person. There's a person and a robot, like in the same space.
And meeting them in person, like for me, it was a magical moment that I can't. It was life transforming that I recently had to spot maybe.
Oh,
I don't know why, but on the human robot interaction, for some reason, I realized how easy it is to anthropomorphize. And it was, I don't know, it was almost like falling in love with this feeling of meeting. And I've obviously seen these robots a lot on the video, but meeting in person, just having that one-on-one time, it's different. So have you had a robot like that in your life that was made you maybe fall in love with robotics? That about like meeting in person?
I love robotics. Yeah, so I was a 12-year-old, like I'm gonna be a roboticist. Actually, I called it cybernetics. But so my motivation was Bionic Woman. I don't know if you know that. And so, that was like a thing, but I didn't like that was TV, right? Like it wasn't like I was in the same space and I was like, oh my gosh, you're like real.
Just looking at Bionic Woman, by the way, because I read that about you. I watched a bits of it, and it's just so. Well, that's terrible.
It's cheesy.
It's cheesy.
Look at it now.
It's cheesy.
I've seen a couple of reruns lately.
But it's but of course at the time it was probably.
But the sound effects.
Especially when you're younger, it just got you. But which aspect did you think of it? You mentioned cybernetics. Did you think of it as robotics, or did you think of it as almost like constructing artificial beings? Is it the intelligent part that captured your fascination, or was it the whole thing, like even just the lens?
So for me, it would have, in another world, I probably would have been more of a biomedical engineer, because what fascinated me was the parts, like the bionic parts, the limbs, those aspects of it.
Are you especially drawn to humanoid or human-like robots?
I would say human-like, not humanoid, right? And when I say human-like, I think it's this aspect of that interaction. And it's social and it's like a dog, right? Like that's human-like because it understands us, it interacts with us at that very social level. Humanoids are part of that, but only if they interact with us as if we are human.
But just to linger on NASA for a little bit, what do you think, maybe if you have other memories, but also what do you think is the future of robots in space? You mentioned HAL, but there's incredible robots that NASA is working on in general, thinking about in our, as we venture out, human civilization ventures out into space. What do you think the future of robots is?
Yeah, so there's the near term. For example, they just announced the rover that's going to the moon, which that's kind of exciting, but that's like near term. My favorite series is Star Trek, right? I really hope, and even Star Trek, like if I calculate the years, I wouldn't be alive. But I would really, really love
to be in that world. Like even if it's just at the beginning, like like Voyage, like Adventure One.
So basically living in space.
Yeah.
With what robots? What are robots?
With Data.
What role?
The Data would have to be, even though that wasn't that was accurate.
So Data is a robot that has human-like qualities.
Right, without the emotion chip. Yeah.
You don't like emotion.
Well,
in
so
your
Data
robot.
with the emotion chip was kind of a mess, right? It took a while for that thing to adapt. But and so why was that an issue? The issue is that emotions make us irrational creatures. That's the problem. And yet he think through things, even if it was based on an emotional scenario, right? Based on pros and cons. But as soon as we made him emotional, one of the metrics he used for evaluation was his own emotion, not people around him, right? Like, and so
We do that as children, right? So we're very egocentric when
we are
we're young.
very egocentric.
And so isn't that just an early version of the emotion chip then? I haven't watched much Star Trek.
Except I have also met adults. Right, and so that is a developmental process, and I'm sure there's a bunch of psychologists that can go through. Like you can have a 60-year-old adult who has the emotional maturity of a 10-year-old, right? And so there's various phases that people should go through in order to evolve, and sometimes you don't.
So how much psychology do you think, a topic that's rarely mentioned in robotics, but how much does psychology come into play when you're talking about HRI, human robot interaction, when you have to have robots that actually interact with you?
Tons. So we, like my group, as well as I, read a lot in the cognitive science literature as well as the psychology literature, because they understand a lot about human-human relations and developmental milestones and things like that. And so we tend to look to see what's been done out there. Sometimes what we'll do is we'll try to match that to see, is that human-human relationship the same as human-robot? Sometimes it is, and sometimes it's different. And then when it's different, we try to figure out, okay, why is it different in this scenario, but it's the same in the other scenario, right? And so we try to do that quite a bit.
Would you say that's, if we're looking at the future of human robot interaction, would you say the psychology piece is the hardest? Like, if it's, I mean, it's a funny notion for you. I don't know if you consider, yeah. I mean, one way to ask it, do you consider yourself a roboticist or a psychologist?
Oh, I consider myself a roboticist that plays the act of a psychologist.
But if you were to look at yourself sort of, 20, 30 years from now, do you see yourself more and more wearing the psychology hat? So another way to put it is, are the hard problems in human robot interaction fundamentally psychology, or is it still robotics, like the perception, manipulation, planning, all that kind of stuff?
It's actually neither. The hardest part is the adaptation and the interaction. So
Learning.
it's the interface, it's the learning. And so if I think of, like, I've become much more of a roboticist / AI person than when like originally, again, I was about to be honest, I was electrical engineer, I was control theory, right? Like, and then I started realizing that my algorithms needed like human data, right? And so then I was like, okay, what is this human thing? Like, how do I incorporate human data? And then I realized that human perception had, that there was a lot in terms of how we perceive the world. And so trying to figure out, how do I model human perception for my, and so I became a HRI person, a robot interaction person, from being a control theory and realizing that humans actually offer quite a bit. And then when you do that, you become like more of an artificial intelligence, AI. And so I see myself evolving more in this AI world, under the lens of robotics having hardware interacting with people.
So you're a a world-class expert researcher in robotics, and yet others, there's a few. It's a small but fierce community of people, but most of them don't take the journey into the age of HRI to the human. So why did you brave into the interaction with humans? It seems like a really hard problem.
It's a hard problem and it's very risky as an academic. And I knew that when I started down that journey, that it was very risky as an academic. In this world that is nuanced, it was just developed. But we didn't even have a conference, right, at the time. Because it was the interesting problems. That was what drove me. It was the fact that I looked at what interests me in terms of the application space and the problems, and that pushed me into trying to figure out what people were and what humans were and how to adapt. If those problems weren't so interesting, I'd probably still be sending rovers to Goshen's, right? But the problems were interesting. And the other thing was that they were hard, right? So I like having to go into and being like, I don't know what to do. And then going back and saying, okay, I'm going to figure this out. I'm not driven when I go in like, oh, there are no surprises. Like, I don't find that satisfying. If that was the case, I'd go someplace and make a lot more money, right? I think I stay in academic because I choose to do this because I can go into a room and like, that's hard.
Yeah, I think just from my perspective, maybe you can correct me on it, but if I just look at the field of AI broadly, it seems that human-robot interaction has one of the most number of open problems. Like people, especially relative to how many people are willing to acknowledge that there are. It's because most people are just afraid of the humans, so they don't even acknowledge how many open problems are. But it's in terms of difficult problems to solve, exciting spaces, that seems to be incredible for that.
It is. It is exciting.
You mentioned trust before. What role does trust from interacting with autopilot to in the medical context? What role does trust play in human robot interaction?
So some of the things I study in this domain is not just trust, but it really is open trust.
How do you think about open trust? Like first of all, what is trust and what is open trust?
Basically, the way I look at it is trust is not what you click on a survey. Trust is about your behavior. So if you interact with the technology based on the decision or the actions of the technology, as if you trust that decision, then you're trusted, right? And I mean, even in my group, we've done surveys that, on the thing, do you trust robots? Of course not. Would you follow this robot in a burning building? Of course not, right? And then you look at their actions and you're like, clearly your behavior does not match what you think, right? Or what you think you would like to think, right? And so I'm really concerned about the behavior because that's really, at the end of the day, when you're in the world, that's what will impact others around you. It's not whether before you went out to the street, you clicked on, like, I don't trust self-driving cars.
Yeah, that from an outsider perspective, it's always frustrating to me. Well, I read a lot, so I'm inside on certain philosophical sense. It's frustrating to me how often trust is used in surveys and how people make claims of any kind of finding they make while somebody clicking an answer. Because trust is behavior. Just you said it beautiful. I mean, the action, your own behavior is what trust is. I mean, that everything else is not even close. It's almost like an absurd comedic poetry that you weave around your actual behavior. So some people can say they trust. I trust my wife, husband, or not, whatever. But the actions is what speaks louder.
Like your car,
Yeah.
you probably don't trust it.
I trust them. I'm just making sure. No, that's yeah.
Like even if you think about cars, I think it's a beautiful case. I came here at some point, sure, on right. I remember when it first came out. I bet
bet if they had a survey, would you get in the car with a stranger and pay them? How many people do you think would have said, like, really? Wait, even worse, would you get in the car with a stranger at 1 a.m. in the morning to have them drop you home as a single female? Like, how many people would say, that's stupid? Yeah. And now look at where we are. I mean, people put kids, like, right? Like, oh yeah, my child has to go to school, and I'm gonna put my kid in this car with a stranger. I mean, it's just fascinating how, like, what we think is not necessarily matching behavior.
Yeah, certain robots, autonomous vehicles, and all the types of robots you work with. It's the way you answer it, especially if you've never interacted with that robot before. If you haven't had the experience, you being able to respond correctly on the survey is impossible. But what role does trust play in the interaction? Do you think? Like, is it good to trust a robot? What does over trust mean? Is it good kind of how you feel about autopilot currently, which is like, from a robotic's perspective, is like, you're still very cautious.
Yeah, so this is still an open area of research. But basically, what I would like in a perfect world is that people trust the technology when it's working 100%, and people will be hypersensitive and identify when it's not. But of course, we're not there. That's the ideal world. And what we find is that people swing, right? They tend to swing, which means that if my first, and like we as a bakers, like first impressions is everything, right? If my first instance with technology, with robotics, is positive, it mitigates any risk. It correlates with like best outcomes. It means that I'm more likely to either not see it when it makes mistakes or faults, or I'm more likely to forgive it. And so this is a problem because technology is not 100%. It's not 100% accurate, although I need to put it.
How do you get that first moment right, do you think? There's also an education about the capabilities and limitations of the system. Do you have a sense of how you educate people correctly in that first interaction?
Again, this is an open-ended problem. So one of the study that actually has given me some hope that I'm trying to figure out how to put in robotics. So there was a research study that showed for medical AI systems giving information to radiologists about you need to look at these areas on the X-ray. What they found was that when the system provided one choice, there was this aspect of either no trust or over trust, right? Like I don't believe it at all, or a yes, 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 and they would miss things, right? Instead, when the system gave them multiple choices, like here are the three, even if it knew, like, it had estimated that the top area you need to look at was, some place on the X-ray. If it gave like one plus others, the trust was maintained and the accuracy of the entire population increased. Right? So basically, it was you're still trusting the system, but you're also putting in a little bit of like your human expertise, like your human decision processing into the equation. So it helps to mitigate that over trust risk.
Yeah, so it's a fascinating balance that strike.
I haven't figured out again.
Right, it's exciting open area research. Exactly. So, what are some exciting applications of human robot interaction? You started a company, maybe you can talk about the exciting efforts there, but in general, also, what other space can robots interact with humans and help?
Yeah, so besides healthcare, because that's my bias lens, my other bias lens is education. I think that, well, one, we definitely, in the US, we're doing okay with teachers, but
There's a lot of school districts that don't have enough teachers. If you think about the teacher student ratio for at least public education, in some districts it's crazy. It's like, how can you have learning in that classroom, right? Because you just don't have the human capital. And so if you think about robotics, bringing that in to classrooms as well as the after school space where they offset some of this lack of resources in certain communities, I think that's a good place. And then turning on the other end is using these systems then for workforce retraining and dealing with some of the things that are going to come out later on of job loss, like thinking about robots and then AI systems for retraining and workforce development. I think that's exciting areas that can be pushed even more, and it would have a huge, huge impact.
What would you say are some of the open problems in education, sort of, exciting young kids and the older folks or just folks of all ages who need to be retrained, who need to sort of open themselves up to a whole other area of work? What are the problems to be solved there? How do you think robots can help?
We have the engagement aspect, right? So we can figure out the engagement. That's not a
What do you mean by engagement?
So identifying whether a person is focused is like that we can figure out. What we can figure out, and there's some positive results in this, is that personalized adaptation based on any concepts, right? So imagine I think about I have an agent and I'm working with a kid learning, I don't know, algebra 2. Can that same agent then switch and teach some type of new coding skill to a displaced mechanic? Like, what does that actually look like, right? Like, hardware might be the same, content is different, two different target demographics of engagement. Like, how do you do that?
How important do you think personalization is in human robot interaction? And not just mechanic or student, but like literally to the individual human being.
I think personalization is really important, but a caveat is that I think we could be okay if we can personalize to the group, right? And so if I can label you as along some certain dimensions, then even though it may not be you specifically, I can put you in this group. So the sample size, this is how they best learn, this is how they best engage. Even at that level, it's really important. And it's because, I mean, it's one of the reasons why educating in large classrooms is so hard, right? You teach to medium, but there's these individuals that are struggling, and then you have highly intelligent individuals, and those are the ones that are usually kind of left out. So highly intelligent individuals may be disruptive, and those who are struggling might be disruptive because they're both bored.
And if you narrow the definition of the group or the size of the group enough, you'll be able to address their individual.
Yes.
It's not individual needs, but really
Group needs.
group, most important group needs.
Right.
Right. That's kind of what a lot of successful recommender systems do, Spotify and so on. So it's sad to believe, but I'm a music listener probably some sort of Spotify. It's very sadly predictable.
You have been labeled.
Yeah, I've been labeled and successfully so. Because they're able to recommend stuff there.
Yeah, but applying that to education, right? There's no reason why it can't be done.
Do you have a hope for our education system?
I have more hope for workforce development. And that's because I'm seeing investments. Even if you look at VC investments in education, the majority of it has lately been going to workforce retraining, right? And so I think that government investment is increasing. There's like a claim, and some of it's based on fear, right? Like AI is going to come and take over all these jobs. What are we going to do with all these non-paying taxes that are coming to us by our citizens? And so I think I'm more hopeful for that. Not so hopeful for early education because it's this. It's still a who's going to pay for it, and you don't see the results for like 16 to 18 years. It's hard for people to wrap their heads around that.
But on the retraining part, what are your thoughts if the candidate Andrew Yang running for president was saying that AI, automation, robots,
Universal basic income.
universal basic income in order to support us as the kind of automation takes people's jobs and allows you to explore and find other routes. Like, do you have a concern of the society transforming effects of automation or robots and so on?
I do. I do know that AI, robotics will displace workers. Like, we do know that. But there'll be other workers that will be defined new jobs. What I worry about is that's not what I worry about. Like, will all the jobs go away? What I worry about is the type of jobs that will come out, right? Like, people who graduate from Georgia Tech will be okay, right? We give them the skills, they will adapt even if the current job goes away. I do worry about those that don't have that quality of an education. Like, will they have the ability, the background to adapt to those new jobs? That I don't know. That I worry about, which will create even more polarization in our society, internationally. And I worry about that. I also worry about not having equal access to all these wonderful things that AI can do and robotics can do. I worry about that. People like me from Georgia Tech, from say, MIT, will be okay, right? But that's such a small part of the population that we need to think much more globally of having access to these beautiful things, whether it's AI in healthcare, AI in education, AI in politics, right? I worry about that.
And that's part of the thing that you were talking about is people that build the technology have to be thinking about ethics, have to be thinking about access, and all those things, not just a small subset. Let me ask some philosophical, slightly romantic questions. I'll listen to this. Like, here she goes again. Okay. Do you think one day we'll build an AI system that a person can fall in love with and it would love them back? Like in the movie Her, for example.
Yeah. Although she kind of didn't fall in love with him. Or she fell in love with like a million other people. Something like that. So
You're the jealous type.
So,
we humans are the jealous
yes.
type.
So I do believe that we can design systems where people would fall in love with their robot, with their AI partner. That I do believe. Because it's actually, I don't like to use the word manipulate, but as we see, there are certain individuals that can be manipulated if you understand the cognitive science about it, right?
Right. So, I mean, if you could think of all close relationship and love in general as a kind of mutual manipulation. That dance, the human dance, maybe there's a negative connotation.
And that's why I don't like to use that word particularly.
I guess another way to phrase it is you're getting at is it could be algorithmatized or something. It could be
the relationship building part of it.
Yeah.
I mean, just think about it. We have, and I don't use dating sites, but from what I heard, there are some individuals that have been dating that have never saw each other, right? In fact, there's a show I think that tries to like weed out fake people. Like there's a show that comes out, right? Because people start faking. Like, what's the difference of that person on the other end being an AI agent, right? And having a communication and you building a relationship remotely. Like there's no reason why that can't happen.
in terms of human robot interaction. So, what role you've kind of mentioned with data, emotion can be problematic if not implemented well, I suppose. What role does emotion and some other human-like things, the imperfect things, come into play here for good human-robot interaction and something like love?
Yeah, so in this case, and you had asked, can an AI agent love a human back?
I think they can emulate love back, right? And so, what does that actually mean? It just means that if you think about their programming, they might put the other person's needs in front of theirs in certain situations, right? Think about it as return on investment. Like, what's my return on investment? As part of that equation, that person's happiness, has some type of, algorithm weighted to it. And the reason why is because I care about them, right? That's the only reason, right? Uh, but if I care about them and I show that, then my final objective function is length of time of the engagement, right? So you can think of how to do this. Actually, perfect. And so,
But that's not love.
well, so that's the thing. I think it emulates love because we don't have a classical definition of love.
Right. But and we don't have the ability to look into each other's minds to see the algorithm. And I guess what I'm getting at is it possible that, especially if that's learned, especially if there's some mystery and black box nature to the system, how is that,
How is it any different?
how is it any different in terms of sort of if the system says, I'm conscious, I'm afraid of death, and it does indicate that it loves you. Another way to sort of phrase that, I'd be curious to see what you think. Do you think there'll be a time when robots should have rights? You've kind of phrased the robot in a very roboticist way. It's just a really good way of saying, okay, well, there's an objective function, and I can see how you can create a compelling human-robot interaction experience that makes you believe that the robot cares for your needs and even something that loves you. But what if the robot says, please don't turn me off? What if the robot starts making you feel like there's an entity, a being, a soul there, right? Do you think there'll be a future? Hopefully, you won't laugh too much at this, but then where they do ask for rights.
So I can see a future if we don't address it in the near term, where these agents, as they adapt and learn, could say, hey, this should be something that's fundamental. I hopefully think that we would address it before it gets to that point.
You think so? That you think that's a bad future? Is like what is that a negative thing where they ask for being discriminated against?
I guess it depends on what role have they attained at that point, right? And so if I think about now,
Careful what you say because the robots will be listening to this, and you'll be on TV saying this is what roboticists used to believe.
right? And so, well, this is and as I said, I have a biased lens, and my robot friend will understand this. But so if you think about it, and I actually put this in kind of as a roboticist, you don't necessarily think of robots as human with human rights, but you could think of them either in the category of property, or you could think of them in the category of animals, right? And so both of those have different types of rights. So animals have their own rights as a living being, but they can't vote, they can't, right? They can be euthanized, but as humans, if we abuse them, we go to jail, like, right? So they do have some rights that protect them, but don't give them the rights of like citizenship. And then you think about property, the rights are associated with the person, right? So if someone vandalizes your property or steals your property, like there are some rights that is associated with the person who owns that. If you think about it, back in the day, and if you remember, we talked about how society has changed. Women were property, right? They were not thought of as having rights. They were thought of as property of, like their.
Yeah, assaulting a woman, that's assaulting the property of somebody else.
Exactly. And so what I envision is that we will establish some type of norm at some point, but that it might evolve, right? Like if you look at women's rights now, like there are still some countries that don't have, but then the rest of the world is like, why? That makes no sense, right? And so I do see a world where we do establish some type of grounding. It might be based on property rights, it might be based on animal rights. And if it evolves that way, I think we will have this conversation at that time because that's the way our society traditionally has evolved.
Beautifully put. Just out of curiosity, Enki, Jibo, Mayfield Robotics, with the robot curious, how it works. We think robotics, we're all these amazing robotics companies that created by incredible roboticists, and they all went out of business recently. Why do you think they didn't last long? Why is it so hard to run a robotics company, especially one like these, which are fundamentally HRI, human reliant interaction robots?
Yeah.
Or personal robots.
Each one has a story. Only one of them I don't understand. And that's actually the only one
I don't understand either. So.
And I mean, I look at like from the outside, I've looked at their sheets, I've looked at like the data that's.
Oh, you mean like business wise?
Yeah.
I understand. Gotcha.
Yeah. And like, I look at that data and I'm like, they seem to have like product market fit. Like, so that's the only one I don't understand. The rest of it was product market fit.
What's product market fit? Just like how do you think about it?
Yeah. So although we think robotics was getting there, right? But I think it's just the timing. It just their clock just timed out. I think if they had been given a couple more years, they would have been okay. But the other ones were still fairly early by the time they got into the market. And so product market fit is I have a product that I want to sell at a certain price. Are there enough people out there, the market, that are willing to buy the product at that market price for me to be a functional, viable, or profit-bearing company, right? So profit market fit. If it costs you $1,000 and everyone wants it and only is willing to pay $1, you have no product market fit. Even if you could sell it for no, it's enough for $1.
So how hard is it for robots? So maybe if you look at iRobot, the company that makes robots back in the days, can you comment on did they find the right product? Market fit? Like, are people willing to pay for robots? Is also another kind of question.
So if you think about iRobot and their story, right? Like when they first, they had enough of a runway, right? When they first started, they weren't doing vacuum cleaners, right? They were contracts, primarily government contracts, designing
robots.
Yeah, I mean that's what they were. That's how they started, right? And
they still do a lot of incredible work there. But yeah, that was the initial thing that gave them a lot of funding
to then try to a vacuum cleaner. What I've been told was not like their first rendezvous in terms of designing a product, right? And so they were able to survive until they got to the point that they found a product price market, right? And even if you look at the Roomba, the price point now is different than when it was first released, right? It was an early adopter price, but they found enough people who were willing to fund it. And I mean, I forgot what their loss profile was for the years, but they became profitable in sufficient time that they didn't have to post those.
So they found the right. There's still people willing to pay a large amount of money for over $1,000 for a vacuum cleaner. Unfortunately for them, now that they've proved everything out, figured it all out, now there's
so, yeah, and so that's the next thing, right? The competition, and they have quite a number even internationally. Like there's some products out there you can go to Europe and be like, oh, I didn't even know this one existed. So this is the thing though, like with any market, I would. This is not a bad time, although as a roboticist it's kind of depressing. But I actually think about things like with I would say that all the companies that are now in the top 5 or 6, they weren't the first to the stage, right? Like Google was not the first search engine. Sorry, all this, right? Facebook was not the first. Sorry, MySpace. Right? Like think about it. They were not the first players. Those first players, like they're not in the top 5, 10 of Fortune 500 companies, right? They proved they started to prove out the market. They started to get people interested. They started the buzz, but they didn't make it to that next level. But the second batch, right? The second batch, I think, might make it to the next level.
When do you think the Facebook
The Facebook of robotics.
sorry, I take that phrase back because people deeply, for some reason, well, I know why, but I think exaggerated, distrust Facebook because of the privacy concerns and so on. And with robotics, one of the things you have to make sure is all the things we talked about is to be transparent and have people deeply trust you to let a robot into their lives, into their home. What do you think the second batch of robots will be? Is it 5, 10 years, 20 years that we'll have robots in our homes and robots in our hearts?
So if I think about, because I try to follow the VC kind of space in terms of robot investments, and right now, and I don't know if they're going to be successful. I don't know if this is the second batch, but there's only one batch that's focused on like the first batch, right? And then there's all these self-driving X, right? And so I don't know if they're a first batch of something or if, like, I don't know quite where they fit in, but there's a number of companies, the co-robot, I call them co-robots, that are still getting VC investments. Some of them have some of the flavor of like Rethink Robotics, some of them have some of the flavor like Curie.
What's a co-robot?
So basically a robot and human working in the same space. So some of the companies are focused on manufacturing. So having a robot and human working together in a factory. Some of these co-robots are robots and humans working in the home, working in clinics. Like there's different versions of these companies in terms of their products, but they're all, so we think robotics would be like one of the first well-known companies focused on this space. So I don't know if this is a second batch or if this is still part of the first batch. That I don't know. And then you have all these other companies in this self-driving space. And I don't know if that's a first batch or again a second batch.
So there's a lot of mystery about this now. Of course, it's hard to say that this is the second batch until it, proves out, right?
Correct.
Yeah, exactly.
Yeah, we need a unicorn.
Yeah, exactly. Why do you think people are so afraid, at least in popular culture, of living robots like those who work in Boston Dynamics, or just robotics in general? If you were to psychoanalyze that fear, what do you make of it? And should they be afraid? Sorry.
So should people be afraid? I don't think people should be. But with a caveat. I don't think people should be afraid, given that most of us in this world understand that we need to change something, right? So given that. Now, if things don't change, be very afraid.
Which is the dimension of change that's needed?
So thinking about the ramifications, thinking about like the ethics, thinking about like the conversation is going on, right? It's no longer we're going to deploy it and forget that, this is a car that can kill pedestrians that are walking across the street, right? We're not in that stage. We're putting these roads out. There are people out there. The car could be a weapon. Like, people are now, solutions aren't there yet, but people are thinking about this as we need to be ethically responsible as we send these systems out, robotics, medical, self-driving.
And military, too.
And military.
It's not as often talked about, but it's really more probably these robots will have a significant impact as well.
Correct. Right, making sure that they can think rationally, even having the conversations, who should pull the trigger, right?
But overall, you're saying if we start to think more and more as a community about these ethical issues, people should not be afraid.
Yeah, I don't think people should be afraid. I think that the return on investment, the positive impact will outweigh any of the potentially negative impacts.
Do you have worries of existential threats of robots or AI that some people kind of talk about and romanticize about in the next decade, next few decades?
No, I don't. Singularity would be an example. So my concept is that, so remember, robots, AI, is designed by people. It has our values. And I always correlate this with a parent and a child. Right? So think about it. As a parent, what we want our kids to have a better life than us. We want them to expand. We want them to experience the world. And then as we grow older, our kids think and know they're smarter and better and more intelligent and have better opportunities, and they may even stop listening to us. They don't go out and then kill us, right? Like, think about it. It's because it's instilled in them values, instilled in them this whole aspect of community. And yes, even though you're maybe smarter and have more money, it's still about this love, caring relationship. And so that's what I do. So even if, like, we've created the singularity in some archaic system back in like 1980 that suddenly evolved, the fact is it might say, I am smarter, I am sentient. These humans are really stupid. But I think it'll be like, yeah, but I just can't destroy them.
Yeah, for sentimental value. It's still just to come back for Thanksgiving dinner every once in a while.
Exactly.
That's so beautifully put. You've also said that The Matrix may be one of your more favorite AI related movies. Can you elaborate why?
Yeah, it is one of my favorite movies. And it's because it represents kind of all the things I think about. So there's this symbiotic relationship between robots and humans, right? That symbiotic relationship is that they don't destroy us, they enslave us, right? But think about it. Even though they enslaved us, they needed us to be happy, right? And in order to be happy, they had to create this pretty world that they then had to live in, right?
Right.
That's the whole thing.
Yeah.
But then there were humans that had a choice, right? Like, you had a choice to stay in this horrific world where it was your fantasy life with all of the anomalies, perfection but not accurate. Or you can choose to be on your own and, like, have maybe no food for a couple of days, but you were totally autonomous. And so I think of that as, and that's why. So it's not necessarily us being enslaved, but I think about us having this symbiotic relationship. Robots and AIs, even if they become sentient, they're still part of our society, and they will suffer just as much as we.
And there will be some kind of equilibrium that we'll have to find, some sort of symbiotic relationship.
And then you have the ethicists, the robotics folks, that are like, no, this has got to stop. I will take the other pill in order to make a difference.
So if you could hang out for a day with a robot, real or from science fiction, movies, books, safely, and get to pick his or her, their brain, who would you pick?
I gotta say it's Dana.
Data.
I was gonna say Rosie, but I'm not really interested in her brain. I'm interested in Data's brain.
Data pre or post emotion chip?
Pre.
But don't you think it'd be a more interesting conversation with post emotion chip?
Yeah, it would be drama. And I'm human. I deal with drama all the time.
Yeah.
But the reason why I want to pick Data's brain is because I could have a conversation with him and ask, for example, how can we fix this ethics problem, right? And he could go through like the rational thinking, and through that, he could also help me think through it as well. And so there's like these questions, fundamental questions I think I could ask him that he would help me also learn from, and that fascinates me.
I don't think there's a better place to end it. Thank you so much for talking. It was an honor.
Thank you. This was fun.
Thanks for listening to this conversation. Thank you to our presenting sponsor, Cash App. Download it. Use code Lex Podcast. $10. $10 will go to first STEM education nonprofit that inspires hundreds of thousands of young minds to become future leaders and innovators. If you enjoy this podcast, subscribe on YouTube, give 5 stars on Apple Podcasts, follow on Spotify, support on Patreon, or simply connect with me on Twitter. And now, let me leave you with some words of wisdom from Arthur C. Clarke. Whether we are based on carbon or on silicon makes no fundamental difference. We should each be treated with appropriate respect. Thank you for listening. I hope to see you next time. The following is a conversation with Paul Krugman, Nobel Prize winner in economics, a CUNY, a columnist at the New York Times. His academic work centers around international economics, economic geography, liquidity traps, and currency crises. But he also is an outspoken writer and commentator on the intersection of modern-day politics and economics, which places him in the middle of the tense, divisive, modern-day political discourse. If you have clicked dislike on this video and started writing a comment of derision before listening to the conversation, I humbly ask that you please unsubscribe from this channel within this podcast. Not because you're conservative, a libertarian, a liberal, a socialist, an anarchist, but because you're not open to new ideas, at least in this case, especially as it's most difficult, from people with whom you largely disagree. I do my best to stay away from politics today, because political discourse is filled with a degree of emotion and self-assured certainty that to me is not conducive to exploring questions that nobody knows a definitive right answer to. The role of government, the impact of automation, the regulation of tech, the medical system, guns, war, trade, foreign policy are not easy topics and have no clear answers, despite the certainty of the so-called experts, the pundits, the trolls, the media personalities, and the conspiracy theorists. Please listen, empathize, and allow yourself to explore ideas with curiosity, but without judgment, but without derision. I will speak with many more economists and political thinkers, trying to stay away from the political battles of the day and instead look at the long arc of history and lessons it reveals. In this, I appreciate your patience and support. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, rate 5 stars on Apple Podcasts, follow on Spotify, support it on Patreon, or simply connect with me on Twitter at Lex Friedman, spelled F-R-I-D-M-A-N. I recently started doing ads at the end of the introduction. I'll do 1 or 2 minutes after introducing the episode, and never any ads in the middle that can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. This show is presented by Cash App, the #1 finance app in the App Store. Cash App lets you send money to friends, buy Bitcoin, and invest in the stock market with fractional share trading, allowing you to buy $1 worth of the stock no matter what the stock price is. Brokerage services are provided by Cash App Investing, a subsidiary of Square and member SIPC. Get Cash App in the App Store and Google Play and use the code LEXPODCAST. You'll get $10. Cash App will also donate $10 to FIRST, one of my favorite organizations that is helping to advance robotics and STEM education for young people around the world. Since Cash App does fractional share trading, let me say that to me, it's a fascinating concept. The order execution algorithm that works behind the scenes to create the abstraction of fractional orders for the investor is an algorithmic marvel. So big props to the Cash App engineers for that. I like it when tech teams solve complicated problems to provide, in the end, a simple, effortless interface that abstracts away all the details of the underlying algorithm. And now, here's my conversation with Paul Krugman. What does a perfect world, a utopia, from an economics perspective look like?
Well, I don't believe in perfection.
somebody once said that this idea was slightly imaginary Sweden. I like an economy that has a really high safety net for people with environmental regulation and not something that's kind of like some of the better run countries in the world, but with fixing all of the smaller things that are wrong with wealth distribution. Well, obviously, total equality is neither possible nor I think especially desirable. But I think you want one where nobody's hurting, and where everybody lives in the same material universe. Everybody is basically living in the same society. So no, I think it's a bad thing to have people who are so wealthy that they're really not in the same world as the rest of us.
What about competition? Do you see the value of competition? And what maybe it's
Oh, competition is great when it can work. I mean, I remember, I'm old enough to remember when there was only one phone company and there was really limited choice. And I think the arrival of multiple phone carriers and all that is actually, I think that's been a really good thing. And that's true across many areas, but not every activity is suitable for competition. So there are some things like healthcare where competition actually doesn't work, and so it's not one size fits all.
It's interesting. Why does competition not work in healthcare?
Oh, there's a long list. There's a famous paper by Kenneth Arrow from 1963. It still holds up very well, where it kind of runs down the list of things you need for competition to work well. Basically, both sides of every transaction being well informed, having the ability to make intelligent decisions, understanding what's going on, and healthcare fails on every dimension.
Healthcare, so not health insurance. Healthcare.
Well, both healthcare and health insurance. Health insurance being part of it, but no, health insurance is really the idea that there's effective competition between health insurers as well as healthcare. I mean, the idea that you can comparison shop for major surgeries is just when people say things like that, you wonder, are you living in the same world I'm living in?
That the piece of well informed, that was always an interesting piece for me, just observing as an outsider. There's so much such a beautiful world as possible if everybody's well informed. My question for you is, how hard is it to be well informed about anything, whether it's healthcare or any kind of purchasing decisions or just life in general in this world?
Oh, information. In theory, there's more information at your fingertips than ever before in history. The trouble is, first of all, that some of that information isn't true, so it's really hard, and then some of it is just too hard to understand. So if I'm buying a car, I can actually probably do a pretty good job of looking up, going into some reports, reviews. You get a pretty good idea of what you're getting when you get a car. If I'm going in for surgery, first of all, fairly often it happens without your being able to plan it, but also there's medical school takes many years, and going on the internet for some advice is not usually a very good substitute.
So, speaking about news and not being able to trust certain sources of information, how much disagreement is there about, I mentioned utopia, perfection in the beginning, but how much disagreement is there about what utopia looks like? Or is most of the disagreement simply about the path to get there?
Oh, I think there's two levels of disagreement. One, and maybe not utopia, but justice. What is a just society? And there are different views. And I teach my students that there are, broadly speaking, two views of justice. One focuses on outcomes. You ask a just society is the one you would choose if you were trying to the one that you would choose to live in if you didn't know who you were going to be, John Rawls. The other focuses on process. That just society is one in which there is no coercion except where absolutely necessary. And there's no objective way to choose between those. I'm pretty much a Rawlsian, and I think many people are. Anyway, there's a legitimate dispute about what we mean by a just society. Anyway, but then there's also a lot of dispute about what actually works. There's a range of legitimate dispute. I mean, any card-carrying economist will say that incentives matter, but how much do they matter? How much does a higher tax rate actually deter people from working? How much does a stronger safety net actually lead people to get lazy? I have a pretty strong view that the evidence is it points to conclusions that are considerably to the left of where most of our politicians are, but that there is legitimate room for dispute about those things.
So you mentioned outcomes. What are some metrics you think about that you keep in mind, like the Gini coefficient, but really anything that measures how good we're doing, whatever we're trying to do? What are the metrics you keep an eye on?
Well, I'm actually I'm not a fan of the Gini coefficient, not because
What is the Gini coefficient?
Yeah, the Gini coefficient is a measure of inequality, and it is commonly used as a single number. It usually tracks with other measures, but the trouble is there's no sort of natural interpretation of it. If you ask me what does a society with a Gini of 0.45 look like as opposed to a society with a Gini of 0.25, and well, I can kind of tell you, that 0.25 is Denmark and 0.45 is Brazil, but there's no sort of easy way to do that mapping. I mean, I look at things like first of all, things like what is the income of the median family, what is the income of the top 1%, how many people are in poverty by various measures of poverty. And then I think that you want to look at questions like how healthy are people, how is life expectancy doing, and how satisfied are people with their lives? Because that sounds like a squishy number. Not so much happiness. It turns out that life satisfaction is a better measure of happiness. But life satisfaction, that varies quite a lot. I think it's meaningful, if not too rigorous, to say, look, according to polling, people in Denmark are pretty satisfied with their lives, and people in the United States not so much so.
And of course, Sweden wins every time.
No, actually, Denmark wins in general. Denmark and Norway win. So Sweden doesn't do that. It's none of these are perfect, but look, I think by and large, there's a bit of a pornography test. If you, how do you know a decent society? Well, you kind of know it when you see it.
Where's America stand on that?
We have our society. There are a lot of virtues to America, but there's a level of harshness, brutality, an ability for somebody who just has bad luck to fall off the edge that is really shouldn't be happening in a country as rich as ours. So we have somehow managed to produce a crueler society than almost any other wealthy country for no good reason.
What do you think is lacking in the safety net that the United States provides? You said there's a harshness to it. And what are the benefits and limits of a safety net in a country like ours?
Well, every other advanced country has some universal guarantee of adequate health care. I think the United States is the only place where citizens can actually fail to get basic health care because they can't afford it. That's weak. It's not hard to do. Everybody else does it, but we don't. We've gotten a little bit better at it than we were, but still, that's a big deal. We have remarkably weak support for children. I mean, most countries have substantial safety. Parents of young children get much more support elsewhere. They get often nothing in the U.S. We have limited care for people. Long-term care for the elderly is a very hit and miss thing. But I think that the really big issues are that we don't take care of children who make the mistake of having wrong parents, and we don't take care of people who make the mistake of getting sick. And those are things that a rich country should be doing.
Sorry for sort of a difficult question, but what you just said kind of feels like the right thing to do in terms of a just society. But is it also good for the economic health of society to take care of the people who are the unfortunate members of society?
By and large, it looks like the doing the right thing in terms of justice is also the right thing in terms of economics. If we're talking about a society that has extremely high tax rates to remove all incentives to provide a safety net that is so generous that why bother working or striving, that could be a problem. But I don't actually know any society that looks like that. Even in European countries with very generous safety nets, people work and innovate and do all of these things. And there's a lot of evidence that lacking those basics is actually destructive. Children who grow up without adequate health care, without adequate nutrition, are developmentally challenged. They don't live up to their potential as adults. So the United States actually probably pays a price. We're harsh, we're cruel, and we actually make ourselves poorer by as a society, not just the individuals, by being so harsh and cruel.
Okay, so invisible hand, Smith. Where does that fit in? The power of just people acting selfishly and somehow everything taking care of itself to where, the economy grows, there's no cruelty, no injustice, that the markets themselves regulate themselves. What is there power to that idea? What are
There's a lot of power to that. There's a reason why I don't think sensible people want the government running steel mills or they want the government to own the farms, right? The markets are a pretty effective way of getting incentives aligned and inducing people to do stuff that works in the invisible hand. Saying that farmers aren't growing crops because they want to feed people. They're growing crops because they can make money by it. But it actually turns out they have a pretty good way of getting agricultural products grown. So the invisible hand is a quick part, but it's not. There's nothing mystical about it. It's a mechanism. It's a way to organize economic activity, which works well given a bunch of preconditions, which means that it actually works well for agriculture. It works well for manufacturing. It works well for many services. It doesn't work well for healthcare. It doesn't work well for education. So having a society which is kind of 3/4 invisible hand and 1/4 visible hand seems to be something on that order seems to be the balance that works best. It's just you don't want to romanticize or make something mystical out of it. It's just this is one way to organize stuff that happens to have broad but not universal application.
So then forgive me for romanticizing, but it does seem pretty magical that I kind of have an intuitive understanding of what happens when you have like 5, 10, maybe even 100 people together, the dynamics of that. The fact that these large society of people, for the most part, acting in a self-interested way, and maybe electing representatives for themselves, that it all kind of seems to work. It's pretty magical.
The fact that there's right now there's a wide assortment of fresh fruit and vegetables in the local markets up and down the street. Who's planning that? And the answer is nobody. That's the invisible hand at work, and that's great. And that's a lesson that Adam Smith figured out more than 200 years ago, and it continues to apply. And but yeah, even Adam Smith has a section in his book about why it's important to regulate banks. So the invisible hand has its limits.
Yeah, and that example is actually a powerful one in terms of the supermarket and food. That was my experience coming from Russia, from the Soviet Union. It is when I first entered the supermarket and just seeing the assortment of fruit, bananas. Yeah, I don't think I've seen bananas before, first of all, but just the selection of fresh fruit was mind blowing. Beyond words, and the fact that, like you said, I don't know what made that happen.
Well, there is some magic to the market, but showing my age, but the old movie quote, sometimes the magic works and sometimes it doesn't. You have to have some idea of when it doesn't.
So how do you get regulation there? What can government best do? Government, strangely enough, in this country today, seems to get a bad rap. Like everyone seems to, everybody's against the government.
Yeah. Well, a lot of money isn't spent on making people hate government. But the reality is, government does some things pretty well. I mean, government does health insurance pretty well. So much so, given our anti-government bias, it really is true that there are people out there saying, "Don't let the government get its hands on Medicare." Right? So government people actually love the government health insurance program far more than they love private health insurance. Basic education. It turns out that your local public high school is the right place to have students trained, and private certainly for-profit education is by and large a nightmare of rip-offs and grift and people not getting what they thought they were paying for. It's judgment games, and it's funny. There are things everybody talks about the DMV being how do you want the economy? And actually, my experiences with the DMV have always been positive. Maybe I'm just going to the right DMVs, but in fact, that allow government pretty well. So you have to some extent, you can do these things on a priori grounds. You can talk about the logic of why healthcare is not going to be handled well by the market, but part of this is experience. We tried, or at least some countries have tried nationalizing their steel industry. That didn't go well. But we've tried privatizing education, and that didn't go well. So you find out what works.
What about this new world of tech? How do you see? What do you think works for tech? Is there more regulation or less regulation?
There are some things that need more regulation. We're finding out that social media is one in which competitive forces aren't working very well, and trusting the companies to regulate themselves isn't working very well. But I'm on the whole a tech skeptic, not in the sense that I think the tech doesn't work, it doesn't do stuff, but the idea that we're living through greater technological change than ever before is really an illusion. Ever since the beginning of the Industrial Revolution, we've had a series of ethical shifts in the nature of work, in the kinds of jobs that are available, and it's not at all clear that what's happening now is any bigger or faster or harder to cope with than past shocks.
It is a popular notion in today's sort of public discourse that automation is going to have a huge impact on the job market. Now, there is something transformational happening now. Can you talk about that? Maybe elaborate a little bit more. Do you not see the software revolutions happening now with machine learning, availability of data, that kind of automation, being able to sort of process, clean, find patterns in data, and you don't see that disrupting any one sector to a point where there's a huge loss of job?
There may be some things. I mean, actually, translators, there's really reduced demand for translators because machine translation ain't perfect, but it ain't bad. There are some kinds of things that are changed, but it's not all the productivity growth has actually been slow in recent years. It's been much slower than in some past periods. So the idea that automation is taking away all the jobs, the counterpart would be that we would be able to produce stuff with many fewer workers than before, and that's not happening. There are a few isolated sectors. There are some kinds of jobs that are going away, but that keeps on happening. New York City used to have thousands and thousands of longshoremen taking stuff off ships and putting them on ships. They're almost all gone now. Now you have the giant cranes taking containers on and off ships in Elizabeth, New Jersey. That's not robots. It doesn't sound high tech, but it actually pretty much destroyed an occupation. Well, it wasn't fun for the longshoremen, to say the least. But it's not. We coped, we moved on, and that sort of thing happens all the time. Farmers, we used to be a nation with mostly farmers. There are now very few farmers left. The end reason is not that we stopped eating; it's that farming has become so efficient that we don't need a lot of farmers, and cope with that too. So the idea that there's something qualitatively different about what's happening now, so far, isn't true.
So your intuition is there is going to be loss of jobs, but it's just a thing that just continues. So there's nothing qualitatively different about this one.
Some jobs will be lost, others will be created, as has always been the case so far. Maybe there's a singularity. Maybe there's a moment when machines get smarter than we are, and it's trying to kill us all or something, right? But that's not visible in anything we're seeing now.
You mentioned metric of productivity. Could you explain that a little bit? Because I've heard you mention that before, the connection with automation. So what is that metric, and if there is something qualitatively different, what should we see in that metric?
Well, okay, productivity. First of all, production. We do have a measure of the economy's total production, real GDP, which is it's a little bit of a construct because it's quite literally it's adding apples and oranges. So we have to add together various things, which we basically do by using market pricing, but we try to adjust for inflation. But it's a reasonable measure of how much the economy is producing.
And goods, sorry to interrupt, is it goods and services?
Goods and services, it's everything. Productivity is divide that total output by the number of hours worked. So we're basically asking how much stuff does the average worker produce in an hour of work. And if you're seeing really rapid technological progress, then you'd expect to see productivity rising at a rapid clip, which we did for the generation after World War II. Productivity rose 2% a year on a sustaining basis. Then it dropped down for a while. Then there was kind of a decade of fairly rapid growth from the mid-90s to the mid-2000s. And then it dropped off again, and it's not impressive right now. You're just not seeing an equitable shift in the economy.
So let me then ask you about the psychology of labor motivation. A few months ago, you wrote in the New York Times, quote, "The other day I found myself, as I often do, at a conference discussing lagging wages and soaring inequality. There was a lot of interesting discussion, but one thing that struck me was how many of the participants just assumed that robots are a big part of the problem. The machines are taking away the good jobs, or even jobs in general. For the most part, this wasn't even presented as a hypothesis, just as part of what everyone knows.
Yeah.
So why is maybe can you psychoanalyze the public intellectuals or economists or us actually, the general public, why this has happened? Why this assumption is just infiltrated public discourse?
There's a couple of things. One is that the particular technologies that are advancing now are ones that are a lot more visible to the chattering class. When you had when containerization did away with the jobs of longshoremen, well, not a whole lot of college professors are close friends with longshoremen, right? And so we see this one. Then there's a second thing, which is we just went through severe financial crisis and a period of very high unemployment that's finally come down. There's really no question that high unemployment was about macroeconomics, it was about a failure of demand. But macroeconomics is really non-intuitive. People just have a hard time wrapping their minds around it. And among other things, people have a hard time believing that something as trivial as, well, people just aren't spending enough can lead to the kind of mass misery that we saw in the 1930s, or the not quite so severe, but still serious misery that we saw after 2008. And there's always a tendency to say it must be something big, it must be technological change that means we don't need workers anymore. There was a lot of that in the 30s, and that same thing happened after 2008. The assumption that it has to be something, some deep cause, not something as trivial as a failure of investor confidence and inadequate monetary and physical response. And the last thing on wages, a lot of what's happened on wages is at some level political. The collapse of the union movement, it's policies that have squeezed workers' bargaining power, and for kind of obvious reasons, there are a lot of influential people who don't want to hear that story. They want it to be an inevitable force of nature. Technology has made it impossible to have people earn middle class wages, and they don't like the story that says actually no, it's kind of the political decisions that we made that have caused this income stagnation, and so they're a receptive audience for technological determinism.
So what comes first in your view, the economy or politics in terms of what has impact on the other?
Oh, everything interacts. And so one of the rules that I was taught in economics, everything affects everything else in at least two ways. But clearly the economy drives a lot of different stuff. But also clearly politics has a huge impact on the economy. We look at the decline of unions in America and say, well, the world has changed and unions don't have a role. But 2/3 of workers in Denmark are unionized. And Denmark has the same technology and faces the same global economy that we do. It's just a difference in political choices that leads to that difference. So I actually teach a course at CUNY called Economics of the Welfare State, which is about things like healthcare and retirement, and to some extent wage policy and so on. The message I keep on trying to drive home is that all advanced countries have got roughly equal competence. We all have the same technology, but we make very different choices. Not that America always makes the wrong choices. We do some things pretty well. Our retirement system is one of the better ones. But the point is that there's a huge amount of political choice involved in the shape of the economy.
What is a welfare state?
Well, the welfare state is the old term, but it basically refers to all the programs that are there to mitigate, if you like, the risks and injustices of the market economy. So in the U.S., the welfare state is Social Security, Medicare, Medicaid, minimum wages, food stamps.
When you say welfare state, my first sort of feeling is a negative.
Well,
Even though I probably generally, at least theoretically, like all the welfare programs.
Well, it's been demonized, and to some extent, I'm doing a little bit of thumbing my nose at all of that by just using the term welfare state. Although it's not.
I see. Yeah,
But every advanced country actually has a lot of welfare state within the U.S. I mean, that's a fundamental part of the fabric of our society. Social Security, Medicare, Medicaid are just things we take for granted as part of the scene. So there's a lot of people on the right wing who are, it's all socialism, and words I guess mean what you want them to mean. And we just today I told my class about the record that Ronald Reagan made in 1961, warning that Medicare would destroy American freedom, and but it sort of didn't happen.
On the topic of welfare state, what are your thoughts on universal basic income? And a sort of not a generic, but a universal safety net this time.
There's always a trade-off. When we talk about social safety net programs, there's always a trade-off between universality, which is clean but means that you're giving a lot of money to people who don't necessarily need it, and some kind of targeting, which makes it easier to get to deal with the crucial problems with limited resources, but both has its kind of political and I would say even psychological issues. So the great thing about Social Security and Medicare is no questions asked. You don't have to prove that you need them. It just comes. I didn't. If I'm on Medicare, they run through my New York Times health insurance, but I didn't have to file an application with the Medicare office to prove that I needed it. It just happened when I turned 65. That's good for dignity, and it's also good for the political support because everybody gets Medicare. On the other hand, if you and you can do that with healthcare, to give everybody a guarantee of an income that's enough to live on comfortably, that's a lot of money.
What about enough income to carry you over through difficult periods, like if you lose a job or that kind of?
Well, we have unemployment insurance, and I think our unemployment insurance is too short-lived and too stingy. It would be better to have a more comprehensive unemployment insurance benefit. But the trouble with something like universal basic income is that either the bar is set too low, so it's really not something you can live on, or it's an enormously expensive program. And so at this point, I think that we can do far better by building on the kinds of safety net programs we have. Food stamps, earned income tax credit. We should have a lot more family support policies. Those things can do a lot more to really diminish the amount of misery in this country. UBI is something that is being, it goes kind of hand in hand with this belief that the robots are going to take all of our jobs. And if that was really happening, then I might reconsider my views on UBI, but I don't see that happening.
So are you happy with discourse that's going on now in terms of politics? So you mentioned a few political candidates. Is the kind of thing going on both on Twitter and debates and the media, through the written word, through the spoken word? How do you assess the public discourse now in terms of politics?
We're in a fragmented world, so
More so than before.
more so than ever. So at this point, the public discourse that you see if Fox News is your principal news source is very different from the one you get if you read the New York Times. On the whole, my sense is that mainstream political reporting, policy reporting, is A, not too great, but B, better than it's ever been. Because when I first got into the pundit business, it was just awful. Lots of things just never got covered. And if things did get covered, it was always both sides. It's the line that comes back from me writing during the 2000 campaign was that if one of the candidates said that the Earth was flat, the headline would be "Views differ on shape of planet." I mean, that's less true. There's still a fair bit of that out there, but it's less true than there used to be. There are more people reporting, writing on policy issues who actually understand them than ever before. So though that's good, but I have how much the typical voter is actually informed, unclear. I mean, the Democratic debates, I'm hoping that we finally get down to not having 27 people on the stage or whatever it is they have. But But yeah, they're reasonably substantive. Certainly better than before. And while there's a lot of still theater criticism instead of actual analysis and reporting, it's not as totally dominant as in the past.
Can I ask maybe a dumb question, but from an open-minded perspective, when you know, people on the left and people on the right, I think view the others as sometimes complete idiots.
Yeah.
What do we do with that? You know, is it possible that the people on the right are correct about what they currently believe? Uh, is that kind of open-mindedness helpful, or is this division long-term productive for us to have this food fight?
Well, the trouble you have to confront is that there's a lot of stuff that just is false out there, and but commands extensive political allegiance. So the idea, well, both sides need to listen to each other respectfully. I'm happy to do that when there's a view that is worthy of respect, but a lot of stuff is not. And so take economics is something where I think I know something, and I'm not sure that I'm always right. In fact, I know I've been wrong plenty of times. But I think that there is a difference between economic views that are within the realm of we can actually have an interesting discussion, and those that are just crank doctrines or things that are purely being disseminated because people are being paid to disseminate them. So there are plenty of good, serious center-right economists that I'm happy to talk to. None of those center-right economists has any role in the Trump administration. And by and large, Republicans in Congress only want to listen to people who are cranks. And so I think it's being dishonest with my readers to pretend otherwise. There's no way I can reach out to people who think that reading Ayn Rand novels is how you learn about monetary economics.
Let me leave you on that point. So if you look at Ayn Rand, okay, so you said center right. What about extreme? The people who have like radical views, do you think they're not grounded in any kind of data, in any kind of valid? I'm just sort of curious about how open we should be to ideas that seem radical.
Oh, radical ideas is fine, but then you have to ask: is there some basis for the radicalism? And if it's something that is not grounded in anything, then, and particularly, by the way, if it's something that's been refuted by evidence again and again, and people just keep saying that it's a zombie idea, there's a lot of those out there, then there comes a point where it's not worth trying to fake respect for it.
So through the scientific process, you've shown that this idea does not hold water, but the zombie ideas, but they live on to, it's like the idea that the earth is flat, for example, has been, for the most part, disproven.
Yeah.
But it lives on actually in growing popularity.
Yeah, and there's a lot of that out there, and you can't wish it away, and you're not being fair to either yourself or if you're somebody who writes for the public, you're not being fair to your readers to pretend otherwise.
So, quantum mechanics is a strange theory, but it's testable, and so while being strange, it's widely accepted among physicists. How robust and testable are economics theories if we compare them to quantum mechanics and physics and so on?
Okay, economics is a complex system, and it's also one in which, by and large, you don't get to do experiments. And so economics is never going to be like quantum mechanics. That said, you get natural experiments, you get tests of rival doctrines. You know, in the immediate aftermath of the financial crisis, there was one style, one basic theory of macroeconomics, which ultimately goes back to John Maynard Keynes, that made a few predictions and said that under these circumstances, printing money will not be inflationary. Running big budget deficits will not cause a rise in interest rates. Slashing government spending, austerity policies will lead to depressions if tried. Other people had exactly the opposite predictions, and we had a fairly robust test. And one theory won: interest rates stayed low, inflation stayed low, austerity countries that implemented harsh austerity policies suffered severe economic downturns. Don't get much. That's pretty clear, and that's not going to be true on everything. But there's a lot of empirical. Younger economists these days are very heavily data based, and that's great. And I think that's the way to go.
What theories of economics is there currently a lot of disagreement about?
Oh, first of all, there's just a lot less disagreement among serious researchers in economics than people imagine. We can track that. Chicago Booth School has a panel, an ideologically diverse panel, and they regularly pose questions, and on most things there's a huge, there's remarkable consensus of things where people imagine that there's dispute, but the illusion of dispute is something that's basically being fed by political forces in this. There are, I think, questions about what are effective ways to regulate technology industries. We really don't know the answers there. There's I don't follow it every part. Minimum wages. I think there's pretty overwhelming evidence that a modest increase in the minimum wage from current levels would not have any noticeable adverse effect on jobs. But if you ask how high can it go, $12 seems pretty safe given what we know. 15 is 15 okay? There's some legitimate disagreement there. I think probably, but people have a point. 20, where is the line at which it starts to become a problem? And the answer is truly we don't know.
It's fascinating to try to such a cool economics is cool in that sense, because they're trying to predict something that hasn't been done before, the effects of something that hasn't been done before.
Yeah, you're going out of sample, and we have good reason to believe that there are that it's non-linear, that there comes a point at which it doesn't work the way it has in the past.
So, as an economist, how do you see science and technological innovation? When I various economics courses in college, technological innovation seemed like a no-brainer way of growing an economy, and we should invest in it aggressively. I may be biased, but it seemed like the various ways to grow an economy seems like the easiest way, especially long term. Is that correct? And if so, why aren't we doing it more?
Well, okay. The first question is, it's pretty much overwhelming. We think we can more or less measure this, although there are some assumptions involved. I think something like 70 to 80% of the growth in per capita income is basically the advance of knowledge. It's not just the crude accumulation of capital. It is the fact that we get smarter. A lot of that, by the way, is more prosaic kinds of technology. So I like to talk about things like containerization or an earlier period, the invention of the flat pack cardboard box. That had to be invented, and now all of your deliveries from Amazon are made possible by the existence of that technology. The web stuff is important too, but what would we do without cardboard boxes? So, but all of that stuff is really important in driving economic progress. Why don't we invest more? Why don't we invest more in more prosaic stuff? Why haven't we built another goddamn rail tunnel under the Hudson River, for which the need is so totally overwhelming and obvious.
How do you think about, first of all, I don't even know what the word mosaic means, but I inferred it, but how do you think about mosaic? Is it the really most basic technology innovation, or is it just like the lowest hanging fruit of what benefit do we gain?
When I say prosaic, I mean stuff that is not sexy and fancy and high tech. It's building bridges and tunnels, having inventing the cardboard box, or the I don't know, where do we put Easy Pass in there? That's it is actually using some modern technology and all that, but it's you're not going to have. I don't think you're going to make a movie about the guy, whoever it was that Easy Pass, but it's actually a pretty significant productivity booster.
To me, it always seemed like it's something that everybody should be able to agree on and just invest. So, like, in the same way, the investment in the military and the DoD is huge. So everyone kind of, not everyone, but there's a there's a there's an agreement amongst people that somehow that a large defense is important. It always seemed to me like that should be shifted towards, if you want to grow prosperity of the nation, you should be investing in knowledge. Yes, prosaic stuff, infrastructure, investing in infrastructure, and so on. I mean, sorry to linger on it, but do you have any intuition? Do you have a hope that changes? Do you have intuition why it's not changing? I'm
Oh,
clear
I have more
which
than
intuition.
intuition. I have a theory. I'm reasonably certain that I understand why we don't do it, and it's because we have a real values dispute about the welfare state, about how much the government should do to help the unfortunate. And politicians believe, probably right, that there's a kind of halo effect that surrounds any kind of government intervention. That even though providing people with enhanced Social Security benefits is really very different from building a tunnel under the Hudson River, politicians of both parties seem to believe that if the government is seen to be successful at doing one kind of thing, it will make people think more favorably on it doing other kinds of things. And so we have conservatives tend to be opposed to any kind of increase in government spending, except military, no matter how obviously a good idea it is, because they fear that it's the thin end of the wedge for bigger government in general. And to some extent, liberals tend to favor spending on these things, partly because they see it as a way of proving that government can do things well, and therefore it can turn to broader social goals. It clearly there's if you like, what you might have thought would be a technocratic discussion about government investment, both in research and in infrastructure, is contaminated by the fact that government is government and people link it to other government entities.
Perhaps a silly question, but as a species, we're currently working on venturing out into space, one day colonizing Mars. So, when we start a society on Mars from scratch, what political and economic system should it operate under?
Oh, I'm a big believer in. First of all, I don't think we're actually going to do that, but let's imagine, hypothesize that we colonize Mars or something. Look, representative democracy is
Versus pure democracy.
well, yeah, pure democracy where people vote directly on everything is really problematic because people don't have time to try and master every issue. I mean, we can see what government by referendum looks like. There's a lot of that in California, and it doesn't work so good because it's hard to explain to people what the various things they vote for may conflict. So, representative democracy is it's got lots of problems, and I kind of the Winston Churchill thing, right? It's the worst system we know, except for all the others.
But so yeah, sticking with representative and basically the American system of regulation and markets and the economy we have going on is a pretty good one from ours. If you start from scratch.
If you're gonna start from scratch, you wouldn't want a Senate where 65% of the population has half the seats. You probably would want one which is more representative than what we have. And the details, it's unclear. I mean, we when times are good, all of the various representative democracy systems, whether it's parliamentary democracies or a U.S. style system, whether you have a prime minister, head of state doesn't elect a president, they all kind of work well, and they all, when times are good, and they all have different modes of breakdown. So I'm not sure I know what the answer is, but something like that is, given what we've seen through history, it's the least bad system out there. I don't know. I'm a big fan of the TV series The Expanse, and it's kind of gratifying that out there it's the Martian Congressional Republic.
Okay. In a brief sense, so amongst many things, you're also an expert in international trade. What do you make of the complexity? So I can understand trade between two people, say two neighboring farmers. It seems pretty straightforward to me. But international, to start talking about nations and nations trading seems to be very complicated. So from a high level, why is it so complicated? What are all the different factors that weigh the objectives that need to be considered in international trade? And maybe feeding that into a question of do you have concerns about the two giants right now of the U.S. and China and the tension that's going on with the international trade there with the trade war?
Well, first of all, international trade is not really that different from trade among individuals. It's vastly more complex. There are many more players, but in the end, the reasons why countries trade are pretty much the same as the reasons why individuals trade. Countries trade because they're different and they can derive mutual advantage from concentrating on the things they do relatively well. And also, there are economies of scale. Not individuals have to decide whether to be a surgeon or an accountant. It's probably not a good idea to try and be both. And countries benefit from specializing just because of the inherent advantages of specialization. And that's so. The fact that it's a big world. They talk about millions of products being traded, and in today's world, often trade involves many stages. So that made in China iPhone is actually assembled from components that are made all over the world, but it doesn't really change the fundamentals all that much. There's a recurrent, the very little secret of international trade conflict is that actually it's not, conflicts among countries are really not that important. Most trade is beneficial to both sides and to both countries, but it has big impacts on the distribution of income within countries. So the growth of U.S. trade with China has made both U.S. and China richer, but it's been pretty bad for people who were employed in the North Carolina furniture industry, who did find that their jobs were displaced by a wave of imports from China. And so that's where the complexity comes in. Not at all clear to me. We have some real problems with China, although they don't really involve trade so much as things like respect for intellectual property. Not clear that those real problems that we do have with China have anything to do with the current trade war. The trade war seems to be driven instead by a fundamentally wrong notion that when we sell goods to China, that's good, and when we buy goods from China, that's bad, and that's misunderstanding the whole point.
Is trade with China in both directions a good thing?
Yeah, we would be poorer if it wasn't for it. But there are downsides, as there are for any economic shift. It's like new technology makes us richer, but often hurts some people. Trade with China makes us richer, but hurts some people. And, I wouldn't undo what's happened, but I wish we had had a better policy for supporting and compensating the losers from that growth.
So we live in a time of radicalization of political ideas, Twitter mobs, and so on. And yet here you are in the midst of it, both tweeting and writing in the New York Times articles, strong opinions, riding this chaotic wave of public discourse. Do you ever hesitate or feel a tinge of fear for exploring your ideas publicly and unapologetically?
Oh, I feel fear all the time. It's not too hard to imagine scenarios in which this has been. I might personally find myself kind of in the crosshairs, I mean, I am the king of hate mail. I get amazing correspondence. It did when it started. These days, I've developed a very thick skin, so I know I don't usually get. In fact, if I don't get a wave of hate mail after a column, then I probably wasted that day.
What do you make of that as a person who's putting ideas out there? If you look at the history of ideas, the way it works is you write about ideas, you put them out there. But now, when there's so much hate mail, so much division, what advice do you have for yourself and for others trying to have a discussion about ideas, difficult ideas?
Well, I don't know what advice for others. I mean, if for most economists, just do your research. That's we can't all be public intellectuals. We should try it. And in fact, I'm glad that I didn't get into this business until I was in my late 40s. And this is probably best to spend your decades of greatest intellectual flexibility addressing deep questions, not confronting Twitter mobs. And as for the rest, I think when you're writing about stuff, it's dance is like no one's watching, right? Like nobody's reading, right? So write what you think is right, trying to make it obviously trying to make it comprehensible and persuasive, but don't let yourself get intimidated by the fact that some people say nasty things. It's you can't do your job if you are worried about criticism.
Well, I think I speak for a lot of people saying that I hope that you keep dancing like nobody's watching on Twitter and New York Times and books. So, well, it's been an honor. Thanks so much for talking today. Thanks for listening to this conversation with Paul Krugman. And thank you to our presenting sponsor, Cash App. Download it and use code LETS PODCAST. You'll get $10. $10 will go to first. Organization that inspires and educates young minds and becomes